Greetings of the day to viewers of this video. Welcome back to ptscadexpert and myself, Architect Kumar Kapadia from the city of Surat in Gujarat. An humble request to the audience and the viewers of this video that thoroughly go through the explanation and introduction part before skipping to the main content of the video, that is the modeling part. So today's exercise is going to be all about modeling this residential G+2 villa here in Revit using the drafting skills with Revit with perfect precision and joint condition using the level of detail LOD 400, starting from the footing level to the topmost level, wherein we are going to take into consideration the architecture part, the structure part with reinforcement details, wherein I'm going to give you an insight, an overview of how to model rebar here in Revit. But this tutorial is not going to take into consideration the MVP part. So it is going to be very informative session. Kindly watch the entire tutorial till the end. And if you think that this particular tutorial was worth, then kindly enroll for this particular course, Master Diploma in Revit Complete Live BIM course, which is a combo of architecture plus structure plus MEP. Fine. So whenever we start the modeling of any structure in any software, specifically here talking about Revit, what we generally do, the process that we follow is that we import the AutoCAD drawings, the 2D footprints drawing of that particular structure, and then elevate the walls, starting from the footing level up to topmost level. But have you ever wondered that is that the correct method and the process of modeling? Then the answer is no. Revit is a very technical software and is meant for modeling of the 3D elements with perfect precision and joint condition, following the hierarchy and modeling of those elements exactly in the same manner. The structure is going to get elevated on site. That is, starting from footing level that have a particular column joined to a footing and joined to ground beams and joined to slab and the architectural elements. All of this structural elements, how are they joined to the architectural elements, that is the wall, with all its wrapping layers and joint condition, which eventually helps us generating the perfect schedules accurately, which helps us quantify the 3D element, giving us the perfect quantification of this particular 3D elements, which I'm not just going to show you, but I'm going to prove you with a couple of examples. So for in this case, I'm just going to take you to this particular simple exercise. This is just a simple structure, a G plus 2.5 simple structure. But if I just take you to the modeling part, let me just take you to the floor plans, ground floor plan. And you see that the modeling of this particular 3D elements is done with perfect precision and perfect joint condition, following each and every detail. Okay. For example, if I just take you to this particular section, then what do you notice is that this particular section highlights the detail and the manner in which this particular 3D elements are modeled following the perfect hierarchy. That is how is a column elevated from footing is joined to beam and floor, and how are all this structural element joined to wall. That is the architectural element along with its wrapping layers, wherein you see that these are the finished layers of a typical floor on an unfinished slab, whether it is PCC or RCC. At the same time, here too, you see that this is a wall. And if I just take you to the construction part of this particular wall, then you see that this is the core structure, which is then followed by plaster on either side. Right now, just to simplify, I have taken half 12 mm plaster on both the sides, but the exterior side follows 19 mm. There is 3/4 of a plaster, and interior is 12 mm. That's fine. And if I just take you to this detail, This is a typical detail of a drop slab. Of course, there will not be a drop slab on ground floor. That's the ground floor, and there will not be a drop slab on the ground floor because it is directly connected to ground. Drop slab. The purpose of drop slab is to provide the waterproofing in order to avoid the external effects of weather and rainfall. So for that purpose, if I just take you to this particular family, this assembly, floor assembly, if I just go to edit, then you see that this is the formation of that particular assembly. When you see, this is the layer of brick beds. It has various layers, followed by sand bedding or PCC, which is used to perfectly create a layer, a fine and finished layer, then followed by the 12 mortar, which is then followed by the finishing tile. That might differ from designer to designer and floor to floor. But I have just taken into consideration the ideal and generic family formation. Okay, and just like that, on all the other different, for example, this is a upper floor, typical floor slab. This will be PCC. If this is on the ground, then this will be PCC, layer of PCC, which actually ideally doesn't need the layer of brick bed because it is directly connected with the ground. But the topmost layer does. The top layer do need. So that's why they have been provided with the same layers. Okay. So this is the ideal prototype, which might differ from design to designer. Okay. And from floor to floor, as I said. And also, if I talk about the modeling of other 3D elements, for example, if I just talk about this particular one wall, then in section, what do you notice is that the base constraint is ground and the top constraint is first floor with the negative offset, top offset of 18 inches. That is, it is excluding the beam depth. So, and the same way, this particular wall has been modeled here in plan also, exactly following the footprints of the floor plan, of the AutoCAD floor plan. And for this particular beam, you see that there is another wall, beam wall model, which discounts the masonry parts and only wraps the layer of plaster to it. And all the other 3D elements are also modeled in the same way with same level of detail. So you might be wondering that what is the reason of modeling with this precision and with this accuracy here in Revit. You see, this is the rebar details, which is I'm just going to cover for the first time in this particular tutorial. Yes, so coming to the point that what is the need of modeling with this precision and this detail here in Revit? So the reason is that with this you will be able to perfectly generate different type of schedules, which would give us the perfect quantification of the 3D elements and its costing, which I am just going to prove you with the another simple example. That is, you see that this is just a small cube of 3 cross 3. But if I just take you to this particular schedule part, and if I just have a side by side view, a tile view, then what do you notice is that you see that this particular two walls, the area it is reading is 3 point, the width is 3.52 and the height of that particular wall is exactly 3 meters. It is a cube of 3 cross 3 cross 3. So 3.52 cross 3. So that will give the perfect area of 10.56 meters square. And likewise, the other walls are exactly 3 meters in length and 3 meters in height. So that is giving this area 9 cross 9. And with that, you see that we have all these details established here. For example, you see that this is the costing of 2 brick thick masonry. In my neighborhood, might differ in your neighborhood, but that gives the costing of masonry, cost of masonry for that particular one wall with the number of bricks. That would be precise enough than manually calculating it on a calculator. So this is the reason. At the same time, it also gives, you see, this is a multi-category material takeoff. So it gives the quantity of all the materials that has been used in this particular project. There is the plaster, then main wall 9 inch, then there's a beam wall paint, etc. Fine. Concrete cast in place gray and quantity of that, from which I can just have take out the quantity of plaster. So this gives us the quantity of entire plaster used in the project. So that is the whole purpose of using this particular software. And if you cannot draw and model with this precision and this joint condition and this accuracy from day one, then there is no point using this particular software. So now I'm just going to give you an overview and insight of that what all details you can generate while working and modeling with this particular software Autodesk Revit. So the 3D interface you already are going to witness in the modeling part in the later part of the tutorial when we'll model this particular entire structure. But as I've been always saying that Revit is not only about modeling the 3D part, but it also very efficiently models the 2D part. That is the different types of drawings, the 2D drawings that are used for its execution on site. At the same time, the 2D part is also divided into two parts. There is one first part is the generation of different sets of drawing of different disciplines, and another part pertains to its quantification. So you see that this is the different sets of drawing, wherein you see that for the first time, as I said, I have also modeled the rebar for this particular project. You see that these are the reinforcement details floor plan for this particular ground floor. Then this is the structural plans. Then let's switch to presentation floor plans. So this is the entire site plan showing all the details from top. This is a typical presentation floor plan, plinth floor, and the working set of the same drawing. You see that this is the working drawing of the same floor, wherein all the details have been incorporated. At the same time, you see that this is a 3D model showing the reinforcement details for that entire project. Let me just press VV filters, and if I just say that apply and OK, now what you will watch is that how is a structure elevated, footing, tie beams, column neck, then we have this retaining wall and ground floor PCC, ground floor beams, plinth floor PCC, and the staircase as well. You see, the reinforcement of a typical staircase. Okay. Likewise, you have this couple of other 3D views. For example, this is an exploded view, which shows the parts and pieces of a typical sloping roof with all its necessary components. Then we have this exterior view. Revit is not a rendering software. Revit is a technical software, but you can render such views, temporary views, here in Revit. Likewise, we also have interior views. Then these are the different disciplines. This is the different disciplines showing the elevations with different visual styles and different details. Then we have the south elevation, Then we have this vest. Also, we have the sections, presentation sections. Okay, fine. So you can generate such drawings here in Revit. Also, I'll just go to the rendering part. So if I just take you to a particular view, this is that particular same view which I showed you, but I have rendered this particular view. So let me bring to your notice that Revit is not a rendering software. You might have already seen in the introduction the beautiful animation that I created using Lumion. And we have a lot of other render engines, Lumion, Enscape, Blender, D5. But Revit is not a rendering software. It is a technical software. We can generate much better rendering views and animations using plugins, which you already saw in the animation. Here, we can also generate such. You can just temporarily create this particular view just to show your client. But we can also create such details like the solar study, the impact of sun on your entire site from sunrise to sunset in different disciplines also. See, this the earlier one was in hidden line, and this is in realistic. Okay. Also the hidden in hidden style also you can generate the interior view rendering which shows the impact of sun on your site from sunrise to sunset. Okay. So if you want to generate renderings in Revit, then it is very time consuming and waste of time. And as I said, there are much better options than that. Coming to the detail part, we as the designers are working on AutoCAD since years and have a lot of details already established on AutoCAD. So you see that you can also, once your detail is modeled in AutoCAD, you can also bring here in Revit and take a printout of that into your preferred scale. So this is the area gross building plan. Certain designers are interested in calculation and analysis of different spaces, that what is the ratio of privacies to public, semi-private, utility, hardscape, circulation, etc. So it provides this also. Then we have this graphical column schedule. Then we have the legends. And at the same time, we have this beautiful schedules, which you see that provides a lot of details. Manufacturer, fire rating, costing. So that gives us a costing of all the doors in your entire project, floor wise. Just like that, we have this room schedule, window schedule, wall schedule, wall material takeoff, plaster, which gives the quantity of plaster in your project. And at the end, we have this sheet composition. Of course, the designer will never issue the sheet in this format, but just to show you that drawings of different disciplines and different scales can be compiled together here in Revit. These are the elevations, these are the sections, these are the different details, and likewise so on. One more feature which I would like to bring to your notice is that while working with Revit, you can also create design options. For example, I just drop in. This is the sloping roof option. Let me just say that I want the straight roof option. Then you see it has switched to this particular straight roof option. Clear? This doesn't only pertains to the 3D part, but also to the 2D part. For example, if I just take you to this particular plain floor plan, then you see that this is the configuration of furniture, the furniture layout for this option, option A, which is the primary option. But let's say that you want to create another configuration, then just switch to option B. So that will give you a different option with different 3D elements and different configuration. Okay, so that was all about the various features and functions of working with this particular software, Autodesk Revit. So with this, now let's start with the modeling part of this particular G+2 residential villa. So first, let me just hide the sites and the assets, surrounding assets. And for this particular tutorial, we are just going to take into consideration the straight roof option. So I'll just switch to this particular straight roof option. Yes, so this is that particular option. And I will just keep this particular file open for reference. So while modeling to and fro, we can have a reference of this particular file. Okay, so now for the new project, using the features and functions of Revit, if I just go to File, New, and Project, I'll open up a fresh new architectural template, default architectural template, and okay. So using the features and functions of Revit, you can just go to this particular Manage tab, and using this particular Transfer Project Standards, you can just copy all the details from a existing project, that is the wall type, floor types, curtain wall types, materials, everything, which I have already done just to save time. So we can concentrate on the modeling part. So the first step that follows, this is a fresh new project which doesn't have anything modeled yet, but has all the details transferred from that particular project. So the first step that follows is that we have to insert the AutoCAD drawing. So let me just first acquaint you with this particular AutoCAD drawing of this particular project. So you see that this is the entire site layout, ground floor layout, and these are the floor plans, first floor and second floor, and this is the structural drawing. And let me just bring to your notice that we, as I said in the introduction, we are just going to take into consideration the structure part also, along with the reinforcement details. So all the structural considerations regarding the sizes of this particular structural elements, its location, and everything will be pretty much basic and conventional. And the exact size and exact design will be um, decided by the structural engineer. Fine, but the only motive is that I want to just make you guys acquaint that how can we incorporate structure while modeling an architectural project. Okay, so you see that herein this are couple of footings, different types of footings. This is a step. This is the step footing. This is a combined footing, and this is the load bearing wall, which is hosting the strip footing. Okay, this is the water body, swimming pool, and water body, and this is the basic isolated footing with the location of column. Okay, so we are just going to transfer, insert this particular drawings, and I've already bifurcated that particular drawing. Don't worry, you will get this particular AutoCAD drawings. So I'll just go to insert and import CAD, and if I just navigate to that particular location, yes, I'm already there, and I have bifurcated this particular drawings according to the different floor levels. So first is that followed is the footing drawing. Okay. So if this particular drawing is in feet inches, that is an imperial system, the import units, colors preserved, layers all, and the import unit should be essentially inch and manual center, and I'll just open. So that is how I have brought the AutoCAD drawing here in Revit. And I'll just go to VG and import units, and I'll just turn this to half tone, apply and OK. So with this now, the first step. So with this now, let's first create the different levels of this particular project. So I'll just go to south elevation, and herein I will call this ground uh, ground road level. Yes, and I just click LL. You can click it from, you can access it from here also. LL, and I just check this particular create plan views. And with this, I will just say that pick lines. And with pick lines, with the 10 feet, with the offset of 4 feet 6 inches, I will create one level. Okay, and that would be footing bottom. Yes, again, I will create one more level with this particular create plan views checked on, and that would be at the offset of 2 feet from this particular level. Okay, and that would be footing top. Yes, rename in corresponding views. So you see that the views are getting renamed over here, created and getting renamed. Level 2. Now this is going to be the plinth level. Plinth level. Yes. And I will just bring this particular level at 2 feet. Let me just change the view scale in order to properly visualize this. Yes. LL, pick lines and create plan views with the offset of 10 foot. I will create one level and one more. So this would be first floor. This would be terrace, and the last I forgot, pick, and with create plan views checked on. This would be slab top. Slab top. Uh-oh, sorry, too fast. Yes. So now you see that all the levels has been created within this different disciplines. And we also have this structural plan. And within this structural plan, there are a couple of views missing. I'll just go to the particular view tab, and under plan views, I'll click the structural plan. And for this, the ground level and plinth level was missing. I'll just create that particular views. Now you see that this particular floor plans created do not follow the hierarchy as per the level. So for that purpose, what I'll do is that I'll just click this browser organization, and from all, I'll just create this. I have already created that. So this is the file with all the levels created, with all the details created. So you have to create this new and by level. So I will just go to this particular by level and go to edit. And herein, I'll just come to this particular grouping and sorting, and should group by family and type and sort by associated level. And I'll just click OK, and I'll check this box and just say that apply and OK. So the now the floor plans will follow the hierarchy of height, except for this particular site plan floating somewhere under this floor plans category. That's okay. So let's select this particular drawing and just snap it to footing top. Close this particular drawing level and snap to structural plans, and under that go to footing top. Okay, and just go to VG, import categories, and turn this to half-tone footing drawing. So herein we are going to start the placement of different types of footing. So I'll just go to structure, and first is this particular isolated footing. So if I just click this particular isolated footing, you already have this particular different types of sizes according to my design already modeled. So in your case, if you don't find this particular thing, then just go to load family and navigate to that particular location, program data Autodesk RT 2026. And under that, you have this particular folder libraries, which has all the 3D elements necessary for the modeling incorporated there. So I will just go to this particular structural foundations, and you have this different types of foundations already loaded over here, from which I have selected this particular footing rectangular, loaded it into the project, and while going to edit type, I have duplicated it and created different sizes as per my design. So from that, first is that we are just going to load this particular 2 feet 9 inches cross 3 foot 6 inches, which is this footing, right? Now, I will just show you one function and feature of Revit that if all your footings are following the same alignment and orientation, then how can you use this particular function grid function, which doesn't only limits up to placement of the center line or face line in Revit, but I will just create this particular grid lines. Let me call it A and CO and copy it from this point to this point. Select this, snap, drag it, and GR. I will create grid on this face as well. CO, copy it from this different footings. Again, select this and drag it all the way. Fine. So with this now, if I just go to structure and isolated footing, this size 2 feet 9 inches cross 3 foot 6 inches, then you have this one function at grid intersection. Okay. So in your case, this particular offset parameter would be 0. But since I know that the foundation thickness is 2 feet and I want to see that particular footing on this particular designated footing top level when I place that footing, so I need to give it a height offset of 2 feet. If I just change this particular thing to 0 and if I place this, then too, in my case, you are able to visualize it because the view range has been set accordingly. But you might not be able to visualize that. So in order to visualize this particular footing, you just need to give it a height offset equals to the thickness. Whatever is the thickness of this particular foundation, you need to give it a height offset parameter. Okay, so I'll just delete this particular thing and isolated footing and at grid intersection, and I will just make a cross window. So you see that all the footings on that particular intersection of grid lines has been placed, and I'll just say that finish. But I forgot to change this height of that level. So you see, fine. So you see, you're not able to visualize those particular footings. So I'll just click undo. Again, I'll click this particular height of that level and just give it a height offset of 2 feet and just make a cross window. So with that, I'll just say that finish. And now you are able to see those particular footings on that designated level. And herein, I'll just select this and see you and copy this, which is not falling at the grid intersection. Okay, now these are the same footings, but with a different orientation. So I need to just say that CEO copy, select this and just click space. So that will revert the direction, move it from this point to, and just press tab if you cannot find the snap point, or if not necessary, you can just go to modify and use this particular align tool. Align this face with this and this with this. And with this now, I'll just say that CEO copy 1 to 2. Okay, and we have this same type of footing here as well. I will just copy this footing 1 to 2 and press tab until you find the snap point. Also this CO, copy it from here to here. And here this are the bigger sizes of the footing. So I will just go to structure and isolated footing. And from this, I will just select this particular 5 cross 5 6 and just click space. Okay, place it somewhere. And in order to avoid any error, just use this align tool and snap it. And CO and copy it from this point to this point again. Yeah. And this is a combined footing. So structure, isolated, and here is the size 8 foot cross 18 3. And just press space and place it somewhere. And then just go to modify and align the faces. So this is how we have placed all the isolated and combined footing. Next is that we need to create columns onto this particular footings. We need to hold the columns onto this footing. So for this particular different footings, I will just go to structure and you have this structural column. Again, I have already designed this particular 11 cross 9 cross 18 and 12 cross 18. Where I have loaded it from? The same location, load family. And under that, instead of structural foundation, now you will look for structural columns. And under that, you have different categories like gauge, precast, steel, wood. We will go to concrete, and you have this concrete rectangular column. Just load it from this location, and just after bringing it, just go to edit type and duplicate, and just change the sizes, breadth, and height. So for 9 cross 12, I'll just make this particular cross window, and let me first check its constraints. Yeah, so see, this instance parameter is set to depth. I'll just change it to height. And I want to bring it right now only up till ground road level. And just make a or grid and intersection. So you see that all the columns are hosted. And just make that finish. So it will say that an attached structural foundation will be moved to the bottom of the column. And that's technically correct. Okay, so if I just take this particular south elevation, then now you can see that earlier, if I just click undo, this particular columns were putting up at this level, that is footing top. With that column's place, I'll just click redo, and now this particular footings are moved to its location, that is footing bottom. Clear? Fine. So now we need to create the columns for this different footings. So I will just say that, or actually, what we can do is that, let me just click column and wireframe. Mm, what if I want to move this? Yeah, I just say that CEO, copy this particular thing, copy it from this place to place. Yes, that's perfectly fine. Here too, and this also follows the same orientation. And here, this particular columns are following different orientation. So I will just flip the direction and move it from this point to move and enter. Find the snap point and select this CEO 1, 2, and here also there is 1, 3. I hate this ugly sound, but that's okay. We also have 4 over here. 1, 2, and find the snap point by pressing tab and 4. So all the columns have been placed. Now these are the bigger columns with bigger size. The reason of this, you will understand, you will figure out in the later part of the modeling. Right now, I'll just go to structure and column, and I'll just select this bigger size, 12 cross 18, wherein the breadth has been changed to 1 feet. Okay. And with this, I will again change the height and ground level. That's fine, but I'm not able to. Yeah, okay. So move it from M enter. Yes, okay. And CEO, copy it from here to here as well. Fine. So we have placed all the columns, but one column is left here, CO, and copy it from here to here. Okay. So we have placed all the columns. Now what's remaining is to create this particular step footing and place columns there. Now there is a different way how to create this particular step footing here in Revit. So here, I'll just use this part because if I just go to architectural tab, structure tab, you don't have this, you have this isolated footing, you have the structural wall foundation, that is a foundation hosted by wall, you have this structural slab, but you don't have the step footing. So how to create that particular step footing here in Revit? So I'm just going to use a different function for that particular thing. For that purpose, I'll just strike one simple section over here. Oh, sorry. Yes. And I'll just go to architecture and component and model in place. And from that, I'll just select this structural foundations. Yes. Okay. I'm just going to name it step footing. Step footing. Yes. And I'm just going to use this particular different tools in order to create that particular footing, for which I'll just first use this extrusion. Apply it a material, and which material? I will just click this button and navigate to that particular folder. And you see that I have even all the materials copied from that particular file using transfer project standards. Okay, definitely during the later part of the modeling part, I will just show you how to create this particular materials and how to use this existing materials that are provided by Revit, and also how to use this asset library, asset browser. But right now, I'm just going to assign it the material of concrete cast in place gray. Yes, so this is the material, wherein this is the JPEG image, the matte which has been applied to that, and the graphics, if you see that this is the cut pattern, concrete cut pattern applied to that particular material. So I'm just going to use that. Yes. So with that, I'm just first going to create a simple extrusion starting from extrusion start 0 and extrusion end 3 foot. And on that particular footing top level, I'm just going to create one extrusion and just finish. Actually, this was supposed to be created not on footing top. I'll just go to edit work plane and just snap it to footing bottom. Okay, so it will disappear from here. Let me just go to footing bottom. Yeah, fine. Here it's here. I will just turn this RP. I'll draw a reference plane, and then I'll just say that uh, still in drafting mode. And now I'm just going to create a void, a sweep void, in order to create that particular footing. So just say that create, and under void form, I'm just going to use this void sweep, void sketch path, and this is going to be the path rectangle. Yes. So here we can host a profile. So I'll just say that finish. Select profile, edit profile, and go to this particular section 1, which I have created. And from there, I'll just go this 2 feet, not 2 feet, fine, just 2 feet. I can come 1 feet down. Again, I will come 2 feet, 1 feet, sorry, 1 feet down, and I will create this. Okay, and just go to 3D and see that what is the modeling says. So the white sweep command says that it deducts something along a path, a mentioned path, selected path. So we have selected this as the path, sketch path. This is the path. And here is the profile that I have hosted. So what is the profile? This is the profile which I want to deduct along that particular path. And I'll just say that finish and finish and just click. So you see that that is how we have created our step footing using the functions and features of Revit and the modeling skills. With this, I'll just say that finish. So we have created all this different types of footing. Also, I need to host a column over there. So let me just go to footing top, select this particular column, footing top, and select this particular column and CO, and copy it from this portion to this portion, and this part to this part. And let me just check in 3D whether it has been hosted properly or not. It's footing top, and yeah. So you need to bring this particular column, in this case, up till this particular level, the top of this particular footing. So I will just select this particular column, wireframe, and move it from this point, constrain, uncheck this join check, move it from this point to this point. Yeah, that's fine. Okay, CC, consistent colors, which you can change the different visual styles from here. That is, I have entered the shortcuts here, view, user interface, and keyboard shortcuts, and my preferred shortcuts I have entered. So now what next is that we, where is this column? Ground road level. Yeah, fine. Are they putting up to ground road level? Let me just check. Grid lines, I guess that I have closed. I'm not. Just close this. South elevation. Yeah, they are putting up to ground road level. Here, for this particular one column, two columns, I guess that I'm able to join, modify. If I bring this column from here to here, constrain and check and join. Yeah, fine. Okay. So that was the better way of doing that particular thing. I'll hide this, select this particular column and join that also. So at least the top of all the columns are same. Okay, fine. If I just turn on this bulb, yeah, see here are the grid lines which are not visible. Okay, let's keep it hidden only. Level lines, not grid lines, sorry. Those were the level lines. I'll turn this AutoCAD drawing here in 3D also to halftone, apply and okay. So now what we have to do next is that we have to create this particular uh, other different footings. For example, if you just take to this particular AutoCAD drawing on footing, where was the AutoCAD drawing? My bad. Where did the AutoCAD drawing go? Footing top. Yeah, so I should be able to visualize here. Yeah, footing top. Okay. So you see that here, this is the water body. We have a living room floating on this particular water body, and this is a swimming pool. So we need to create, and this is essentially a load bearing wall, which is hosted with a strip footing. So first let's create that. So I'll just go to wall, and herein you have this one wall, load bearing. Where is it? I cannot find the load bearing wall. Yeah, here it is. See, load bearing wall, 15-inch, edit type, edit, and it is 15-inch thickness. And if I just go to this particular, it has been applied this particular material, structural stone material. This, this is the existing material of Revit, which I have applied from this asset browser appearance, and from this any of this particular field, I have applied that particular material to that particular structural stone. Okay, so since this is going to be the load bearing wall, I'm just going to say that apply and okay, and I will just call this footing top, and let me just check once in that particular file for which I have kept that particular file open in order to just let me just go to south elevation, and what is the base of this particular load bearing wall? Footing bottom and base offset 2 feet. Okay, footing bottom. So this is the strip footing has been loaded, and the work plane of this. Okay, fine. We will just, but the essentially all of this particular footings should be the base of all this particular footing should be same. We just need to keep a check of that. So I will just say that I want this at footing bottom, and just create this particular rectangle, and from footing bottom till first floor. Right now, let's just snap it to ground floor. Later, we will just change it. Create that particular wall. Yes. So that is how we have created this particular structural wall. R enter. If I just change this particular visibility to realistic. So this is that particular load bearing wall. Now we need to host the strip footing onto that. So this is that footing top. Let me just come here to structure, and this is the structural wall foundations. creates a foundation that is hosted by wall. Okay, so I will just click this and I have already the different types of structural foundations. The strip footing I've already created. So this particular thing, I guess, is that it's 3 cross 3. Let me just check. Yeah, see, so 3 foot 3 inches, and its height should essentially is 2 feet. Its depth is 2 feet. So I'll just click this, and with this, I'll just select this 1, 2, 3, and 4. So with this now, if I just go to 3D, so you see that that particular four walls has been hosted with that particular strip footing. Clear? Let me just check here in south elevation. Where did it go? So here is wrong. So here the base constraint should be footing top and footing top. And with this, I guess that I need to load that particular four footings again. Load bearing wall, 3D, 1, 2, 3. By mistake, I deleted this wall also. I just need to delete this footing. And all the four walls, press one wall and press tab, select all the four walls, and the base constraint should be footing top. Yes. And with that, I'll just go to this particular and select that particular wall foundation. This is the width, this is the foundation thickness, and this is the material. So with that, I'll just select this 1, 2, 3, and 4 walls and create that particular footing. And with that, I'll just go to south elevation. Now you see that base of all the footings are same. What is left within this particular footing is to create this particular strip footing for this particular water body and swimming pool. So you see that, let me just take you to this particular AutoCAD drawing. So here, this again, this four walls of swimming pool and of this particular water body. This particular four walls will be the retaining wall, which will retain the lateral pressure of the soil. The exact design, structural design, will be given by the engineer, but right now we will just take into consideration that this is a retaining wall which is hosted with this strip footing. Okay, and here this is 9 inch is the eccentricity. So this four and this four are the retaining wall. So I will just come here, and again this particular four walls will be hosted on footing top. So let me just go to walls, and I have already that particular wall design. Let me just look for it. Retaining, yeah, retaining wall, 12-inch concrete. Okay, edit and edit. But the thickness of this is 9 inch only. So let me just check in that particular project that which wall is that. This is RCC wall 9 inch. Okay, so the retaining wall, I guess, is that this is also the RCC wall. So where is the retaining wall created and used? This is compound wall. Okay, fine. So this is, I just click wall, and this is RCC 9 inch wall, edit, edit. And the thickness is 9 inch and wall concrete texture. This is the material that has been applied to this. Okay, and the graphics follows the cut pattern of the concrete, wall concrete texture. So again, I will just select this particular rectangle and footing top, upper ground level right now, and just create that particular wall here as well as here. So this wall will split at this location. I'll just bring this over here and bring this over here. Now I need to host the strip footing to this particular concrete wall, this retaining walls. So again, I'll go to footing top and come here to structure. And under that, you have the structural wall foundation. But this time, the size of this would be 1 feet 6 inches cross 2 feet. And I'll just select this 1, 2, 3, and 4. 1, 2, 3, and 4, and this 2. Now, I want this particular face to be flushed. For example, right now you see that this particular footing is offsetted. That's fine in this condition. But here I want a flush face. If I want a flush face for this particular strip footing, then you see that in footing top, if you just measure this, you have this 4.5. Just select this particular strip footing SA, select one and just press SA. That will select all the families of that particular similar type and just give it a eccentricity of 4.5 inch. Negative, I guess. Yes. So now you can see that the particular wall has been hosted with a strip footing. Let me just check here in south elevation. Yeah, fine. It's perfect. Now I need to create the tie beams for this particular foundations. Tie beams at this level. Now again, the location of the tie beams, whether it is at this point or the bottom of the footing, that is again a structural concern, will be decided by the structural engineer. But right now, we will just follow the ideal modeling process. So I will just go to footing bottom in this case, but we have the sorry drawing here on footing top. So let's place it here as well. I will just HC and hide this particular grid lines. So here I'll just go to structure and you have this beams. Under that, you have this concrete rectangular beam. Again, you have to load it from the same location, but this time it would not be structural foundations, it would not be structural column, but it would be structural framing. Because for beam, the terminology that has been used by Revit is framing, structural framing. Okay, concrete rectangular beams. So, and once loaded, you can just go to edit and mention your required size. For example, for this particular tie beams, I have given it 9-inch cross 12-inch, wherein 9 inch is the breadth and 1 feet is the height. I'll just pick, and here you have this Y justification. I'll just click this. Yeah, fine. So that is perfect. So with that one snapped, I will just take it all the way till this point for this column. Again, I'll just select this and CS, that is create similar. You can see create similar. The shortcut to that is CS. Create similar and snap it. But this time the location would be right. Oh, sorry, right. And then again snap it to this column. Select this particular beam, move it from this column to this column, from here to here. So that how you have placed CO, one more, from here to here. Fine. Now I need to place it here. So CS and snap it from this to this. Oh, center. Left. So pick, yeah, 1 and 2, 3, sorry. And again, this also. So here we can just snap this CS and pick lines, whether left or right. That's, we have to cross check. Snap it here and bring this all the way till No, from here the orientation of the beam, the direction of the beam changes. Here it's fine. Here you can snap it, but here I will just change this. Pick lines and with left. Yeah, fine. So that is how CS and pick 1 and 2, 3. Here, select this and just click space, or you cannot click space in case of beams. You just have to, yeah, fine. And here I can continue this. Okay. Here too, I have to continue this. The tie beams are provided to avoid buckling and staggering. So we have provided all the tie beams. Perfect. Clear? This particular part, I suppose I need to check here in this particular project. Let me just go to structure, 3D and 3D structure. Yeah. Let me just select this particular reinforcement and height category. We are going to learn this also, how to create reinforcement. And VV, filters, hide all of them, apply, just turn on footings. Yes. Okay, so this seems joined to this particular, yeah, this wall bearing footing is joined to this footing. Yeah, this wall bearing footing is joined to this footing. Yeah, so in this case, I guess that this particular thing will go up till this point. Yeah, this wall. Yeah, the retaining wall. Okay, rest everything is perfect and no issues. Just let me check here. Okay, fine. It's perfectly fine. So as I said, the location of this particular beam, tie beam, will be decided by the structural engineer. It can be here also. I will just select all of them and just say that edit work plane and footing top. I'll just change it to footing bottom. No, select all of them and just give it a Z offset value of 1 feet, -1 feet. Yeah, fine. So I'm just considering this option, which might be true or might not be. Usually it is provided at this location, but I'm just following an ideal situation, considering ideal situation. Okay. And yeah, fine. Perfect everything so far. One thing which we forgot was that we need to create a layer of PCC along this particular different footings. Also, let me just check that whether this footing, this, I need to check here, I guess. Yeah, see, here the eccentricity has been retained. Okay, fine, doesn't matter. Perfect. So, what I was saying was, yeah. So for the structural concern says that if I just take you to this particular project and here 3D structure, you see that there is a layer of PCC on that particular ground. Let's lay this particular this strip footing for this particular compound wall also. What is the height of the constraints of compound wall? Ground floor and unconnected height 8 inch. That is hosted with this particular strip footing, which is 2 feet, 2 cross 2. On the bottom of that, there is a layer of PCC. So first, let's create the compound wall on ground floor, ground road level, but I cannot see the AutoCAD drawing. Okay, the AutoCAD drawing is here, putting up at this particular level, but that's the footing drawing. So what we'll do is that we will take a reference point, common reference point, and snap this to edit work plane and snap this to ground road level. And what we will do is that we will go to ground road level and bring the ground floor layout, this particular AutoCAD drawing, this ground floor layout in that particular Revit file. So let's go to insert and let's say that import CAD and ground floor layout, inch and manual center. That's fine. And I will just put it. Okay. And I will snap this point to this location. So the AutoCAD drawing will be properly positioned in its place. And I'll just go to VG imported categories and turn this to halftone as well. Okay. And now let's snap the compound wall. So I'll just say that wall. And here is the compound wall, edit type. If I just go to its properties, then here is its 1 feet 1 inches. And this is the material that have been applied to it. This is the custom material. You can load any material, that's not important. Okay, and apply and okay. And with that, I'll just say that ground road level and unconnected. It should not snap to any of the level, but it should have an unconnected height of 8 feet. That's fine. And with this, I'll just create that particular compound wall. Click, pick lines, pick this, sorry, wall, and draw from with core face exterior, and pick, yes, again line, and start from this point. Okay, pick, and again line, and start from this point. Okay, and pick. It should select the center. Yeah. Okay. And from here, just continue up till this point and stop. And again, start from this point and pick and yeah, snap it. Okay. So this is how we have hosted the compound wall. Now we need to host the strip footing for that. So I will just go to structure and wall footing, but this time 2x2. So this will be the strip footing that was hosted by wall foundation, structure, and this. See, structure of foundation, create the foundation hosted by wall. So I will just create this 1, 2, 3, and every time it is going to pop up that ugly sound. And this, and this. And here we created, I guess, yes, 3D. Yeah, fine. I'll just go to footing bottom, but I cannot visualize. Neither in footing top. No, in footing top. Oh, so this is left. This is left. So I just say that CS, come here to ground level and create this as well. Footing top. Yeah, fine. So what is the eccentricity? That is 6 inches. So select one, SA. Select all of them and just say that eccentricity to minus 6 inches. Not changing. Maybe minus 5.5 inches. Yeah. And for this, I will select, it might happen in some case, it might, so you need to revert and just say that positive. Yeah, fine. Okay, so the strip footing has been hosted. I will just select this and join this to this and go to 3D. Okay, so the compound wall has been created with that particular strip footing hosted. Let's move further. Now, since we have, okay, let me check whether I've turned this, let this turn to half tone as well. Fine, so that might not distract us for the modeling part. So now the next part that we have to create is that on ground road level, we have to create the base plate, the PCC plate. Let's assume that the back soil filling is done, the compaction has been done, and we need to create a base plate and then further process with the modeling part. So in that case, what I'm just going to use that just in order to save time, what I can do is that I cannot copy between different projects, between different, because there are two different Revit open, Revit interface. So what if I want to copy certain things from this, for example, the footprints of this particular floor plate. If I just go to 3D structure, I'll come to VV filters and I want to copy this. We have created so much. I need to create the base plate for this particular water body and the swimming pool that I will create, but ground floor PCC. You see that I don't want to waste time drafting this footprints. So I cannot edit boundary and copy this particular footprints because these are two different Revit interface. So what I will do is that in order to copy this detail, I will just open up this particular file here. So file and open up that particular file. It will prompt me a message that that particular file is open somewhere else and it can be opened only as a read-only file. Oh, didn't pop up. Which is that particular file? Oh, sorry, we opened the wrong file. Just okay, but this is also fine. There is no issue with this. This is the same file. So what I will do is that I'll just go to structural plan and oh, sorry, not structural plan, structural 3D structure. Yeah, fine. And just hide in view by category reinforcement. Okay, and VV filters, slap top, uncheck all. Just turn on this so many layers up till ground floor. Okay. So with that, now what I can do is that you see that right now this particular floor plate 6-inch swimming pool and water body concrete slab. If I just go to edit type, it is nothing but just a simple floor of 6-inch, which you will find in our drawing also, the one which we are doing right now. I will just first create this particular floor plate on footing bottom and just select the structure and floor, floor structure and 6-inch swimming pool and water body concrete slab. Fine. And just select this boundary line, create that at footing bottom. Okay. And if you want, you can just get rid of this footings, split line, join this to this, join this to this, and mm, I snapped to the wrong face. That is the face of the PCC, but we need to deduct this concrete foundation. Okay, and just say that finish. Highlighted floor overlap, that's fine. Okay, so that particular thing, I guess, is created at footing bottom. Here also it is at footing bottom only now. Oh, sorry, footing top. Okay, that's what I was thinking, that something is wrong. So it doesn't matter. Just select this and just change this to footing top. So it will be at its designated location. But now for the PCC of this particular ground floor, after the compaction has been done, the PCC we need to do in order to avoid the settlement. Okay, so for that particular thing, I will just go to this particular 3D structure. And from here, I will just select this particular base plate, which I don't want to waste time drafting in that particular newly created project. So I just say that edit boundary and just say that copy. Okay. And the only purpose of opening this particular project here is that you cannot copy if it is in a different Revit interface. And this is putting up at ground floor. So in this particular project, new project which we are working on, I need to just go to ground root level. You will not be able to do this. You will have to draft it manually. Right now, what is this? VG, import categories and ground floor layout, apply halftone. But we can also see this drawing because of the view range, VR. And I just want to change this to associated level and associated level. Apply and OK. So with that, yeah, we are only able to see this particular thing. Now, why is this footing drawing still seen? HH, or let's hide in view by category. Elements, not category, elements. Okay, so now what I will do is that I will just come here to structure and it is going to be the PCC. So it will be a structural floor. So floor and floor structure, and I'll select this 4-inch PCC and I'm in the drafting mode. So I'll just say that Control V and select this. I did this particular thing just to save time because I didn't want to waste time drafting this, and just move it from this point to this particular point and properly place it. Find the snap point. Yes. Okay. So the stuff has been created. Okay. Perfectly. Perfect. Okay. And this is the floor plate. Structural floor span direction not specified. Yeah. Span direction is this. And just say that finish. Don't attach. So that particular floor plate has been copied. Okay. Rest other areas. For example, if I just take you to this particular AutoCAD drawing, you see that this is the garden. This is the garden, and this is entirely the mud. Okay, gravel portion. This is garden, and this is the gravel portion, so they don't need compaction. But within this floor plate pathway, the one that we created, the hardscapes, and this particular wash area, there is the layer of PCC provided where the minor reinforcement will be provided in order to avoid settlements. Okay, so that's why we created the hardscape floor plate for that. But for garden and this portion, we don't need that. So we will just go to this particular ground floor, and herein I will just get rid of this hide in view by category. Also, this grids I don't need. So hide in view by category. And we need to create this particular. Why am I able to see VR? Let me just change associated level is. Okay, 0 and 0, apply and okay, fine. I'll be able to see the 3D elements only on that particular designated level. So that would make the drawing much better and clear. So this is the water body at footing top, which also I guess that shouldn't be able to, on ground level, it should not be visible. Okay, let's just ignore that. Okay, so this particular part is done. Now the rest, this is the garden and this is the mud. So let's create that. Oh, sorry. We were in this particular project. Yeah, yeah. Ground road level. And I will just close this particular file for now. We don't need it. And from there, I'll just go to structure, architecture, and that could be any floor architecture or structure, doesn't not important. Floor architecture. This I have given the category of floor structure because this will quantify this particular element as a structural element and schedule it as a structural element. So that's why. So I will just go to floor and architecture, and first is that I'll just create grass. Uh, grass. Sorry. Yeah, grass. And let me just check. This is grass. Yeah, fine. This is the custom. This is gravel, but that is the finishing material, I guess. H. Or this should have been continued till this point. And this is mud. So this PCC will continue till this point. And here this is mud. And this is grass. Okay. So I will just create this particular grass from here till this point, and 1, 2, 3, and 4. Split, join this to this, and join this to this. And just say that 0, and it should be on ground road level. That's fine. Don't attach. Then this, as I said, will snap till this point. Finish. Don't attach. Then I will just create one floor architecture again, and this time it would be mud. And create a rectangle, and I'll have to do a little bit of drafting. 1, 2, 3, 4, 5, 6, 7, and 8. Join this to this. Pick lines. 1, 2, and join this to this. Yeah, fine. That would be mud. Okay, clear. Now, I need to create this particular garden steps, this amphitheater, and also the steps leading to the plinth. That is the 2 feet of plinth. So let's no, but this is left. Yeah, fine. So let me just say that wall, and which wall was that? That's why I kept purposely this particular project open so we can have a cross check off because there are a lot of 3D elements. So it is difficult to remember everything. So this wall is parapet wall. Yeah, fine. Okay. So let's just first create wireframe and wall. I will just create that particular parapet wall, ground road level, and unconnect plinth level. Maybe say that plinth level, and right now it will also have an offset from that particular plinth level, 3 foot 6 inches. So let's create that one over here, one over here. This 1, 2, and 3. Is this wall having the layers? Yeah, cladding. So 1, 2, 3, and 4. Here it is enough. It is perfect. Okay, and from here to here, 1, 2, 3, 4, 5, and 6. This 1, 2, and 3. We can create a rectangle here. Okay, and here too. No, but here it is not needed. Okay, so let me just create a simple wall. 1, 2, 3, and 4. 1 and 2. Okay, so one here also, CS, and create. So this particular floor plate CC, I will just edit boundary and snap it. Finish. Okay. Now, here we need to place CS at ground road level at the height of, or let's say maybe at the plinth level with -1 feet. So our bed rectangle from here to here and from here to here. HL, just delete this overlapping lines, TR, and join this to this. Likewise here too, and over here, this rectangle. And now I need to create this line. Pick 1, 2, 3, join this to this. Pick 1, 2, 3, too fast. Sorry. Join this to this, join this to this. Okay, and finish. Don't attach. Let's go to 3D, and I guess this particular parapet wall will be of the lower height. 1, 2, 3. 1, 2, 3, and 1, 2, 3, and select this. 1, 2, 3, 4, and will be only up till plinth level with 0 offset. Yeah, fine. Okay. Now let's create the steps leading to plinth. 1, 2. But before that, yeah, fine. Okay. Let's create the steps first and then we'll create the plinth floor. Here, I guess that there is mud in this portion. Let me just check. Yeah, see here also and this portion also. So I will just select this and go to ground level, edit boundary, snap this here, rectangle, create this, and I guess this as well because, yeah, fine. Okay, so line and join this to this. Okay, and here too, and say that finish. Don't attach. Go to 3D. Yeah, okay. Now let's first create the steps leading to plinth 1 and 2, and also there's amphitheater. So I'll just go to ground level and I'll just come to her to stairs, and we have this cast in place monolithic, and yeah, see outdoor steps. I've already created that, which has this specifications that is smooth 6 inches, tread thickness 3/4 inch, and risers 3/4 inch. Okay, and it is smooth. The structural depth of 6 inch. So important here is to create this path. So I will just say that sketch, create sketch and boundary line. This will be the boundary line. Yes. And this will be the risers, but I forgot to maybe, okay, fine. One, two, three, four. One, two, three, and four. And join this to this. Three risers created, one remaining. Yeah. And just hit the stair path. We need to define the stair path. Okay. Go to 3D. Say that finish. I get that flip. Okay. And that particular steps has been created. Okay. And this material has been applied to it. Simple stair material. It is nothing but just a simple paint. This particular paint. This particular simple color stair material. Okay. And I'll just say that finish. So we have created the staircase. I don't need the railing. Likewise, I'll again come here and just say that CS, and with that ground to road, and with create sketch. Actually, this, I guess that we don't need to create sketch. We can directly, by creating run and desired number of risers 2 and railing, I will just say that none. I don't want the railing. And I will just go from ground to actual run width is how much? 6 feet. So run and 6 feet and run left. Oh, but the tread depth, I guess that, yeah, that's 1 feet. What it is? 1 feet 6 inches. Actual tread depth, 1 feet 6 inches. Run and run from, what is the problem? Ground to plinth, yeah. Desired number of risers 2. Oh, this time it will be 4. Yeah, 1 to 4. Hmm. Just say that finish. 3D. Okay, that is also created. I'll just edit this and I press tab and select this flight and end with riser uncheck. Okay. Now we need to create this amphitheater steps, amphi steps, which would be if you create such spiral steps with the help of this stair command, then there is a special way how to create it. It cannot be monolithic. It can be a simple staircase only. And at the same time, you can also create it by drafting tools. But then there is no point of using Revit if we cannot use the functions of Revit. So I will just use this particular stairs and you have this empty steps, which is a assembled staircase, assembly of different elements, that is tread riser and everything. So here you have the tread thickness, which is equals to 6 inches, and the riser thickness, which is also equals to 6 inches. Okay. And just say that okay and apply and okay. And here it is important that what sketch do you create? Okay. So in order to create this different segments, I would just say that create sketch because this cannot be one entire staircase. It will be created in different segments. So here I just forgot to mention one thing that from ground level to not plinth, but I'll just say that none. And I'll just say that desired stair height is 5 feet. And within that, the desired number of risers that I want right now is 5. So within desired height of 5 feet, if you want 5 risers, then actual riser height will become 1. Okay. And this actual tread depth is not important because anyway, we are going to sketch it out. Okay. Just make sure that here the minimum tread depth is equals to 18, minimum tread depth equals to 11 inches. That's fine. And minimum run width, yeah, fine. Maximum riser height is 1 feet. Yeah, that's fine. Apply and okay. And the stair calculator here will calculate on the basis of the information in the variables that we have feed it. Now, important is that to create the sketch. So first is the boundary. So what will be the boundary? So this would be the boundary. Okay. And this would be the risers. Pick one, two, three, four, five, and this. Okay. And I would just create riser, a simple line over here, and one line over here, and join this to this, join this to this by TR, that is this, join this to, join this to this, and join this to this. Okay, now here, trim X and multiple. Select this, one, two, three, four, okay, and trim X and multiple, trim X and multiple, and one, two, three, four. Okay, done. And just delete this. Just what you need is that you see that four I just created, one is still remaining, which is that one, two, three, four, five. Oh, come on. Stair path. And this is the path. I guess that I have perfectly finished. Invalid sketch. Hmm, what is the problem? Sketch is correct, I guess. HI. Select this. Edit steps. Edit sketch. See, what is the issue? So the same sketch which we are trying to create, I mean, that we have created actually. Ground floor to none, 5 feet, desired number of, yeah, 1 feet and 3 feet. Yeah, everything is fine. What is the problem? Oh, yes, one to two. I forgot to join this. So with the four, I just created one remaining. With that, I'll just say that finish. Yeah, it created one to five and just say that finish. Something was for silly problem. Okay, so that was the purpose of giving this particular parapet up to plinth level and top of sort of 3 feet 6 inches because I wanted this here. Still, I guess that yeah, this was remaining. Yeah, fine. So one you will create this. So okay, ground level. Select this and just say that DM, that is mirror, and mirror it here. So that same element is created here. Now what you need is to create this one, two, and three. Okay. So I will again say that CS, that is create similar, and sketch. This time the boundary line would be 1 and 2, and riser, pick 1, 2, 3, 4, 5, 6, 7, 8, 9. But I forgot to mention one thing. So just let me discard this. And ground floor to none. The desired stair height is 5. That's fine. But the number of risers this time, I want 9 of them. Okay, 9. And with that, I just create this boundary lines, 1 and 2, risers, pick 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I will create one line from here to here, not boundary line, but that would be the riser line from here to here and from here to here. TR, join this to this, join this to this, and trim extend multiple elements. 1, 2, 3, 4, 5. Likewise, trim extend multiple elements. 1, 2, 3, 4, 5. Okay, and just say that finish, and finish. So this has also been created. Now we need to create this. So again, say that CS and with the same constraint, same variable, none, and up to 5 feet. And desired number of risers, 9. I will just create a sketch wherein this would be the boundary line. 1, 2, 2 risers. I would first snap 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last one would be a sketch that would be follow this. TR join this to this. Uh, TR join this to this. Yeah. And just say that trim X and multiple. 1, 2, 3, 4, 5. And I made a mistake, I guess. Mm, why is that? I guess in this case, this is the problem. There is a conflict between, I snapped to the wrong boundary line. Sorry. Boundary line, pick, and it should be this. Okay, HL. I turned it to wireframe by clicking WF, that is a shortcut. And that's why I was able to see this. I just turned it to hidden line, HL again. And now trim X and multiple. 1. Mm, why is it behaving like this? Trim X and multiple. 1. With this, I guess trim X and multiple. 1. Yeah. And trim X and multiple. This time this. 1. Sorry. Trim X and multiple. 1, 2, 3, 4, and 5. Yeah. This is a perfect sketch. Finish. Invalid sketch. Yes. Run. Stair path. I forgot to mention the stair path. Just say that finish. Still an invalid sketch. What is the problem? Somewhere some lines are. Sorry. Finish. Still. Mm, I guess it's closed loop or and finish. Drafting error happens and DM, and I will just mirror it. DM is a shortcut to mirror, and with that we have created this particular staircase using the functions of Revit and not manually by drafting tools. That is, this is the manual method by using this drafting tools. But then if you are going to create that and not use the functions of Revit, then there is no point of using Revit. Okay. This was the manual drafting way with which we could have created this drafting lot of elements. But you see that so easily it's created so many steps in just a little bit of time. So ground level, and if I just turn it to consistent colors, what needed is that we need to create this first step. So I will just turn it back to hidden line and just say that stairs, but this time I will just use this particular landing by sketch, pick line and create this. Okay, and relative height, I'll just say, okay, fine, let it be 1 feet for now. Just first finish it and let's see that where it's created. Yeah, okay, so it is on ground road level. I'll just give it a base offset of -6 inches. So that would act as the first step and would merge with this. This are yet to have its finishing layers. Okay, this is the layer of PCC on which we will have the finishing layers, which when we will start with the modeling of the superstructure. Okay, so this is done, and now we need to proceed further with the modeling part, wherein I'm just going to select this particular AutoCAD drawing footing. The footing I don't need, so I'll just hide in view by elements. I need this ground floor layout, and I'll just snap it to plinth level. And I'll just close this ground road level and go to the structural plan plinth level. Okay. So here, now what we need to do is that I first need to make you understand the structural concern that we have taken into consideration the this particular height of plinth is equal to 2 feet. So in that case, what will happen is that this particular ground beams and plinth beam, on ground, there will be beams which will be inverted beams, which will be having a height of the ideal height is 1 feet 6 inches, that is 18 inches, but I am considering ground plane beam as one and the same. So here up till this point, there will be PCC and here there will be filling. Okay, here there will be filling and this will be the not the RCC slab cassette, but the PCC slab, which will have the reinforcement along the periphery and at the location where the beam intersects with column. This is again a structural concern, but I'm just considering the fundamentals and basics. Okay, so we need to first select all the columns. So how to select the columns? Let me just say that select one SA and bring it up to plinth level using the functions of Revit. So see, now the drafting will become easy, start becoming easy, because we are just going to use this functions and features of Revit and easily proceed with the modeling process. Okay, so all the columns, this two are left, I guess, one and two, again to plinth level, but I just turn this to 0. Yeah, so those are the columns on the step footing. Okay, so all the columns have been elevated up till the plinth level. Also, this retaining wall of the swimming pool and the water body, all all of them will also have the top constraint. Yes, the top constraint not up till ground level, but up till plinth level with the top offset of slightly 3 inches. Why? That you will understand in the later part of the modeling. So this was the reason of taking this height equals to 3 foot 6 inches with the top offset of plinth level and 3 foot 6 inches, that we will realize once we lay the floor plate of that particular ground plinth level. We first need to lay the ground plane beam. Okay, the plane beam, the inverted beam on plinth, sorry, the inverted beam on ground, which will act as a ground plane beam, 2 feet, which I explained in the section, AutoCAD drawing. Okay, so for that purpose, what I will do is that I will just come to this. I shouldn't have taken this particular AutoCAD drawing. First, let me just first go to ground level only and go to ground level and first create the beam network here. I just say that height category floor. Okay, so this would be the beam network on the ground floor. Okay, so let's just check here. Yeah, fine. So see this, if I just hide the reinforcement HC height category, this would be the beam network on the ground floor, plain ground floor. So this will be the beam concrete 9-inch 24 ground plane beam. Okay, so we need to create that. So I will just come here to beams, structure and beams, and I will just drop down and select this ground floor beams. Okay, which will be their offset value of 2 feet. The top of that will be laid on that particular designated floor. So if I just show you, if I just lay this, it will be on this particular level. Okay, so just click this particular beam and then just start drafting. Okay, and this will entirely connect till this point. I'll just turn this particular that justification to right. CS, that is create similar. Okay, this would also go to all the way to this point. And here we would have one. Again, this is confusing, left and right. I will just connect this. This particular beam will entirely go till this part. Okay. And CS connect from this point to this point. Again, the justification left and CS and create this from here to here. And this would from here to this part. Again, the justification to right. Okay. This particular beam will go till this point, and here this will be the, let me just check whether this beam, yeah, this will entirely come. Okay, so CS and create similar, the justification to right, bring all the way till this point, and what if it connects this, it will support this water body. In that case, even this should be brought to this point. Okay, let me just check why I haven't taken it here. I have stopped that particular beam over here. If it is a ground beam, then what's the problem? Oh, sorry. If it is a ground plane beam, then I guess we can continue till this point. Let me just connect. Okay, and CS and CS create similar pick lines. TR join this to this. And this will entirely connect till this retaining wall. Uh, why can't I find the snap point? Okay, I'll just say that RP reference plane. Oh, RP, hide this retaining wall and bring this point. Yeah, delete it. AR. CS, connect this to this, connect this to this. This will entirely go to this part. Okay. And here also, if you want, you can have a couple of tie beams. Uh, Left, bring it till this point. Yeah. But that is again a structural concern that whether there is a wall coming on top of it or not. But I'm just taking an ideal condition. This will be the beam till this part. Okay. And here there will be one beam. Yes. And here the beam size will increase. Okay. But that would be for the floor above. Right now, let's just continue this beam only. Left. Snap point is wrong. Yes. CS 1 to 2 and 1 to 2. That's fine. Okay, so this is the ground plane beam network that we have created. Okay, wherein I might be wrong at some point, wherein you see that I guess that this particular beam will stop here because this is a water body. Yeah, fine. So I'm just showing you the modeling process. That's it. I might be wrong at a couple of places. Even this, I guess, will not, or it will come. What does this drawing says? Let me just go to 3D structure. Yeah, see, this beam will stop here, but this will come. Yeah, see. Why it is not showing it here in plinth floor plan HR? Maybe some visibility problem. Otherwise, that beam is there. Yeah, see, this beam stops here. Okay, but this beam will come because there is a wall on the top of it. Fine, perfect. So that's for that purpose only I kept this particular file open so we can have a reference as and when required. So I guess that this is perfectly being followed. Okay, yeah. So ground beam and connect this point to this point. Okay, fine. It's perfectly fine. No issues. 3D. Fine. So the ground beam has been created. Now we can proceed further with the laying of floor plate at that particular level here. This particular level. We need to place the floor plate. See, this would be the floor plate of PCC as I explained in the AutoCAD drawing. Okay, and I don't want to waste drafting this particular floor plate. I would just again copy that particular floor plate from that drawing. And on plinth level, you can see this drawing. Yeah, if you want, you can just draft out the floor plate. You will have to draft out the floor plate because you will not have the reference drawing. I have, so I will just, in order to save time, I will just say that open up that particular project. Under that, I will just hide this and select this particular plinth 6-inch plinth floor PCC. See, HI. So this is the entire floor plate. Okay, this is the entire floor plate, which I will just say that edit. Oh, sorry, not modify. Sorry, undo. Edit boundary. Select this. Control C. Finish. Don't attach. HR. And is that has it covered the gymnasium area? Yeah, fine. Okay. HH and has it covered this particular area? HI. Yeah, fine. Hmm. Okay, so I will come to this particular project, our project on which we are working. I'll come to plinth level and I will just say that architecture, not architecture, sorry, structure, floor structure, and the family exists. Mm, plinth, plinth level PCC slab. See, that has also been given the material of sand bedding. As I said, that there will be PCC on that for that particular floor, and reinforcement will be only along the boundary and the intersection of beam and column. So this is the sand bedding PCC material, which is given the concrete mat material and the graphics of this cut pattern, which is equal to sand dense. Okay, so I will just Control V and copy that particular floor plate HL hidden, and from here I will just move it and find the snap point. Yeah. Oh no, that's wrong. Move it. Yes. Okay. So this, I didn't want to waste time on drafting this, so that's why I just copied it. That's fine. Okay. So this would be the plinth level PCC lab, and just say that finish. Quit sketching. Span direction. Yeah. Span direction. Let me just select any of this and just say that finish. Don't attach. Go to 3D. And that particular thing has been created. See, so this was the purpose of giving this retaining wall height offset of 3 inches. Okay. Again, there will be finished flooring layers on this particular PCC. Okay. We need to create a, okay, but that's not important. Here, one staircase I forgot to create, but that's okay. But you see that now this is the living room, which is floating on a water body. Right now, we are just considering the structural part. Okay, so before proceeding further, let's complete this particular staircase. I don't want to keep it. So, ground road level. Yeah, on ground road level, this is the courtyard, and from this courtyard, the staircase is coming up till the height of 2 feet. So, I will just select this particular steps, CS, empty steps, and just create a boundary line. This would be the boundary line. Oh, but before that, I forgot to mention the constraints. Discard run. Yeah. Empty steps, I want from ground level to plinth level, and I want only desired number of riser to be one. Yes. And actual tread depth to how much is this? 1 feet. Actual tread depth to 1 feet. Okay. And desired number of risers two. That's fine. And sketch out boundary line from here to here, from here to here, and riser pick 1, 2, 3, 4, and 5, and stair path from here to here. Two risers created. Yeah. Invalid sketch. What do you say? It is correct. What is the problem? Oh, sorry. Forgot to draw one riser here. And finish. Yes, and just finish. 3D. Mm, I guess that. Okay, here there will be one beam which will hide, but that's not important. It is the steps being which is being taken to, if I can end with riser, edit steps, end with riser. Oh yes, perfect. That's what I was thinking, that something is wrong. Anyways, fine. So these are the steps coming to this courtyard, not amphitheater, courtyard. Okay, courtyard. Okay, now let's begin proceed further with the modeling part, for which first what I will do is that I'll select this particular load bearing wall and take it up to first floor with a top offset of 15 inches. Okay, the load bearing wall, which is pertaining in the gymnasium area, multipurpose room. Yeah, fine, this is the multipurpose room. Okay, has been elevated. Now what next is that I will select all these particular columns and use the features and functions of Revit, and now things will be easy. Little bit, a lot of details have been established. Select this also, and SA, all the columns have been selected, and just take this particular thing up till first floor. Clear? But this particular one column will not. The reason you will understand later. I'll make you explain later why I want to stop this particular column here. Okay, next is the beams, the ground plane beams. So just HH and hide this and select this particular beam SA. All these are the ground floor plane beams. I would just use the features and functions of Revit when you have this particular thing. Copy to clipboard. I would just say that align to selected levels and just snap it to first floor. But those particular beams will elevate in the top direction, which was the consideration for this level, that this particular thing was ground and plane beam was same. So they were the inverted beams, but these are not the inverted beams. So this should elevate in the negative y direction. So what should be done in that case? I will just uncheck this, select all those particular beams, and first is that I will just select this particular beams and change this beams to 9 cross 18 first floor beams. 9 cross 18 first floor beams. Okay, and the Z offset value to 0. So they will perfectly snap to the location where it is supposed to be. Okay, now again I need to check whether this beam, I guess this is double height, so this beam will not come in this case. Yeah, okay. So go to plinth level, but you'll not be able to visualize those beams. You need to go to first floor, but even in first floor, yeah, first floor, those beams are there. Yeah, I can visualize that. And this to this 3D. Okay, absolutely perfect. No issues. Only thing is that here the beams will be of the greater size. 12 cross 18 first floor beams. See, actually these beams are also supposed to be of the bigger size, but since they were ground beam, so I didn't. Actually, these beams are also of the greater size. It's not 9 cross 24. You see that? It's 12 cross 24 first floor beam for puja room. Doesn't matter. Let that be as it is. But this particular thing, I will just stop it here. And 1, 2, 3, I will just change it to the bigger size. That is 9, 12 cross 18. Bigger beams. Okay. So you will, in this case, it was having a small size. So see this offset. I will select this particular three beams and change it to bigger size first floor beams. For puja room, what is the difference? First floor beams. Yeah, first floor beams for puja room. Yeah, okay. But the 12 cross 24 that was supposed to be, yeah, first floor beams only, not puja room. Those first floor beams puja room was supposed to be actually here on this ground level. But we placed their regular beams also, regular beams only. Now I'm not changing it. That's fine. Only thing is that I need to create that CS and that one beam over here. Mm, left, or sorry, not center, right. Okay, 3D. Ah, yeah, fine. See, if I as a tutor, I'm facing so many problems, even though constructed this particular model one time, then I'm facing so many problems. So just imagine how many problems you will face while modeling it. But just say stick to it and you will achieve it. Don't worry. HR. Okay, fine. So now let's go to first floor. Again, I guess that I need to create a reference line LI. Select this line, edit work plane, and first floor. Uh, where is first floor? Yes. So I'll go to first floor, and here I will just come here, insert, import CAD, first floor plan, inch manual center. Okay, and VG, imported categories. Turn this first floor to half tone. Apply and OK. And move this from this point to this point. Okay, everything is fine. Go to 3D. Yes. VG, imported categories, turn this first floor drawing, AutoCAD drawing to halftone as well. Okay, let me just check in south elevation whether we are proceeding perfect. So see this particular, yeah, load bearing wall, that is fine, but everything is perfect. Okay, no issues. Now the next step is that we need to elevate this particular columns. Furthermore, depending upon the requirement, what is the requirement on the floor above. So I will just select this and edit work plane, snap this reference line to terrace level and OK. Just go to terrace level, floor plan, and sorry, terrace level, yeah. And here is the snap point. Insert, import CAD, uh, second terrace floor plan. Okay, inch, manual center, open. I guess I inserted the wrong second terrace floor. Second terrace floor ground layout. Uh, open CAD drawings, second terrace level, open. All this drawing will not come. This is the first floor plan. So what did I insert here in this first floor plan? Yeah, first floor plan is perfect. Yeah, fine. So second floor plan will be this. Only this. You will get this AutoCAD drawing. Don't worry. Okay. And Control S, close it. And then now go to import CAD, second terrace floor plan. And yes, yeah, fine. And VG, imported categories. Turn the second terrace floor plan to halftone. Move from this point to this point. No, this is not the snap point. Move from this point to this point. And whether we are correct or not, in order to cross check, just let me just change this range level to planes level. Yeah, fine. We are perfect. Perfectly snapped. Okay. So now let's go to 3D. Before proceeding further, first VG and imported categories, turn this to halftone, apply and OK. And let's temporary hide this HH and also this layout HH. And we just need the first floor drawing. So for the first floor, we also need to create this particular floor plate, which on this particular floor, it was PCC. But now on first floor, it would be an RCC slab, reinforced cement concrete slab. So as per the footprints of the floor plan, we need to complete the beam network. For example, if I just take you to this particular first floor plan, and here there is an AutoCAD drawing, which says that here there is a lower terrace next to this particular family sitting and bedroom, and here the beam network will continue. So I will just select this particular beam and snap it till this point. Okay, and just say that CS create similar, create one beam over here as well. Just select this particular thing and change its just Y justification to left. Okay, this is again a structural concern, but I'm just following the ideal method. So here, this particular courtyard on the plinth floor, on the plinth level, this courtyard is overlooking. Okay, so in order to support this particular slab, there will be a beam over here at first floor. So I will select this particular beam and just draw from this edge to this edge and this edge. But all of this, I guess, will we have the right Y justification to write. Actually, I snapped at the wrong place. Sorry. This should here and move this point and move this as well. This is a structural consideration that where to put a beam according to load constraint, but I'm just following the ideal situation. Also here, there will be a, as per the drawing, if I just say that HI. So see, this is the wall. This is the wall. So I need to create a beam over here as well. Right? So that concludes the beam network on that particular first floor. Now I need to, the beam network is complete. See, now I need to create the slab, RCC slab. So for that purpose, I'll just go to this particular drawing again, and I will just select this particular floor and IC. Let me just say that IC, that is isolate category. You can do it from this eyeglasses, isolate category. I have just entered the shortcut IC. Okay. And uh, I just need to see this IC finish flooring. I don't want to see the finished flooring right now. I just want to see the RCC slab. So let me just select all the slabs, finished slab, and just say that H, hide it. Also from here, H, hide it. Okay, fine. So this is that particular slab, which is putting up at first floor, 6-inch first floor concrete slab. Okay, so I will just say that edit boundary, HL, and I will just say that Control C and come here to first floor and just go to architecture. It's not architecture, structure and floor structure, and I will look for that first floor concrete slab. Okay, and just Control V and copy the and the footprints copied. I will just align it. Oh, sorry. I'll just say that enter, move it from this point to this point. Okay, so that is how I have copied the footprints of that particular floor plate on that particular first floor, and just say that finish. Yes, span direction. I just give this as span direction. Don't attach. Again, I'll come to this particular 3D and here and don't attach. I'll enter. I think yes, this is left. Okay. So I will select this particular extended floor plate for extended balcony and edit boundary. Control C. Come to first floor and again say that structure, floor structure. Control V. This is just that I don't want to waste time drafting that boundary. So that's why I'm just copying it from that existing file. Fine. And this would have -1 foot, the drop of -1 foot. So that would be a drop slab. In order to, in order to, um, what do we say? Here, there is a, this particular portion will be affected by external rainfall. So that's why we have created a drop slab over here. And same likewise, this is the toilet areas. So here too, I will just say that edit boundary, Control C, come to first floor. Again, select this slab CS, that is create similar, and Control V, paste. This was a simple rectangle I could have. Yes. Okay. And finish. Again, the span direction. Just say that finish. Fine. One thing I forgot, this hidden view by category, the span direction. One thing I forgot was that there will be a beam over here also. So in order to place that particular beam, let me just change it to consistent color and select this particular floor plates, all the floor plates and HH hide. So we can see the beam network. Okay, yeah. So here there will be a beam, and at the same time here also there will be one beam. Okay, so select this CS, that is create similar, and place one beam over here, place one beam over here. All of that, I will just change it to right. Yeah, perfect. And also one beam over here. Okay, yeah, fine. And HR, yes. So the last slab left is this particular lower terrace. So again, I'll just say that 6 inch, but this time I'll not copy. I'll just say that C is create similar because it's just a simple rectangle, which I would create. Again, the view range is creating a problem, and I'm not able to properly enter. Okay, and this is the beam network. Yeah, fine. So why am I be able to see the? Okay, let's forget it. CS, that is create similar, and just create that. Again, this is a lower terrace, so I will need 1 feet minus drop slab. That is going to get affected by external rainfall. So we'll need to do a waterproofing over here. All the drop slab that we have created, including toilet and the extended balconies and everything, with this as the inverted beam, this acting as an inverted beam. Here there will be waterproofing. We will create that particular layer of waterproofing when we model the finish, the superstructure, with all the finishing materials. Okay. So now with this, that concludes up this particular floor plate. Now I'll just select this particular column SA, and this column won't go further up. So only all this particular columns, and I will just deselect this column, and this particular columns I will just say that will go up till footing, not footing, terrace level. Where is the terrace level? Like, yeah, terrace. Okay, second floor or terrace level, whatever. Okay, and at the same time, I will also use this particular beams, SA, select all the beams, deselect this beam, but I guess that I need to select that particular beams for now. So I will just select this SA, select all the beams, and just say that copy to clipboard and paste line to selected levels to terrace second floor. Okay, and as I said, I won't need this particular beams on that particular floor. So this time I will go to terrace. I will just rename this terrace second floor. Because there is a room there also on that particular floor also. Terrace second floor. Okay, and terrace second floor, CC. I will just select this beam, delete it. This beam I will just conclude till this point. Okay, so this becomes the terrace second floor. And let me just check here the floor plate for that particular floor. This is the floor plate for that particular floor with this one drop slab. So I will just select this and just say that edit boundary and Control C. Okay, and finish. Don't attach. Come to our drawing, and here we have already copied the AutoCAD drawing. What I'll do is that I'll just say that structure, floor structure, and 6-inch second floor concrete slab, because that would have a different footprint. So in order to quantify that, I have created that differently. And just say that Control V and select that and move it from this point to this point. And I suppose I guess we were supposed to first, yeah. Okay, let's just finish. Span direction, and I will just select any of this one line and finish. Okay, but I will just zero, not be a drop slab. Okay, and here this beam will not come. See, as per the design, this particular beam will not come in this case. Let me just say that HR. Here, yeah, see, this is the lower terrace, and here there are louvers. So that particular beam will not come. Again, if we want to cross check, then I will just select this particular beam and any of this one column, or actually this would have a 3D structure. Yes, and onto that, I will just get rid of the reinforcement. Reinforcement, I will select and hide category. So here we can cross check. Yeah, fine, perfect. So see, this particular beam will not come. See, okay, clear? Yeah, this drawing concludes. So that's why it's important to, yeah. So come here and terrace floor plan. Yeah, I would just break this particular beam with this split element tool. Conclude this beam till this point and this particular beam till this point. Okay, and also this, I just say that HH, join this to this, join this to this, and get rid of this. HR, H, HR, uh-oh, sorry, HR. Okay, here there is one so that we can actually create. So just say that CS create similar, and with -1 feet, I will just say that and just finish it. Okay, select this and hide in view by category. Go to 3D. Okay, yeah, fine, perfect. Only we missed one beam over here. And in that case, we missed that particular beam on this particular floor also. So let me just go to first floor and select this particular floor plate, hide category HC, and I need a beam over, but if I'll hide that, yeah, here we need a beam. So HC, hide category, select this CS and create that beam over here. Just shift it uh, left. Okay, and the same, I will just say that copy to clipboard paste align to selected levels to terrace second floor. So that beam will be reflected here as well. So if I now just check in 3D, yeah, see, okay, perfect, fine. So we have concluded this much. Now the last floor up till the slab top. So for that purpose, I will just go to this particular terrace second floor and HL, sorry, and I will just, and I'm not able to, yes, one, okay, let me just do that particular thing here in 3D only. Let me just select the required columns. There's a shadow on, and let me turn off the shadows. Yeah, fine. So properly visualize. 1, 2, 3, and 1, 2, and 3, 1, 2, and 3. This much columns we need to elevate up till slab top. Okay. And for the structural framing, again, I will just hide this particular floor plate HH. So we can just select the structural framing required 1, 2, and the beams. Okay, and this beam and this beam. And just say that copy to clipboard, align to selected levels, and just snap it to terrace, oh sorry, slab top. The name of this level would be first floor lower terrace LT. Yes. And this would be rename second floor upper terrace. Yes. That would make it more. So I will just join this to this, TR, and join this to this, join this to this. Okay. And just say that HR. Fine. So that particular floor has been created. And let me just go to terrace floor plan. Okay, slab top, and just, yeah, that's perfect. I need to create the slab floor structure, and that would be this same second floor concrete slab. I will just, because I don't have the slab top, so I just create this particular second floor concrete slab, and that would from here to here, and okay, and just say that finish. Go to 3D, but this, I guess that wouldn't have this offset. Yeah, no, actually, let me just check over here. Here also there will be waterproofing. So does this? No, slab top 0. Yeah, fine. We don't have a drop slab over here. Ideally, that should be because I have made a mistake. So just ignore that and follow what I'm teaching right now. Ideally, this is the terrace. So there should be a drop slab. So if you just select this particular thing, then this particular slab HH, this also doesn't have it. The finished flooring, I guess, will be such that would take into consideration. Yeah, correct. The finished flooring would take into consideration the waterproofing part. So that's why there is no drop slab. So if I just select this, then it is, yeah, fine. See, it is incorporated with this particular brick bed. So that's why there is no drop slab. Yeah, correct. So let me just go to 3D of this, our project. And yeah, this is perfect. Okay, no issues. So with that, we are completely done with the civil part, the core structure. What left within this is that, as I said in the introduction, we will model the reinforcement for this particular structural model. So let's start with that. And for that purpose, let me just go to, sorry, not this, footing bottom. And we will first start with the reinforcement of hiding view by category. Yeah, first we will start with the reinforcement of this particular footing, a typical footing. So I'm going to give you an overview and insight of how to use this particular tools under this particular structure tab under reinforcement panel. You have this various different tools and how can you model rebar. Mark my words. How can you model and not design? How can you model a rebar once you have the drawing from the structural engineer for different structural 3D elements? For which even I have taken an online reference of some images which I found online, wherein you see that this is the clear concrete cover for different 3D structural elements, different structural 3D elements, that is foundation, column, beams, staircase, slab. Then this is a table of the foundation which shows the diameter of a particular rebar. in short and long direction for top and bottom for a particular width length. And this is a typical detail of a column. And all this I have taken into consideration and taken as a reference and implemented and tried to implement that particular thing in that particular project, wherein I have not designed it, but I have just learned that if you have the drawing, then how can you model this particular thing? So I'm just going to show you that. I cannot design because I'm not a structural engineer. Fine. So for that purpose, we will start with this particular simple, this rectangular isolated footing. Okay. So do we have any section? So let me just take this particular section over here, and also let me just drop this horizontal section. And if I just go to this particular project, and under this, if I just go to structure, then you see that I have this rebar designed for all the 3D elements, from which right now I will just focus on footing. Yes, that how can you model this particular rebar? Okay, so we are just going to learn how to create this particular thing here. So for this, I will just go to the section and just hide this unnecessary things. Okay, and yeah, also this grid line HC height category. The drawing is much clear. This import symbol, AutoCAD drawing also I know don't need to see. Okay, and we will just focus on this particular isolated footing for now. So now since this is the footing, so here under structure tab, first is that you have to mention a cover for your 3D elements. So here if you just click this, and if you click this particular tab, then I have already created this different cover for different structural 3D elements on the depending upon the reference that I have found online. For example, for this particular footing, it is exactly 50 mm, that is 2 inch. And likewise, for columns, beams, and girders, and staircase and wall, I have entered all those particular values here. Okay, fine. So for that, for the particular thing, I will just select this particular thing and drop this down. And since this is a footing, so I will just give it a cover of 2 inch. Okay, cover of, yeah, this shows the cover of 2 inch. Now I will just click on this particular rebar. So as soon as you click on rebar, it will highlight these different shapes. Okay, so the first is that for this particular thing, we will need this particular shape M-02, M-02 rebar shape, and you see that it snaps to the cover that we have mentioned for that particular footing, and I will just place it one, and from here I will just turn this to fine. So this is the 8 mm diameter bar. So these are the couple of sizes. If you just go to the fresh new project, let me just go to project, and this time I will open up a default metric project. Default metric, where is it? Why could I locate a default metric project? Uh-huh. Oh, so this is the English Imperial, sorry. Templates, and go to English, and here you have this default metric, and open and OK. So under here, if you just drop down and come to the family section, then you see that right now there is no rebar details loaded over here. So where can you load it from? You just need to go to insert, load family, and under this libraries, navigate to English and US, and under that you have this one folder, structural rebar. Where is it? Yeah, structural rebar shapes. From that, select from M0 to M19, all of this, and just say that open. So as soon as you will load those particular shapes, you will also with that simultaneously load the different rebar with different diameter. I'll just show you. So with this now, if I drop down, you see that you have the structural rebar, you have the different shapes already loaded. Fine. But at the same time, you also have this rebar of different sizes. For example, if I just go to type properties of this is the system family shows rebar 16 mm, wherein these are the different fields which a structural engineer will be quite aware of: model diameter, bar diameter, bend diameter, hook bend diameter, etc. And under this, you have this spice length, then you have this crack length and hook length and everything. Each of this particular different parameters which you can edit, which I have already made the required changes according to those reference images and already loaded this particular different types of shapes and different, for example, structural rebar. So these are the shapes which I'm just going to use in my in our this project, wherein from here to here we have this custom shapes, rebar 1 to rebar. All these are the custom shapes which we'll use for a particular staircase, but the standard shape follows this M-0 to 17A, M-0 and T1. Okay, and with this also I have edited the different sizes for a different type of rebar. For example, right now this is 8 mm. I will just make it equals to 16 mm, and if I just go to edit type, then you see that I have entered that same value here. See, 16 mm. Revit is compatible between switching units. As soon as you enter that, it will accept. Okay, and likewise also I have edited this figures for those particular rebars, the standard bend diameter, hook diameter, etc. Fine. So whatever I know, I will make you explain regarding this particular modeling of rebar. So for now, if when I select this, right now you see that there is just one single piece of this particular M-02, this particular shape 02 M-02, this rebar, which is of 16 mm, there's only one element. So from layout, I will just change this to fixed number and I will just change it to, let's say that 8. Forget about the direction, but right now I am just considering this. So this is what, yeah, this is the one we are focusing on this. So now I want to highlight that particular one footing. So what to do? Mm, Let me just go to this particular section, select this particular footing, come to this particular 3D and just say that section box. Yeah, so we have highlighted that particular footing. From this, I will just select this and go to filter, check none. And I will just select this particular structural framing. We don't have structural rebar loaded. We created it, right? So is this the same footing? Yeah. Maybe VV and is structural rebar on? Yeah, see, this particular category was off, so that's why it's not showing. Apply and OK. And with that, I will just say that apply and filter and check none. Structural rebar, apply and OK. And just go to this particular edit visibility stats and view unobscured and just say that OK. So with that, now you will be able to see that your rebar has been placed. Now number of this particular bars in short direction, long direction, its radius, its hook length, its bend diameter, etc. All this will be decided by a structural engineer. I cannot decide it because I'm not a structural engineer. So I will just show you that how can you model this. Okay. So I'll just go back to section 2 again. And now I will just select this particular rebar again. And this time I'm just going to say that I'm going to host the same rebar but in another direction. So for that purpose, I will just use this particular tool. Under placement tool, I just say that perpendicular to cover. Okay. And with that, I will turn this to 16 mm. Okay. And I will just place this here. And let me just shift it a bit. Okay. And again, I will just say that maximum spacing, no, not maximum spacing. I'll just say that number, fixed number, and this time for this direction, I will just enter the number 7. Okay, so let's go to 3D and just select it. Filter, check none. Structural rebar, apply, OK, and view visibility states, view on obscured. OK, OK. So this is how you have created the rebar for the bottom bars of that particular isolated footing. Now let's create quickly the top rebar, and this time I'm just going to select this 14 and placement plane parallel to work plane and place it. Again, select this and fix number. I want 7 of them in both the directions, and rebar same, but the placement plane I will just say that perpendicular to cover 14 mm. That's fine. 14 mm, yes, and yeah, place it, select it, and just come here and to fix number, and in both the directions for top rebar I will use 7, number 7, and just go to 3D, select this, filter, check none, structural rebar, apply and OK, and just say that visibility stats, view unobscured. OK. So that is how we have created this particular rebar for a typical footing. Now let's continue to host this particular rebar in column. So for that purpose, if I just take you to this particular drawing and I will just say that VV visibility graphics filters, and I will just call this equals to tie beam neck, column neck, apply. So with this, you will be able to see that how have I placed the rebar over here onto this particular column. Okay, so for that purpose, now we will come here to this particular section and we want to create the column footing rebar for this particular column. So I will just select this particular rebar, and this time I will just select which shape it was. Yeah, M17A, 17A, this particular thing. And I will use this 14 mm or 12 mm, let's say that 12 mm. Okay. And the placement plane should be parallel to work plane. And I will just place one over here. Okay. The sizes I'm just taking randomly. It's not a structural concern. Okay. And I will just snap it here. But one thing we forgot. We forgot to mention the cover for this. So I will just select this particular rebar and delete it and just go to cover, select this particular column, and I will just select the preferred value. It was something like 30 mm or 40 mm, I don't exactly remember, column for that particular thing. And then I will just say that rebar and place that particular rebar. Okay, and just snap it to that particular cover. Yes, and just pull this. Okay, if you want to edit the dimension of this length or this diameter, then everything you can do over here under these different fields. Okay, with this, I will just say that I want this to be fixed number, 3 of them in this direction. Select and DM, that is copy, and copy it across here. Okay, now I need to go to plan of this. So I'll just go to footing bottom. I will just select this particular thing, filter, check none, structural rebar, apply and OK. And I will just drop down view visibility state, view on obscured. And here is the rebar detail in plan. Okay, so I will select this particular rebar and just copy it roughly somewhere here. Okay, and with that, I will just change this fixed number to only 1. Okay, and with that, I will just use this rotate tool. I will click the snap point and rotate it exactly perpendicular 90 degree. Fine. So this is how I have placed this rebar, and just I will just say that DM, that is mirror. Select center of this footing. Where is it? Where is the center? You could not snap to the center. Okay, fine. Let's just create one. Select this and just move it with the help of your arrow keys. Okay. Okay. So that is how we have created the rebar for a particular column. Check none. Structural rebar. Apply. Okay. And view visibility. View unobscured. Okay. So you see that it shows the rebar. If I just click R enter, you can see that different colors I've applied to different sizes. So you can differentiate and distinguish the rebar. Okay, now I'll again come to this particular section, and now we need the stirrups. So again, I'll come to structure and rebar, and this time I will use this T1, and the placement plane would be perpendicular to cover. Okay, and I will use this 8 mm. Again, this is just a random size, and this I will just say that it should be equals to, I will just place it on the bottom of this cover and just say that the maximum spacing should be equals to 200 mm. Okay, and from here I will just drop this down. Uh-oh, I have the arrow keys. I will just drop it till this point. Okay, fine. Now for this rebar, we will have the lapping with the rebar on the column above. So what I will do, I will select this particular rebar, all of this actually, and just say that this C value should be equals to whatever it is, plus I will have a lapping of 500 mm. Okay, so that will elevate. Fine. This I would stop here, or it will go here, I don't know. So again, I will come to 3D here. Let me just select all of this. Filter, check none, structural rebar, apply, OK, and just view visibility states, view unobscured, and OK. So that is how you create a rebar for a typical footing and a typical column. This is just the modeling of rebar, not the designing of rebar. Okay, and this value, I will just select it, Control C, and enter the same value for this one which was left, Control V. Okay, so that was for a column. I will just, yeah, I'll get rid of the scope box. Column we are done. Now, next we are going to proceed for a beam. And now for a beam, it is going to be very simple. So I shouldn't have, yeah, let me just go to the same section and extend it in the bottom. Structural framing is not visible. So VV, let me just go to visibility graphics and structural framing. Yeah, it is visible. Then why it is not showing? Mm, is it here? Oh, yeah, it's here. Maybe in this, here it is. Here there is no structural framing, so that's why. Which column did I select? Let me just get rid of the scope box. Okay, so from here there is no, yeah. So we have this beam over here. So for this particular beam, it is going to be very easy section. And for beams and girders, so I will just say that cover. Let me just expand this a bit. Select this beam and just say that structure and cover and select this beam and drop down and just say that 20 or something. I exactly don't remember. Beams and girder. See, selected that. With that selected, I will just go to the section of it, this particular section. Okay, so we are on that particular section, and the cover we have already mentioned, I guess. Yeah, fine. I need to hide this. Where is the section in plan? Yeah, it's perfect. So why am I able to? Let me just, yeah, okay. So only that much is visible. So cover, and yeah, that's fine. So I will just again now say that rebar, and it is going to be a, but the placement plane, oh, sorry, current work plane, and the placement should be perpendicular or parallel, sorry, parallel. Okay. So you will place this particular rebar. Let me just extend it or drag it a bit according depending upon the cover. I don't know why this cover in this case flushed here, and just turn this to fine and just turn this to 8 that's fine perfectly, and I would just say that the maximum spacing should be 200 so that is how we have placed the rebar for that particular beam. Yeah, here it is. So I just select from here to here, filter, uh, this particular thing, filter and check none, structural rebar, apply and OK. Visibility stats, view unobscured and OK. Yeah, so see, this has been placed. Now I will again go to this section 1, and now I will provide rebar, but this straight rebars. Okay, m dash 0, for which again I'm just going to use this 8 bar, and the placement place perpendicular, and I will just place one over here, and I will just say that I want fixed number and 3 of them. That's fine. Select this and DM and mirror it. Okay, perfect. And just go to 3D. Select this, filter, check none, structural rebar, apply, OK. And visibility stats, and just say that view unobscured and OK. So that is how we have placed the rebar for a beam also. So the rebar for the strip footing exactly behaves like this only. If I just take it to this particular structure, then you see that this is exactly acting like a beam. This is a strip footing, but it's exactly acting like a beam. And same is here, the strip footing for a compound wall. So there also the details follows is the same. For all this strip footing and everything, the details exactly follow the same. So this is for combined footing also. See, only the sizes and the diameter varies. Otherwise, rest everything is the same. Okay. See, for this particular step footing also, for this particular step footing, one single step is acting like a footing. That is the only difference. Otherwise, the rest, everything is the same. Okay. Only difference is that how to model this particular curve rebar, freeform rebar, curve freeform rebar, how to model this. So that I will show you. And after that, I'll show you that how to model rebar for a staircase. So let me just go to this particular 3D and select this until we, sorry, find, where I'm not able to find this. Yeah, here it is. So HI, no, but if I just say that HI, then it will, so let me just, okay, hide this unnecessary elements, H, and let's just focus on that particular curve shape of the footing, H, curve shape beam. Okay, so for this particular beam, there is a curve shape beam, there is a special method of how to lay the rebar. For example, I just go to this particular structure tab, and under that, if you just click rebar, then you have here this free form. You can also sketch if according to your design. Also use this, sorry, not free form. We'll use this align tool. Yeah, that is part of free form only. Okay, so align. So specify a free form rebar set with a planar bar distributed along the path. So you can see right now that it is popping up this animation. As soon as I click this align, you see that it shows that select a face to add to the host surface, select again to remove, space to continue. So first we have to select the host surface. So I will select this 1, 2, 3, and the bottom one, 4. So this is the host surface. I'll just press space, and then we have to select the direction. Okay, we have to select the path, sorry, not direction. If I just click space, you see that right now we have selected the host surface. Now I will, as soon as I click space, that path will get activated. So I will just select this one path. Okay, and then I will just say that 8 rebar. I'll just say that finish. Okay, so that particular rebar has been hosted. Only thing is that we forgot to mention the cover. So I'll just select this particular beam and say that the cover is equals to beam and girders. So see, the size all reduces. Fine. I can just select this and change it to 12 Now, this should be a, this should have certain style. For example, this should be a stirrup. Okay, so stirrup tie, wherein the end of bar should be a hook, which should be equals to stirrup tie 135 degree, and same end of bar should be equals to hook, and hook at end should be equals to stirrup tie 135 degree. Fine. So that concludes this particular rebar. Again, I will just say that maximum spacing should equals to 200 Okay. That depends upon the designer. Fine. Now we have to place the rebar along the face. Let me just turn it to CC, consistent colors. Here you can change it from. So we have to place the rebar along this face and bottom face. Okay. So for that purpose, I just click rebar, and this time I'm just going to use this surface tool. Specify a free-form rebar set that allows varying length of individual rebar along a surface of the host. So as soon as I click this particular surface, you see that select a face to add the host surface. So I'm just going to say that this is going to be the host surface. Okay. I just press space. This is going to be the start surface. Again, I'll click space, and this is going to be the end surface. Okay, and this I'm just going to hit the check. Okay, so with that, you see that that particular rebar has been hosted, which is going to be a 8 bar. Now you see that it doesn't follow the cover. So we want that particular bar along the edge, inside edge of this particular stirrup. So if I just click this, I will just say that maximum spacing should be equals to, or not maximum spacing in this case, I'll just say that fixed number, and that should be equals to three of them. Okay, and I will just host that particular thing on the bottom as well. So again, I will just go to rebar and surface. So for this time, I'm just going to select this as a surface, this as a start surface. Oh, sorry, surface, this as the host surface. Ah, sorry, rebar and surface, and bottom कौन सा है? Yeah, this is the host surface. I'll press space. I select this start surface, press space, and I'll select this end surface. Oh, by mistake, I selected that. Aha, sorry. Let's try once again. Surface, select the bottom surface, press space, select this surface, press space, and then select this surface and just hit the checkbox. Okay, so the rebar has been hosted here. Now I will just change it to fixed number, that is three of them. Now I want to adjust it according to the stirrup. So what I will do is that I'll select this, and you see that you have that edit constraints. With that, I will just edit constraint. First is that I will elevate this, and I would make it equals to minus 16 mm. So that will elevate. Then I will select this is equals to minus 16 mm, and then I will edit this dimension minus 16 mm. So you see that now you have your particular rebar. I suppose that it was supposed to be positive. Let's just check 16 mm. No, 16 mm is getting in negative direction. Uh, Minus 16 mm. Okay. And this particular thing, that too, minus 16 mm. That will get inside. And this too, minus 16 mm. Minus 16 mm. Uh-oh. Edit. Okay, wait. I'll just say that HI. And with that, I'll say that edit constraints. This. I'm not able to edit constraints, and this should be equals to minus 16 mm. This should be equals to minus 16 mm. Okay, and this should be equals to this point. First, let's finish this. Select this and again edit constraint and select the last one. This should be equals to minus 16 mm. Yes, and just say that finish. Okay, so that is how you model a rebar for this particular curve shape. Okay, and that is how I have done it here for all this particular four curve shapes. Now, what left within this is that I have to show you. This is same as strip footing. So if I just take you to the section of this, let me just close this section, and in this particular project, let me just go to any of the floor plan, plinth floor, and yeah, go to this particular section, which will highlight the rebar of that. You see, this is exactly same as the isolated footing. Okay, this is exactly same as the isolated footing. Let me just drag it a little bit. Why am I not able to plinth floor and just take it all the way till this point? Yeah, so see, this is exactly acting like an isolated footing. Each of the step is acting like a isolated footing. That is the only difference. What left is to model a rebar for a typical staircase. How to model this? If I take you to this particular section, then you see this is the rebar for a typical staircase, for a typical flight. So I am just going to show you that, for which I have just taken into consideration this drawings only, wherein we have different sets of rebar along a particular flight. Okay, so that I'm just going to explain you. So let me just go to footing bottom. Not footing bottom. No, we don't need this. I will just go to plinth level. Take this particular section over here, HL, and go to this particular section. but we haven't created a typical staircase. So first we need to create a typical staircase. So I'll just go to plinth level, and that wouldn't take much time. So architecture, stairs, and mm, typical staircase cast in place, plinth floor to first floor, and desired number of staircase 20, which makes the riser height 6 inch and actual tread depth 1 feet, and actual run width equals to 4 feet. Okay, and run left, and railing I don't want, none, that's fine. And I would just create one, or run right, 1, 2, 6, 10, 11. How is this? Yeah, 1 to 10, 14, and 20. Sorry, and just finish. Now go to this particular section, and you see that you have this particular staircase cast in place on site, cast in C2. Okay, this is not a assembled staircase, not a staircase in fabrication, but the um, cast in place means the module is created on site, the concrete is poured, the reinforcement is run, concrete is poured and allowed to settle. So that is this particular typical staircase. So now we need to design a rebar for this. So first is that I will just go to structure and cover, and I will select this particular staircase, and for this also I have mentioned this cover. Okay. Now I will start loading different types of rebar shapes. Different rebar I will just create. You can, these are the different types of shapes. I just drop down and go to rebar shape and delete from 1 to 36 because we are going to create that. Rebar shape 2 is 1 to 36. Rebar shape 2 is being used. Where is it used? No, it is not. Rebar shape. Okay. So delete this one, and from 3 to 36, delete. Yeah, fine. So what does the section here says? So that will be the first step, this particular thing, which I will isolate. So that will start from the top of the staircase and come here and get model like this. So first is that we are going to design that, or actually we can use this set as first set, HI. Okay, yeah, so this is going to be the first shape. Okay, so let's go to section 1, and herein I will just say that rebar, and you have uh, placement, and this time I'm just going to, we have used this free form, you have used this existing, now this time I'm just going to sketch. So sketch, and with that particular sketch I'm first going to sketch the shape. So see, as soon as I click this particular staircase, the cover get activated. From there I'm just going to draw from here to here and continue along this particular segment. Come here, and roughly according to the dimensions provided by the structural engineer, you can manipulate this length. Okay, right now I am just showing you the basics and fundamentals, that how can you draft this rebar. Okay, and let me just snap it, and I will just move it on the top of that particular, because it will also have its own thickness. Fine. So this is going to be the first set. It is going to be a 12 mm or 14 mm, whatever, or 16 mm, depending upon the designer. And I'm just going to finish that. This is going to be maximum spacing of 200 mm along that length. Okay, the next set will start from the bottom of this. So let's say that rebar, again select this particular staircase, sketch, select this particular staircase and should be along this top. Yes, just click, drag it. It loses. Okay, and create one over here. This should have been actually okay. I will just select this and move it a bit again because it will have its own thickness. Then this should go all the way till this point. CS, continue. Sorry, line, draw from this end and conclude. Okay, also snap this a bit down. Okay, so this is also going to be, let's say that 12 mm rebar. Size will be decided by the structural engineer. And this would be maximum spacing 200 mm. Okay, let me just edit this sketch. Take this a bit above. Yes, also this shape. Yeah, fine. And finish this edit sketch. This I can just take it here. In that case, this also can be taken up to this point. Okay. So this is the two different sets of rebar along a inclined flight. Now we need to lay the other members. So I will just select this particular rebar and now I will select a 8 mm rebar. Okay. And this is going to be M-0. And I'm just going to place one over here along this cover, this part. Okay. And I will just say that this should be equals to maximum spacing, but it is not following the orientation. So just say that rotate. Uh, it should follow the orientation. Why it didn't? Maybe I will just again say that structure rebar M-0, and if I just place it along this edge and just say that maximum spacing. Okay, let's not waste time and select this and rotate it and slightly align it with this face. Rotate and not working. Maybe let's try once again. Rebar, and this time I will host that particular thing here on this face. Let's say that maximum spacing. Yeah, see, is equals to 200 mm, and select this bars and drag it till the top of this or as per your design, and this will come here. Just copy it and move it roughly on the top and then just adjust it, drag it till this point. Okay, fine. And I guess this should move a little bit. Yeah, okay. Also, we need to place it here. So again, I will just say that structure rebar M-0 and along this flight here. And here this is, it is going to be fixed number, 3 of them. That's fine. I'll just snap it And I'll just copy it, CO, from 1 to 2, 3, 4, 5, and 6. Here it will not come, or here maybe. No, that would incorporate for that another flight. Okay, so now one more shape. See this HR, this particular shape for proper structural formation. See, this is that particular shape. Okay, so we are just going to do that for structure and rebar. That is again going to be maybe 10 mm, and it is going to be a free form sketch. So I will just select this particular staircase so it activates the cover. I will draw from here to here. Maybe first let's do it for this one. Okay, and just let it go all the way till this point. Li, give a little bit of bending. Okay, uh, this is how you can create this type of different shapes. Okay, so that's fine, and just say that finish, and just select that, and just say that maximum spacing is equals to 200 mm. Is the shape correct? Let me just confirm. Yeah, it's perfect, but just make it overlap and weld with the corresponding bar. So for here, I will just say that edit sketch, and this should actually go here like this. Okay, and once done, you can copy it from one step to another step. Okay, so this is how you create a rebar for a typical staircase for one flight, and the same process follows for all the other flights. So in that case, what I will do is that uh, select this particular staircase. I just want to see the staircase. So select HI. Select this particular staircase, filter. Oh, but yes, since we made HI, let me just get rid of this particular section box. CC. And let me just select this particular staircase and just filter, check none, structural rebar, apply and OK, and just go to visibility stats, view unobscured, and just say that OK. So that is how R enter. You design a rebar for a typical flight of a staircase, and this same position you have to take it from this flight to this here and from this to this. Okay, I can show you this particular thing here in this. See, the same thing has been achieved. Let me just say that VV filters and ground floor, plinth floor staircase. Yeah, apply and OK. So you'll be able to see that that particular thing has been modeled here in the same manner. Let me just VV filters, slap top, apply, and only the plinth floor staircase, apply and OK. So see, okay, clear? Okay. So that was all about a little bit insight and overview of how can you model rebar in Revit using the tools and functions of Revit if you have the drawings provided from the structural engineer, depending upon the drawing. Clear? So let me just close all of this and putting bottom, and let's come to here, our project. Okay, fine. So yes, one thing left is that how can you model rebar for a wall, for a wall, and also this area reinforcement. Area reinforcement is very easy. For example, if this is the PCC layer, if this is the PCC layer, and in order to avoid settlement, if we generally PCC doesn't have a reinforcement, but in order to, if this is the ground floor and there is a soil filling, compaction is done, in order to avoid settlements, the minor bars are provided on the bottom. So how to provide that particular thing? So you let's go to this particular structure, and under that you have this area reinforcement. Okay, area reinforcement, and just select this particular thing and just rebar line. I will just click this particular thing. One, two, three, and four. And I'll just close this, have a close shape. Okay. And just say that this is the major direction. That's fine. And I'll just say that finish. Now you can model according to your design that what should be the top major bar equals to. Okay. For example, right now, this since this is the PCC, so I will just say change this to uh, I will just say that I don't want the top major bar, neither I want the top minor bar. I just want the bottom major bar, which is equal to 8 mm, and the spacing should be equals to bottom major bar, spacing should be equals to 200 mm, okay, and bottom minor bar, that also spacing should be equals to 200 mm. Oh, none, here we have to change 200 mm or 250 mm, whatever, depending upon your design. Okay, and with that, if I just select this and filter, mm, select this filter and structural rebar, I will just go to visibility stats, view unobscured, and just say that okay. So see, this is how you place a reinforcement for a typical slab and a floor in Revit. Okay, and the same way you provide the reinforcement for the wall also. Area reinforcement, you have to select the first. First is that you have to select this particular wall and turn it into a and tell Revit that this is a structural wall. There is a retaining structural wall. And with that, if I just come here to structure and rebar, this area reinforcement tool, I can just select this particular wall and just same way I did for the floor plate, I can draw here for this particular wall also. And if I just say that exterior major spacing to be say that to 300 mm, and this to be 12 mm or 14 mm or whatever depending upon the design, and this to be 250 mm, and likewise here to be again interior direction to 8 mm and with spacing of 300 mm, and depending, I'm just randomly selecting the figures right now, so 300 mm, and just say that finish. So the rebar has been hosted for this particular wall, and filter, check none, structural rebar, apply OK, and change this visibility stats to view unobscured. Okay, fine. So you see that this is how you provide a rebar for a particular structural wall, whether it is lift shaft or a retaining wall or whatever. Okay, so this is how I have created the rebar for here, this walls. See, I will just say that VV visibility graphics filters and change this to and just say that swimming pool and water body slab and its retaining wall. Both of that I will turn on, apply and OK. So see, also on this particular wall, after providing the reinforcement, you can also provide just as you provide for column, the shape T1, 17A, sorry, 17A, you can provide it for that. Okay, so that concludes the complete structure part for the entire project. That is the core structure, that how to create this particular core structure here in Revit HR. Okay, and I will just select this everything, filter, check none, and structural rebar. I will select all of them, apply and OK, and I'll just right click and hide in view by category so that we can focus on the modeling part of the architectural elements. So let's start the modeling of the superstructure. That is all the finished architectural layers attached to a typical floor or wall and everything. So for that purpose, what I'll do is that first is that I will, from this particular 3D, I will just make a cross window and select check none. And I want to hide all the DWG AutoCAD drawings from this particular workspace and clear it a bit, hide in view by elements. Okay, so let's go to this particular reference project. And herein, what I'll do is that I'll select this particular one floor and IC, that is isolate category. You can do it from this eyeglasses also. So I just added a shortcut. So IC, so that will isolate all the floor plates from which I'm just first going to focus on the finished layers of the ground floor. Okay, so let's keep this open and go to our project from which now we will not touch this discipline structural plan. Now we will work with this particular architectural segment floor plan. First, I will just go to ground floor layout. And under that, if you see that, if I just click realistic R enter, then you need to provide the finished flooring layers of this particular pathway and this swimming pool tiles, water body tiles, etc. on this particular ground floor. So what I will do is that here again, I'm just going to use the features and functions of Revit for the easy modeling part. For example, this is the PCC layer of PCC, which is done on the particular ground. After the back soil filling and compaction, the layer of PCC had been done, wherein the minor reinforcement has been provided to avoid crack. But on the top of that, we will also have some finished flooring layers. So what would be that? So I will just use this particular and just say that copy to clipboard, and I will just say that align to same place. So what that would do is that that would make a copy of that particular floor on the same place, but I will just elevate that particular floor plate to 1.25 inch from that particular level, and with that I will change it to this particular flooring, that is entrance pathway. So what does this entrance pathway says? If I just go to edit structure of that, so that is nothing but the on that particular layer of PCC, we have the binding element mortar 12 mm and then the finishing tile, wherein I have used this particular material. You can use any as per your convenience, but I have used this particular material for that particular flooring. And with that, I'll just say that OK, apply and OK. So if I just, you see that that particular thing has been created. But from that, I will just say that edit boundary and HL. I will just snap it. Okay. And from that, I will also get rid of this particular thing. Keep one line, delete and TR and join this to this. So this would only be the pathway. And I will just delete this as well. Okay. So this is how you can use the features and functions of Revit and finish. So that would make it this particular flooring of pathway. So if I just take you to this particular section, and if you see this particular section, then what do you notice is that I'll just hide category and hide category CC. So you see that this is the layer of PCC, 4-inch layer of PCC. See, right now I've selected the layer of PCC. On the top of that, we have this finished flooring entrance pathway, which is at the height offset of 1/4, the binding of which says that this is half mm mortar and 19 mm tile. Okay, so that's as simple as that. So now what I'm going to do is that we are just going to lay this parking quota and this gravel. So again, I will select this particular same, or actually let's select this and make another copy of that, copy to clipboard, paste, align to same place. So the another copy of bin has been created at the same place, but that I will just turn it to parking quota, okay, which has the same construction, 1/4 half mm mortar and 19 tile, parking quota tile. And for that, I have applied this particular material. Okay, fine. So that has been created at the same place. I will just select this and parking quota. I will just edit boundary and HL. And from that, I will just snap. I'll pick lines and I'll snap to this point. TR and join this to this, join this to this, join this to this, and join this to this, and rest delete all of this. And just say that finish. Structural span direction, yeah, fine. Span direction is this. Okay. R enter. So you see, this is how you use the features and functions of Revit for easy modeling. And the last one is this particular gravel. So for that purpose, what I will do is that here again, I guess that, let me just check. Yeah, this is ground floor wash area. Okay. The construction is same, so it doesn't matter. This is gravel. Okay. So I will just go to ground floor and select this particular thing. And again, say that, just copy to clipboard, align to same place. Give it an offset of 1.25, that is 1/4, but change it to highlighted floor overlap, that's fine. And drop down and change it to the copy was this gravel. Okay. And just go to edit of this. The same construction, but only the finishing material is different. This is, what do we say? Pebbles. Pebbles. Okay. So material of that, the existing material of Revit, apply and OK. But from that, I'll just say that edit boundary and I will get rid of this. At the same time, I will HL get rid of this particular part. Okay, and I'll just draw a line from here to here and just conclude it. R enter. Okay, so you see that this particular flooring has been created. Now the same way, now this I don't need to copy to clipboard, I can just create one. So I will just go to architectural, and this time I'm not selecting the floor from structure because it is not a structural floor. I'm just selecting it architecture, floor, floor architecture, and ground floor, ground floor wash area. This particular material and give it an offset of 1.25 and just create a simple rectangle, HL, and finish and done. Okay, R enter. Yes, done. Now we have to create the finishing material for this particular swimming pool tiles, swimming pool and water body area. Okay, so this I will just come here, and again this is a swimming pool and water body concrete slab. So what I will do is that again I will make a copy of this, make a copy of this and align to same place. So that will make a copy of that particular floor on the same place. But this I will give it an offset of 2.5 inches from that area and just turn it to uh, where do we have the finished flooring for water body? Water body base plate, and is this water body base plate? Yeah, 2 inch. No, that is not the one. Water body swimming pool tiles. Yeah. So see here on, now that is not the layer of PCC. The slab, this is the concrete slab which is casted supporting this particular retaining wall. Okay, so reinforcement will be passed along that particular slab. So on that particular slab, we will have sand bedding PCC for leveling, which would be 30 that is 1.25 inch, followed by 12 mortar and followed by 19 tiles. Okay, this is just the basic formation which I am following, which might differ from designer to designer. Okay, and 2.5, fine. So what I just need to do is that edit boundary and HL snap it. Okay, yes, and here too. Uh, yes, and here too. Okay, and just say that finish. And now if I just click R enter, you see that those particular China mosaic flooring for that particular swimming pool base plate has been created. Okay, now again on this wood on the top, if I just take it to this particular 3D, this layer would be again on the top, but that would turn to water. So again, I will just say copy to clipboard, align to same place, but snap it to plinth level. Okay, perfect. And just change it to water. Yes, with it nothing but just material of water given to that particular thing. Okay, just escape. Fine. So that concludes. But this particular thing, I guess that edit boundary, and we will HL get rid of this particular from this, and just say that TR and join this to this. And just say that finish. Don't attach. R enter. Okay. Yeah, that's it. So now we have a living room floating on the water body. So this is how we concluded the finishing layers of that particular ground floor. Now we need to move further to this particular plinth level. So I will close this drawing and now we will shift to plinth level. CC, consistent colors. Okay. And I will just hide the unnecessary elements, hide category HC and also this. Oh, okay, fine. And I'll just turn it to hidden line. Yeah, fine. So here there are lots and lots of floorings which we need to place. For example, you see that you have this plinth floor entrance and spill out decks. Entrance and spill out decks. Okay. Then we have this pool deck. Then we have this private areas, plinth floor private areas, which are for bedrooms and etc. These are the public areas, plinth floor public areas. Then this is plinth floor washroom areas, which doesn't have a drop slab. Why it doesn't have a drop slab? Because it is resting on a plinth and which is have a filling, a plinth of 2 feet which has a filling, so there is no drop slab over here. The water will penetrate directly in the ground. So we have not taken into consideration the drop slab for this particular washroom areas of plinth floor because it is directly connected to the ground. Then we have this public areas too. So these are the different floorings with different materials which are directly hosted on that particular PCC. Okay, there is no RCC slab casted on that particular floor. There is directly PCC done and reinforcement only along the periphery and the intersection of beam column. So after the layer of PCC is done, we directly need to lay the flooring. Okay. Uh-oh. Undo and undo. Fine. So now we will draft this particular different finished flooring for this particular plinth level. So let's quickly start. I will just, what I will do is that I will just HI, okay, this AutoCAD drawing, VV, and I will turn this ground floor layout to halftone. Yes, so we can properly visualize. Now I will come to architectural and all will be the finished flooring layers. So floor architecture, this is plinth floor entrance and spill out decks. So edit and the thickness is 1/4 mortar and plinth floor entrance spill out. I'll just go to in this particular material has been applied. You can apply any material. That is not important. The formation is important. This is important. Okay. Apply and okay. And I'll just drop a rectangle from here to here. will be here as well, and also it will be here and here. Delete, delete, tr, join this to this and join this to this. And I'll give it a height offset of 1/4 from that particular plinth level because it is a finished flooring. And I'll just hit the checkbox. Don't attach. R enter. Fine. So that particular flooring has been laid. Now, uh, we need to, let me just check. This much is plinth floor, public areas too. Okay. So let's go to architecture and floor architecture. And now this will be the plinth floor private areas. And I will just snap this rectangle from here to here. And also get rid of this column, split, tr, join this to this and join this to this. And likewise, we have one bedroom over here also. And this multi-purpose room. Okay. And that's fine. Okay. And 1/4 and just say that finish. Don't attach. Likewise, I will again say that CS, that is create similar, but this time I will use this public areas too. And just drop a rectangle from here to here. And this particular part, this inside it into it. And here also, I guess, no, here there's a water body. So informal living, let me just check. Yeah, informal living also has the same public areas too. Yeah. So rectangle and from here to here and TR, join this to this, join this to this. So only the finishing material for all this other different types of flooring are different. Otherwise, the construction path remains the same. That is mortar followed by the finished flooring on that particular PCC. See, only the finished flooring differs. Rest everything remains the same. And don't attach. And now the CS, and this would be public areas. So here we will need a little bit of drafting. First, let me just drop a rectangle from here to here, and then just 1, 2, 3, and TR, join this to this. LI, I will draw from here to, sorry, here, and the snap point is here. From here, okay, and just following the footprints of the floor plan. Mm, yes, actually this entire area and line. Okay, and this dress too. Don't worry about the walls, with that we will exclude with join geometries. And split, TR, and join this to this, join this to this. And somewhere I was, this is the courtyard, fine. So here also there will be, okay, and split this TR join this to this and this to this, and this should snap to the line of wall. Okay, so this concludes also this one area along with 1, 2, 3, and 4. Split, join this to this and this. So this concludes your public areas on that particular floor plate. And just say that finish. Okay, fine. Now washroom floor plate. Before that, let me just say that CS and pool deck. Pool deck, rectangle, straight away from here till uh, this point. Pick lines. TR, join this to this and join this to this and rectangle. Okay, 1/4, that's fine. Don't attach. And finally, last but not least, CS and plinth floor washroom areas. So that would be from here to here. Sorry, here to here, and this line. Join this to this. Join this to this. Rectangle, and this entire area again. HL, this, and also this, and split, and this to this. Yeah, that's fine. CC. Okay. That concludes the wet areas, and just say that finish. Fine. The height offset for this would be only 1 inch because mortar with the plinth room finish flooring, which will be 12 mm, in order to have a drop between this finished flooring and the wet areas. So that will only be 1 inch. Okay. So that concludes the finished flooring of your entire plinth floor plan, plinth floor level. See. So now let's start modeling the other 3D elements of this particular structure. That is the wall, the finished layers to this particular exposed beams, columns, and other 3D elements of this particular superstructure. Fine. For which we are going to follow the level of detail 400, and we will try to maintain the perfect joint condition with perfect precision. For example, the general method that follows is that when we construct a wall, for example, if you want to construct a wall over here from plinth level to this topmost level, what we generally do is that I'll just say that wall, and I'll just select this particular main 9-inch wall. And what I'll do is that I'll constrain it from plinth level to the topmost level, that is second floor upper terrace. And I will just create a cube hiding the 3D elements in this way. Okay, but is this the correct method of modeling in Revit? Then the answer is no. Revit, as I said in my introduction, is meant for perfect quantification and costing and scheduling of the 3D elements. And for that purpose, the 3D element should be modeled exactly in the same way the structure is going to get elevated on site with all its wrapping layer, perfect joint condition, and perfect precision. With this, you'll not be able to quantify the amount of plaster, the amount of masonry work, and etc. So what we are going to do is that we are just going to start the modeling process with perfection. So first is that what you see is that if I just hide this particular parapet wall over here, then on this face, you see that there are these structural elements which are exposed. These are the beam, ground beams. If I select this particular beam, See, these are the 9 cross 24 ground floor beams. Okay. So here also 9 cross 24. So we need to hide this particular thing with the wrapping layer of plaster to it. It will not have the masonry. So let's begin with this part. So if I just go to plinth level, then herein this is that particular face which is having that exposed surface. So what I will do is that I will just go to wall, and herein I will look for beam wall, uh, beam wall, and yeah, beam wall external plaster, but that is for the upper beams. For ground beams, I guess that there is another. Yeah, see, ground beams external wall plaster 1 foot, and ground beam external wall 9 inch. So if I come here and just measure these beams, for that purpose I need to ground floor level, and herein I'll just hide the unnecessary things. HC height category. Okay. So herein you can see that these are the beams, the ground beams, which are exposed. So I will just say that wall, and I will just select this particular ground beam walls, external plaster 9 inch. So it only has the layer of plaster on the exterior side. Okay, exterior side, which we are going to wrap to that particular beam, because there will be no masonry over there. So apply and OK, and I will just keep it at the ground base constraint to be ground level and top constraint to be plinth level, and I will just start modeling that particular ground beam from this part. Sorry, yeah, from here till this face, and cover all the exposed structure part which will be visible. Here there will be a, yeah, okay, here also. Yes, and in this portion there is a staircase which will have a different wall. So I will not consider that different wall assembly. I will just consider this until here. Okay, and at here the joint condition modify, and click this and just say that disallow join. So this would snap till here, this parapet wall, and here this will be the wall. So now the play here would be that if I just select this particular wall and go to 3D, even the, okay, let me just hide this. And the top constraint, I guess that to plinth level with the top offset, I forgot to remove the top offset. So just select all that particular walls and just remove the top offset. Okay, so I will just select this particular beam, and also I need to select this, and isolate category, but that will just isolate the wall. So I will just make a cross window over here. Yes, and then just say that isolate category. No, but that has selected the floor. Sorry. Mm, let me just go to ground floor and just make a cross window here. But before that, let me just turn this to CC, hide this floor, and then make a cross window. Come here. Okay, and I see that it isolate category. Okay, perfect. So with that, now you see that the layer have plaster has been wrapped to this particular beams, which we need to join the perfect join condition. So modify, join, select this particular beam. See, watch this point. It should read ground beam, press tab, concrete rectangular beam 9 cross 24, and join it with this. So see, only the layer of plaster is wrapped to that particular structural element. Okay. Likewise, just join this uh, concrete rectangular beams. Yes, everywhere, wherever needed. Here, you need to join it with columns that we will do later. First is let's complete this particular part. Okay. Yes. Okay. Mm. because it's that particular plaster layer belongs to the wall category, so everything is visible. But I will just try to make it as simple as possible. Yes, okay. Here there will be no. Here we need to join. Here we need to join. It is difficult to select that particular thing from external face, so we need to select it from internal way. It is slightly difficult, but just try to follow. Maybe what I'll do is that I'll just hide this beams and the compound wall as well, HH, and hide this HH. Yeah, so it is now, I should have done that earlier. Fine, doesn't matter. And join this to this, and also this beam with this. Uh, yes. Okay, so only the layer of plaster is wrapped to those particular structural beams. Now I'll just go to ground floor, and you see that there are columns also which needs to be joined. So I will just say that join, watch this point. It should read structural column to this particular wall. Okay, structural column to this particular wall, and only the layer of plaster is wrapped. See, perfect. Here, okay, yeah, fine. So that's done. So this way we have to proceed further. So now if I just say that HR, you see the layer of plaster is only been wrapped to those particular structural elements which are visible. Here, here there will be a another different wall assembly for this staircase portion. So I have not wrapped layer of plaster to that, but here I have. Okay, at some places you see that, yeah, you need to join it here as well. And if I just say that HH, yeah, fine, it is perfect. Fine. So no issues. HR. Let's proceed further. Now we have to start modeling of the walls. So as I said, the walls should properly be constrained exactly the way it is going to get construction on site. For example, here there will be the masonry part. So the wall should only be in this portion. So I will just go to ground floor, not ground floor, plinth level. Okay. And now I'll just say that height category. Okay. And I can see the footprints of the realistic and okay, I can see the footprints of the beam, but I don't have AutoCAD drawing. So let me just turn on HH and AutoCAD drawing. I guess that where did the AutoCAD drawing go? Yeah, it is here, putting up at ground floor level. I'll just bring it to plinth level, the ground floor layout. Okay. With that, yes, the AutoCAD drawing is now visible here. I will again turn off this bulb. Fine. Come to plinth level, and I will just say that select this particular floor plate. And this is the floor. So I will just say that height category. You can do it from this eyeglasses also. Just say that the shortcut I have entered is 8C, that is height category. So the drawing is clear now. Only the AutoCAD drawing is visible. I'll just go to VV, import categories, and turn this ground floor layout to half tone here in this view. Fine. So now start the modeling of walls. So wall, and this time it will not be the ground beam external wall, but it would be main wall 9 inch, which has the layer of plaster on both exterior and interior. Ideally this should be 19 mm, that is 0.34 of an inch, 3/4 of an inch, 0.19 mm it should be, and this should be 12 mm. And here is the core masonry part, but just for the sake of easy workflow, right now I have taken it half inches, 12 mm on both the sides. Fine, apply and okay. So now if I construct this wall, then it should be from plinth level to first floor, but the top offset should eliminate the beam depth. So beam depth will also have the layer of plaster wrapped to it. So it should be minus 18. That is 1 foot 6 inches plus zero point 0.5 half inch of the plaster. That is minus 6.5 inches. So that makes it unconnected height 8 foot 5 inches. Okay. So I will just drop that wall from here to here. And let me just turn it to hidden line so you can see that this is masonry. Okay. And let me just do it for this part. Here there's a cutout to enter in this particular formal living. Then from here to here, this point to this point, and I will just go on constructing the wall following the footprints of the floor plan. This would be from here to here, and say the overlap walls because this wall, the walls, RCC walls had the top offset of 3 inch. That's okay. We will join geometry and get rid of that. So don't worry. I'm just right now taking into consideration the external walls. Okay, and from here to oh, let me just hide this grid lines, HC height category. Yes. CS and construct from here to here and from here to here, from here to here and here to here and here to this point and this point to here and this point to O and CS, that is grid similar from here to here, this point to entirely till this column and kitchen wall, this wall from here to this point. Here there will be a special wall which we will build in the end after we complete the modeling process of rest of the other structures. Now this here there is a lower wall which will open up into this double height space. This courtyard, this common toilet and this washroom will have the low height wall. So what I'll do is that I'll just change this. First, let's see that if we have any other walls which are full walls. So let us just first construct that. And from here to here, and this to this. This will also be a lower wall, parapet wall. Okay, we are done. So now I will do what I'll do is that I'll just change this particular thing to unconnected and unconnected height to only 3 foot, and that would only be a 3 foot wall here. At the same time here as well. Okay, fine. So it will not show the hatch pattern because it is a lower wall. Now, what you notice is that at few junctions, this particular wall has been joined. When we draw in loop, it connects. So we just need to go to this particular wall joint option, go to that junction and just say that disallow join and just snap this here, snap this portion here. Okay. And likewise, let me just check everywhere it is. Yeah, here, see. So just say that disallow join, snap this here, snap this portion here and join geometry, join this to this. I guess I forgot for this. Yeah, join this to this. Okay, and here too. So wall joins, disallow, and perfectly snap, join, and here too, disallow, okay, and join. Okay, rest everything is perfect. No issues. Fine. So now let's build the internal walls. The internal wall. There are some places you see that there are internal walls also. So I will just say that WA, and from this I will just select this internal wall 4.5 inch, which is the same assembly, only the thickness here has been reduced to 4.5. Otherwise it has the same material, that is this wall paint, which is nothing but just a paint, but in graphics it has the cut pattern. which resembles to something like we draw in AutoCAD, which depicts like it is a wall getting cut. Okay. And this plaster is again the same wall paint, but it doesn't have a graphics cut pattern or anything. Fine. That is the only difference between the main wall and the internal wall. So I will just come here and say that this would snap exactly to the first floor with no offset because there will be no beam network along that face. At some point there will be, so I need to check where it will be. So I need to go to ceiling plan of plinth level. Let's check that whether there is a beam in this area. Yeah, there is a beam. See, there is a beam here. So the internal wall here, let me just hide this floor, H. So the internal wall here only will stop at beam bottom. See, but at some places, actually, I guess that there are no place where the internal wall is exactly going up till the slab. Here, I guess. No, but here there is also a beam. See, okay. So, see, we are working multidimensionally. Mm, okay, fine. Let's say that WA, and I will just say that minus 18.5 inch. Okay, and let me just draft here to here. Let me just connect this. Okay, CS, that is create similar, join this. So again, it gets wrapped. So just say that disallow. In order to do that later, first let's conclude, do it here itself. Okay, CS, and here also there is internal wall, and here also there is internal wall. Let me just connect it from this point. Okay, fine. So let's just check in 3D this part. Okay, perfect. No issues. Fine. Let's go to and construct the other required walls. Example, we have a store wall 1 to 2 and 1 to 2. And we have a wall over here which also has the beam. Okay, so we are completely done with the snapping of the walls for that particular level. Okay, clear? But now what you notice is that this particular structural elements are still visible. This column, this beam, everything is visible. So what to be done in this case? We cannot draw the wall over there. So what? Just like beams we did for this particular beams, we also need to do it for this particular columns, exposed columns. So I will just go to plinth level floor plan, and here you see that under architecture, you have this column. You have the structural column also and architectural column also. The purpose of the architectural column is that right now I'll just select this 24 cross 24. And if I just snap here, you see that it get embedded within the wall, depicting that here there is a column. Okay. So what we will do is that we will select this particular column. First, let me just select this particular column, SA, and uh, no, but that will not be visible. So fine, let's just column and column architectural. And I will just select the column size is 9 cross, the column size is 9 cross 18. So in order to wrap the layer of plaster around it, the column size should be 10 cross 19, typical. If I just go to edit, you see that the layer of plaster has been applied to it, and the depth is 19 inches and the width is 10 inches. So half mm plaster on both the sides. So with this, I will just say that height up till, let's take it directly to second floor upper terrace, because we will need to flush it, because every time we don't need to, let's do it once and for all. So I will just snap to this particular column. You see that it got easily snapped, and the layer of plaster wraps with the layer of plaster. So one, I just press space and flip the direction 2, 3. You need to be very careful. 3 and 4, 5, 6, 7, 8. Likewise, all the columns I will do. This will be vertical. Okay, yes. So see, you need to be very careful. And finally, we are done wrapping the layer of plaster to those particular exposed columns. Here it is left. Here one left. And here too. No, here I have already done. Okay. So now one is left. Yes. You need to be very specific. Okay. Now I will just drop down and select the larger size of this because this column sizes are purposely taken larger than the wall because I want to see, because I want to make you clear that if there is a coping for the beam, so you see that the beam on the top of this particular thing is extruding out. So how to, at that time, how to join? So that's why this particular column sizes are 13 cross 19. So again, the constraint should be this particular wall only goes up till first floor. So first floor lower terrace, 1 and 2, 3 and 4. This last one. Too fast. Sorry. Okay. And we are completely done wrapping the layer of plaster to the column. Let's go to 3D. So see, all the columns has been wrapped with the finishing layer of plaster. What we just need to do is that we need to go to plinth level floor plan, hide this particular AutoCAD drawing temporary, and just do the needful join condition at all the places. So modify, join, select, press tab. Watch this point. It should read structural column, join with architectural column. Likewise here too, join structure to architecture, and the layer of plaster will get automatically joined with the corresponding wall. Structure to architecture. Here there is a, let me just delete this. There was no need of deleting, only the wall needs to be snapped up perfectly. Yeah, fine. Okay, again, join structure to architecture. This column, I guess, no, it was perfect only. Join column to architecture, column to architectural column, structural to architectural, structure to architecture, and structure to architecture. Here too, structure to architecture. See, earlier the concrete hatch was not visible, but now it is. Structure to architecture, and likewise, let me just do it for all the columns. And you guys just stay tuned, and I will just quickly complete the modeling part. Join. Okay. Okay. And this too. This also. Oh, I joined it wrong. Press tab until you find structural column and then architecture. Structure to architecture. Cancel. Is this joined properly? Let me just structure to architecture. Yeah, it's perfect. And here too. Yeah, this is left. Tab and join structure to architecture. No, it's a wrong join connection. You should be very particular, while multiple join, I'll just uncheck. Structure. Oh, structure to architecture. Mhm. This one is left. Structure to architecture. Press tab and flip between the different disciplines. Okay, and that is how we have joined all the structural columns with the layer of plaster wrapped with the architectural columns to them. Okay, and HR. Okay, now see in 3D, you see the one uniform surface and the structure is now hidden. Perfect. Okay, at some places, okay, we will do that in ceiling plan. Okay, but now we need to wrap the layer of plaster to this particular beams, just as we did for that particular ground. This particular ground beam external plaster, we need to do it for the first floor beams also. These are the concrete rectangular beams, 9 cross 18 first floor beams. So how to do that? So for that purpose, we will go to the ceiling plan of plinth level, where only the columns are visible. Sorry, the beams are visible. HC height category. Height category. And I just want to see the floor plan. Now, you see the layer of plaster is wrapped here for this particular column, but at some places you need to join here for this beam also. Okay. If you cannot work with this precision, then there is no point working with Revit. There is no point using Revit. Mm, okay. Uh, see, we are exactly following the perfect join condition, following the level of detail LOD 400. Here there is some problem, I guess. See, now it's perfect. This, I guess, join, and let me just select. Yeah. Uh, why is this creating trouble? Where is this column? It has joined incorrectly, so that's why got removed. Yeah. Let me just come here and select this particular column, CS, and just snap it back. Go to planes level. Okay. Join, press tab, structure to architecture. Yes. Perfect. Mhm. And join this. Undo. Join this to this. Yes. Okay. Let me just select structural column and then, yeah. Mm, this is again creating a problem. Which column is this? It is this column. Oh, yeah, here it is perfect. So what's the issue? Join, and let me first select the structural column, but this beam is not joining here. Let me just delete it. And for this column, we will lay that particular. Seems that, oh, the wall is continuous here. Mm, I should stop this wall here and join elements. Wireframe and H. Stop this wall here. CS, create similar, and start drafting the wall from here to here again. Okay. And now HC, height category. Select this particular rectangular column, CS, and place it back here. Okay. And just say that join. Press tab, watch this point. Press tab until you find the structural column and join with architectural column. Now let's go to planes level. Okay. It's same problem. Yeah, fine. Then it's gone. Okay. Absolutely perfect. Fine. Join and join this to this. Yes. And yes. Okay. The material of that parapet wall has been, I guess, transferred to this. See, let's check. No. It is perfect. No issues. Fine. Let's proceed. Mm, is there left anywhere? No. Perfect. Now, let's say that WA, that is wall. And what I'll do is that I will drop down and look for beam wall. Beam wall, this particular beam has the thickness of 12 cross 18. So this will be beam wall external plaster 1 feet. Edit. And here, this will be 1 feet with plaster layer half inch on both the sides. And material, why does not apply the material beam wall external plaster? Let me just check here. Mm, beam wall, beam external wall 13 inch. Oh, yes. So we are looking for a wrong family. Sorry. So WA and that beam wall. Yeah, here it is. Sorry. This beam external. Okay, this is external plaster. So I guess that this wall should be eliminated. Let me just go to wall, basic wall, beam wall external plaster 13 inch and 10 inch. So this 1 feet needs to be eliminated. We will make it if we need it. Okay, but right now, just to avoid confusion, I'll just again click this wall. And now I will just quickly go to beam wall external plaster 12, 13 inch, which has the wall paint of 1 feet and half plaster wrapped on both the sides. Apply and OK. And now, very important, this particular thing should be 8 foot 5.5 inch up to first floor. So that would make its unconnected height 1 feet 16 inches. The top of the law wall, yeah, sorry, 0. Okay, so that would make the unconnected height 1 foot 6.5 inches. Now I will wrap the layer of plaster to this particular beams and you just check. See, one, and we can do this modeling directly in 3D also, but you will get confused. You might get confused. So that's why I'm doing it here in this particular floor plan. Okay, so that is how we have wrapped the layer of plaster to this particular external beams here. See, clear? What we just need to do is that after wrapping it, just join, press tab until watch this point. It should read structural, press tab, structural beam 12 cross 18, and then join it to beam external 13 inch. So this to this to this, is to this. Fine. So this is how we have to do the modeling for all the 3D elements. So I will just select this particular beam and now we will do it in 3D. Select this and just say that IC, isolate category. Just hide the rest all other beams, HH. Also hide all this particular unnecessary elements, HH, HH, yes, fine. Also, let's hide this. And only let me just select this particular main wall, SA and HH, that also. Hide that also. Only I want to see. Yes, perfect. Okay, this beams I wanted to see, and also this particular beam external wall. Okay, so now what I'll do is that quickly I'll just say that wall WA, and this sign I will select not this because this were the greater beams, bigger beams. I will explain you in section. But these are the smaller beams which are only of 9 inch cross 12. So for that, the beam external plaster would be only 10 inch, which would have the thickness of 9 inch with half inch on both the sides. Okay. So this is the dummy wall we have created, the false wall which is acting as a plaster layer for this particular beams. And with this constraint, what I'll do is that I'll just snap. Let me just say that core face exterior, 1, 2, 3, 4, 5, 6, and do it for all the exposed beams. This got both of this actually. CS, select this wall, beam wall, CS, and pick. Uh, mhm, yes, okay. The location line should be core face exterior. Just make sure that. Here it is, grabbed. Hmm. Yes. You will understand once you complete the modeling process, and I will show you this particular thing in section with perfect joint condition. Okay, this is left. One, two, three, three. Okay, done. Fine. With this now, what I'll do is that I will just use this particular join and join all the structural members with the architectural members. So see, automatically it gets perfectly. You'll understand once we'll see this particular thing in section. Okay, we are almost done. Just stay tuned, and wherever needed, we will join that particular thing in section, because some junctions will be left unattended. For that, we have to do that particular thing in. We have to work in multiple views, multidimensionally. That's the only way out, working perfectly with Revit. Mhm. Press tab until you find. Okay, forget about this too. Okay, I guess everything is done. What left is only this two. So why are they creating a problem? Let me press tab. Uh, we will do this particular thing in section. Fine. So this is how I have wrapped the layer of plaster to all the exposed beams, structural framing. Fine. And let me just click HR. Fine. So you see one uniform surface. And at some places, we also need to join it in section with the floor. With the floor also we need to join. Okay. So what I'll do is that I'll just select this and I select category, select this floor plate, HH, and I will just say that join, but this time I will use this multiple join, select this particular floor, and at one shot, I will get rid of the overlapping volumes. Join 1, 2, 3, 4, 5, wherever necessary, I'll just get rid of it. See, perfect. Yes. Join 2, 3, 4, 5, 6, 7, and this 2. Okay. CCR enter. Join here also. Mhm. And here there is a drop slab. So when we do the modeling of the floor for that particular drop slab, we'll get rid of plaster from here as well. Okay. But right now, this I guess is perfect so far. Let me just turn on HR. Okay. And let's just try to visualize this particular thing in section, that it is perfect or not. Section at multiple places. Let's start from here. The view range is perfect. And let me just say that height category, and also the AutoCAD drawing. Let me just uncrop this particular view and select this entire chunk, filter, check none, DWG files. I will just select all of them and apply OK. And with that selected, I will hide in view by elements. This is left hide in view by elements. This also. Oh, why did that happen? Hide in view by elements. Okay, so here we have to check the perfect join condition in section also. So you see that at some places this is left because here there is a drop slab. As I said, when we'll come to that laying of the floor plate for a typical drop slab, we will get rid of the plaster layer from here also. Rest, everything is perfect so far. Okay, let me just go to floor plan. Let me just take this particular section over here, join, and let's get rid of, see, this is left. I'll just press tab, join this to this. Yeah, get rid from here. This is drop slab. So when we will do the modeling of the slab for that area, we will just, mm, okay, this is perfect. Let's just take this section over here. Perfect. Yes. This is left. What is this? Mm, which is this area? Here it is. So see, here it is left. So that's why H. No, yeah, see, so this is left. So I'll just join, press tab until it reads structural framing. Watch this point. Structural framing, press tab, concrete rectangular beam. Yeah, fine. So it's done now. Clear? Section 1. Yeah, fine. See? Perfect. And this is the stair category, so it will not join with this particular beam. That's okay. Just ignore it. Come here. Again, this is uh, a drop slab. And here, from here, we will get rid once we lay the floor plate for this particular thing. I guess all this wall should connect with this. Okay. Mm, fine. No issues. I guess that this wall should connect with this. We made the, 8 minute. Let me just select this, all this walls, SA. No, but now it will create a problem because there are beam walls also. Doesn't matter. Let's just do the required changes wherever necessary. And here, see, I need to snap this wall here and join this to this. We selected the wrong constraint. This constraint should be not minus only, doesn't matter. I'll take into consideration this part for the upper floors. Yes, here it is left. Okay. Structure should join with structure. Here it is left. Okay. And this wall should go and join this to this. Okay. This wall also should go here. That's ugly sound. Okay. Here, this should start from 3 inches because this is. Let me just ignore this right now. We will see that later. Where is the section from? It is from this point. So this is the ground beam. Which beam is this? Okay. So that also should be wrapped with the layer of plaster. I forgot. Hmm. That this particular beams also should be wrapped with the layer of plaster and this columns also. Okay, fine. Let's first complete with this. And here, Join. Ah, okay. Plinth level. And here again, this wall, I'll have to do it for all the walls. Mm-hmm. Yeah. Also, this slab should eliminate this plaster. Hmm. Okay. I think the wall here also join from this. Okay. Plaster should join with plaster and join this to this plinth level. And again, I need to do that for all the walls. Plinth level. From here, I guess we perfectly. Oh, this is left. And plinth level. Yeah, here it is perfect. And here too. Yes. Oh, sorry. Here everything is perfect. And here we already did that. Oh, here it is left. Here it is fine. Okay. Yes. Okay. Done. Now we need to do the same for this particular, this vertical horizontal segment. HL, HC height category, and just uncrop this particular view and just select all of this, filter, check none, and all the DWG files I will just select, apply, and OK. And with that selected, I just hide in view by elements. Yeah, fine. So one shot it's gone. Just change this to fine. Okay. Here, actually what I did was that for all the walls, I made the constraint -6.5. There is minus 18, 1/4, 6.5. That is minus 18.5. I should have done it -18 only because this layer of plaster will wrap with the wall and join it. So the masonry will join with the column. But oh, that's okay. I won't make this mistake for the floor above. यहाँ पे हो गया है तो we need to rectify it. Oh, join. Okay. See, from this, I also need to get rid of. Why is this layer of plaster visible here? Hmm. So from here it is gone. So why it is not join this beam? And yeah, it's gone. Perfect. This ugly sound. 1, 2, 3, and 4, 5, and 6, all the walls, only minus 18 inches. Okay, so now we can just quickly join it. Multiple join, I will uncheck 1 to 2, wherever needed, 1 to 2, 1 to 2, 1 to 2, 1 to 2. Yeah, that's fine. Okay, so we are done with this. Let me just take this particular section a bit here, and let's just check the join condition. Fine. This wall, I guess, will go till slab, and I will eliminate that thing. Join. Yes. Rest everything. This wall will also join the concrete slab with this wall. Okay, rest everything is perfect. Shift it a bit over here. I see everything perfect. No issues. Okay, this wall needs to be minus 18 inches. Highlighted walls overlap. That's fine. I want them to overlap. Join. Uh, the masonry should join with the concrete beam. Okay, fine. And here, yes. Okay, so see this wall. Hmm. Join. Okay, okay. Done. Again, these two walls. Even this wall. One, two. Oh, sorry. One, one, two, three, four. All of this to 0. Okay. This beam first need to connect with this, and then this plaster layer needs to connect with this. Perfect. Same here. This beam needs to connect with this. Plaster layer needs to connect with this. Oh, all these beams were left. But this is the perfect joint condition and precision with which you have to work in Revit in order to properly quantify the 3D elements. Fine. So we are perfectly done. Last one. Let me just. Okay. Okay, that's done. Let's go to 3D. Fine. So let me just press HR. Fine. And this particular part was remaining. So let's complete it. Let's go to ground floor plan. And herein, let me just hide the AutoCAD drawing. So here are the beams and the columns which need to flush with the layer of plaster. So I'll just go to column and column architecture, and that would be the regular 12 cross 19 typical would be from uh, where the constraint, yeah, height up to only plinth level. Yes, fine. One here over here, another over here, and this one we seen. So that's fine. And at the same time, I'll just say that wall again. That would be beam wall, external plaster, 13-inch. Yeah, no, not 13-inch. Sorry, maybe 10-inch. Okay, and from ground level to plinth level. And let me just check once again in 3D. Yeah, only this much part. Yeah, so ground level with core face exterior, just snap it to here, and from this point to this point. Okay, for this particular columns, I will just keep this constraint to footing top. Also this to footing top. Let's check out in 3D. Yes, that's perfect. But this particular, both the beam walls will be up till plinth level, and yes, 0. Okay, absolutely perfect. Why was this left? Here also there is one column. Let me just press HH. Okay, so CS and okay. This have I provided the plaster here? Yes. So only up till, yeah, fine. Okay. So ground level and just CS and up till height up till plinth level. Mm, okay. One element is completely unjoined. That's fine. And just say that HR. That's fine. Okay. I will just say that modify. Let me just hide the AutoCAD drawing. Okay. And mm, let's do it in 3D itself. For example, I will just say that join. Select this structural framing and same structural framing with, and here too I will just hide this. So join and structural framing with beam wall. That's fine. And this would go up to footing top. Okay, perfect. And let's check out in plan whether it's if not, then let me just join this to this structural framing with this. Oh, sorry, I suppose that it's already joined. And this. Fine. Yeah, this was not needed actually, but that's fine. Okay, chalo. Let's proceed further. 3D. Let me just close this ground floor plan. And let me hide the water body for now. Okay, so far everything is perfect. The only thing that I feel which I missed was, let me just HH this. And this two columns will also go till the slab top. Yes. And also this beams HH. This beam will join. But I need a beam over here. So I will just select this particular beam and just say that copy to clipboard and align to selected level up to first floor. Mm, this is actually at second floor. Oh, sorry. So by mistake, I flush detach, wrong place. Align to selected levels to slab top. Okay. And let me just hide this. TR and join this to this. TR and join this to this. Okay. That's completes the structure. This part was missed out during the modeling. So that's done. And also this particular thing will edit boundary, HL, flush it till this edge, finish, CC, oh sorry, R enter, realistic, this keyboard shortcut that I have entered. Okay, and fine. Also this beams, let me just say that isolate category. This beam here, this beam here will come and join somewhere at this place, because if you see, just see this, then you see that at this we have a beam over here wherein we have this semi-open, what is this, let me just, yeah, semi-covered entrance deck. Okay, press tab until if you want to select any particular item, HR, and where it will be here, somewhere over here. So let me just roughly expand it. Okay, HR, and somewhere till this point, not exactly, it is not covering complete. CS, that is create similar, and I would just create one over here. It's wrong place. Just edit work plane and flush it to first floor, first floor lower terrace. Yes, perfect. Okay, so this is how you use the functions of Revit to perfectly model things. I suppose that this should go a little bit inside. Yes, that's enough. Fine. Okay, HR. Yeah, that's done. Let me just include the layer of plaster to this as well. So just say that CS, but which are these beams? Yeah, 8, 12 cross 18. So 12 cross 18 will not work. We will have to say that wall, and that would be 13-inch. Okay, plinth level and up till first floor, and 13-inch. Pick 1 and 2. No, second up till first. Okay, and let's just change this to first. Okay, fine. Join, press tab until you find the structural element. Join it with architectural, join, press tab, watch this point, press tab, concrete. Uh, I'm selecting the wrong concrete with this, yeah, and concrete with this. Also this to this, yeah, fine, perfect. Okay, that concludes this particular part. Now let's model the finishing floors for this particular topmost layer. So the basics and the fundamentals I have shown you regarding the modeling of the walls, the floors, the joint condition, and everything. So now in order to accelerate the modeling process, what I'll do is that Most of the details I will just copy and I will just focus on the joint conditions. Otherwise, you know that this tutorial will never end in the long tutorial. So regarding the footprints, you have to just follow the footprints of the AutoCAD floor plan at that particular designated levels, whether it is floor or wall or anything. Right now, I will just copy the elements and focus and concentrate on the joint condition, which will eventually help us scheduling and quantification. So I'll just go to this particular complete project, and herein I will just select this any of the floor plate and I select category. We have done it for this particular ground floor. So I will just hide all of this, HH, fine. Now we need to do it for this particular first floor. This slab is also casted. This concrete slab is also casted on that particular first floor lower terrace with the drop slab. What I need to do is that I need to make you understand the joint conditions of this particular this drop slab, the finished flooring layer for this particular drop slab. Rest this will be same. So I will just copy it from this particular project. Come here to let's say that first floor level and just paste this. Okay, and paste it. And from this point, I will just move it. Let me just find a snap point, perfect snap point. Yes, this would be the perfect snap point from here to here. And somewhere I think that it doesn't tally with the AutoCAD floor plan, so somewhere I would be wrong. I snapped it at the wrong place, move it from this point to this point, yeah. But still, I feel that this should be okay. And this too should be here. Select doesn't tallies. This is the perfect place, I suppose. Yes. Okay. Okay. That's absolutely perfect. Fine. So now let me just make you explain the formation of this particular floor plates, which I'll explain you in section. So first, let me just take you to this particular section, which has this lower terrace. And if you just see this first floor balcony, and if you just go to edit type of this, and you see that the thickness of this is 1 feet, almost 15 inches, with this brick beds to lot of uh, considerable thickness, which will be followed by the brick beds for waterproofing, followed by sand bedding PCC in order to level that particular thing, mortar, the winding element, and then the finished flooring for this balcony, first floor balcony, finished flooring. If I just open up, and this is that particular material which I have applied to it. You can apply as per your wish, but I need to explain you this formation. So first I will just change this to uh, regular, let's say that 4 inch. Okay, I'm just saying that okay, apply and okay. And then now let me just go to this particular section. For all the rest other flooring, the one that we kept on ground floor was R enter, not ground floor, sorry, on print level. R enter, that is realistic. This particular finished floorings were directly snapped to the PCC layer of PCC, because on ground floor there is no slab caster because it is directly connected with the ground. So there is a PCC layer of PCC. Onto that we just have the binding element mortar and the finished flooring. But on the first floor there will be an RCC slab casted, which is not uniformly casted, and there is a slightly difference in the gradient of that particular slab. So for that purpose, what we need to do is that all the finished flooring will be sand bedding PCC. This is just ideal. Then a designer can change this according to his or her design. This is just an ideal configuration. There is sand bedding PCC 1.25, that is almost 30 to 35 to 40 followed by mortar, and then the finished flooring layers. Okay, this is the only change. But what important to infer is that learn is that how to lay this drop slab. For example, I just change this to 0. That is offset to 0. And let me just go to this particular section in order to make you explain this particular thing. So right now, this particular drop slab has been placed at first floor lower terrace with 0 offset. Okay. Now there is a drop slab over here. So ideally, this point should come here. And this particular finished flooring, the top of this particular finished flooring should be such that it should have a 12 drop between the finished floor of this public areas, so the water won't penetrate up. And the same follows for this particular toilet areas also. And the same follows for this particular toilet areas also, that we will see later. First, if we are doing this particular thing, then first let's complete this particular part and then we'll shift to toilet areas. The concept remains the same there also. I'll just change this to 0 and edit and change this to 4". Okay, apply and okay. Okay, so now if I just wash this particular washroom floor plate, that too remains the same. See, first floor, and here there is a drop slab, and we need to snap it in such a way that the water won't penetrate up in the living areas, and there is a one tile drop between the living areas and this particular wet areas, dry areas and wet areas. So first I'll go to this particular section, and herein I will just draw a reference plane, draw this particular reference plane and move it. Actually, let me just randomly draw some reference plane over here. HL hidden, RP, uh, RP, and let me just say that PK, that is pick a plane, pick this particular plane and then go to that particular section so we can draw a line. Okay, line, and then I will just move it 12 down for one tile drop. So with that, now what you infer is that if I just snap this point with this, then this is the level we need to reach. So this particular control C, this particular height, I will add to the brickbat layers. So edit, and this should equals to 4" plus control V and enter. That would give, this is how you compute in order to highlighted floor, and that's fine, perfect. I will just delete this particular line and just align this face with this face. So now you see this face is flushed. Okay, so this is how you compute our typical drop slab and provide the layers. Now important is that to join the geometries. So join, select this and concrete, join this and get rid of this. Join and switch order and click somewhere over here. And with this, you will bring the concrete layer, the beam back in place. No, we have brought the wrong layer, not a concrete layer. Let me just click undo again. Yes, fine. Join and first join this with the concrete beams and then switch order, select this and this. Yeah, fine, perfect. So the inverted beam is now in place. Then you join this with this external plaster. Likewise with this, sorry, join this with this and this with this. Now you also need the layer of plaster here in the bottom. You also need the layer of plaster here in the bottom, but that later. First, let me just complete this particular washroom part. So the washroom part follows the same. That is, you have to just go to edit, and is equals to this particular thing plus control V. That will decide the height of the brick bed and highlighted floor appear, apply and OK. And with that, let me just, with this arrows, I will just move it and then I will align. So this, there will be one tile drop exactly between the wet areas and the dry areas. So this is how you compute. Okay. Let me just go to first floor and check out this section. Yeah, here there's a join condition. So join and join this to this particular this is an interesting junction. Join this to concrete beams, join this to the slab, and then switch order, this to this, and this to this, this to this. Fine. Okay. And then join it with and get rid of this particular plaster layers from slab and everywhere. Also, I need to get rid of the plaster layers from this areas. During the modeling part, didn't I say that we will do this particular thing when we lay the drop slab? So, okay, so this is done. Let me just check this particular thing here in vertical section if everything is perfect. Fine. So you see that this and this needs to be joined. Rest everything is perfect. Likewise, same. I'll take this particular section over here. Okay. But here, this face is actually join this to this. Edit boundary. Go to first floor lower terrace. This will pop up here and finish. Don't attach. Then go to that particular section. Already it's joined. Edit boundary, first floor, and here too. Yes, finish. Don't attach. And with that, I will just say that join and join. Okay. So this is how you manipulate this particular floor areas. The flooring of this particular finished flooring for first floor. Now, for all the sections, for example, if you just see this particular section, then there will be a layer of finishing here at the bottom of the slab also. See, everywhere. Everywhere we will need this layer of plaster in the bottom of the slab also. So that you can do by a couple of ways. But I'm right now just going to show you that how can you do it, wherein you see that this is floor ceiling plaster. There is actually a floor plate, half inch. And the reason of this is that it is something related to quantification, and that's why you have to create a different floor plate which is only of 12 mm. But that particular thing should be given a material of plaster. Okay. And with that, you have to go to the reflected ceiling plan, and then you can see here all the slabs have that particular thing snapped to the bottom of that. This is plaster. Okay. This is first floor slab. This is terrace floor slab. Second floor, lower terrace. Okay. On the bottom of that, I have snapped this particular ceiling plaster layer. Okay. I can just copy this in order to just save time because this doesn't need to waste time on the modeling. We have a lot of other things to do. So on the bottom of this is what? First floor slab, right? Yeah, fine. So this particular thing and this, I will just say that Control C. I will come to this particular project and go to first floor. Yeah, paste that ceiling plaster and I will just move it from this point to this point. Okay. And in order to check that, was it perfectly pasted at the place? Yeah, see, the layer of ceiling plaster exactly is at the place where it is supposed to be. Minus 1 foot 6 inches in case of drop slab, and exactly on the bottom of that particular slab with minus 6 inch. Okay, only thing is that this material I will just change it to one plaster, half inch. Okay, apply and okay. Fine, clear. Now let's proceed further. I will just say that a couple of walls, one, two, three, four, all these walls will be common. So what I'll do is that use the features and functions of Revit to snap it to the floor above. So this particular thing will not come. And here, one, two, and then we will draft the remaining walls only. Okay, and this will also not come. So this many walls, I will just say that copy to clipboard, align to selected levels, and snap it to first floor. See? So, I mean, so much labor work eliminated. Okay. One thing is that this particular here, as I said, there will be a couple of walls which we need to draw for this particular level. But yes, here I forgot to provide the finished flooring for the this particular slab. But there you will not have the roof. I'll just go to first floor and I forgot to copy that or what from this particular project. Yes, because that was not of the category roof, sorry, floor, but it was of the category roof. See, puja room flat roof. Otherwise, the configuration remains the same. Everything remains the same. So I will just say that Control C and I'll just come here and paste it here. Okay, put it and then say finish. R enter and just find the perfect snap point. And yes, done. Okay. Let me just check out in section whether it has been placed properly or not. Uh, Let me just go to this particular section and yeah, fine. Only thing is that we need to join the geometries. So this with concrete, this with concrete, this with the plaster layer, this with the plaster layer. Okay. And here there will be a small parapet wall of 15 inches on that particular designated level. But before that, let me just check this. Yes, so see, here it remains. Mhm. Join this to this, join this to this. Okay, done. This will move slightly inside, and that would help us eliminate the layer of plaster. Okay, and join, and join, and join, and this to this. Okay, perfect. Let me just go to first floor, take a check out this horizontal section. Why so? Oh, yes. Okay. Okay. Join this to this to this to this to this. And yes, this is fine. First floor, take this particular section over here. Uh-huh. But there will be, let me check out in 3D. Yeah, okay, fine. Doesn't matter. Check out this face. Yeah, perfect. Okay, so with that, I will just come here to first floor level plan and just say that wall, but this time it would be main wall and with first floor to 0 and unconnected to only 15 inches. That's it. HL, core face exterior, and follow the footprints of the drawing. Perfect. And that's done. 3D. Okay. If you want, you can say that join and have a uniform surface. But right now, let's not waste more time on that. I'll just quickly finish it off. hmm Okay, done. Also, you need to join this, but fine, that's okay. Now, let's complete with the modeling of the walls, which were left off at this particular level. And I'll just select this and I'll select any of the floor and I see the height category so we can focus on the wall. So here there will not be a full wall. I will delete this particular wall and this wall will snap up till this point, somewhere over here. Okay. And this particular wall, CS, will snap from here to here. Okay. Yes. This particular column has been left to assign the copy CO, copy rectangular column, copy it from this point to this point. So on ground floor also, is it left or not? Not ground floor, sorry. Plinth level. Is that particular column assigned with the layer of plaster? Yes, rectangular column 9 to acceptable. Then why didn't continue for this? Okay, fine, doesn't matter. And then I'll just say that CS, that is create similar, and draw that same wall from this core face exterior. The constraint are correct, yeah. From here to here and from here to here. Okay, this is family sitting, so I suppose, let me just say that wireframe, where will the wall come till? HI, the wall, okay, family sitting, so this wall will join here. No, but where this, at least it needs to come till this point. Or actually, we can just, yeah, fine, this is correct. Okay, okay. And then here, there will be a parapet wall, unconnected. There will be a parapet wall at a couple of places. We will draw that later. First, let's complete this. CS and create similar. Draw this wall and join. Press tab. Join it with this. Yes. CS. Draw from here to here and from here to here. Here there will be internal walls and let's close this area. Okay, because this is a lower terrace. And now time to provide unconnected and 15 inches, only 15 inches. Then the glass railing will be provided there. Okay. Uh, why is it overlapping? What it is overlapping with? Let me just check in section. Oh, oh, there is already a wall. There is already a wall provided for this particular cutout. I provided another wall. So let's delete this 3 foot wall and we'll just provide this. Why did this flooring CC HR? Okay, this is the lower terrace flooring, or and I made the mistake for so on plinth level also. I guess this particular flooring was not correctly placed or what? No, it is correctly placed. And we just copied it to a level above. So why it created this glitch? Edit boundary, snap it, finish, don't attach. Okay, fine. Section 1, and yeah, fine. Okay, no issues. Go to first floor again and just select this particular same plinth wall. Uh, this is 15 inches, so this would also follow unconnected height 15 inches. And CS, that is correct, similar. And we will provide that wall here. 1, 2, and 3. Start from here. 1 and 2. Okay, let's go to 3D. Okay, clear. Fine. But we need to create a couple of internal walls. So you see there are a couple of internal walls over here in a lot of places. So yeah, this is also see, yes, there will be a parapet wall here as well. CS, join this to this. Fine. HL, and just say that wall, but this time it would be internal wall, first floor, and up till straight away. Let's take it up to uh, second floor, lower terrace. And there will be no beam over here. Is there a beam over here? I don't know. I actually don't remember. But right now, let's just consider that there is a beam. So I'll give it a negative offset of minus 18 inches. And let's, uh, is there a wall here? No, this is a slab. Hmm, why am I getting confused? Core face exterior. Uh, I don't not. I guess this is the face, I guess. Yeah, fine. And from here to this point. Okay. Likewise, from this to this and this complete. I guess that snap point is wrong. This will come till this point and wall and conclude till this point and here to this point and from here to this point. Okay, so we are done placing the walls for that particular floor plate as well. This particular wall will have what is the minus 6.5, so minus 18 exact, 18 inches, minus 18 inches, yes, minus 18.5. Is it showing a proper joint condition? Let me just check. No, all the walls should be flushed. Exactly minus 18 inches. Okay, so the wall will overlap and then we will have the join condition. Plaster will join with plaster. Yes, so the masonry should join with the concrete. Okay, we need to do that for, let's say that, where was the section taken from here? So let's just check roughly 1.6, 1.18. Yeah, see, this wall, all this walls, minus 18 inches. I'll just keep it. Okay. Mm, yeah, fine. On first floor, plinth level, I'll just say that isolate category. So walls will be isolated 1.6, 1.6, 1.6. Oh, this, I guess that there was a problem for this, all the walls. So just to be on a safer side, I will select all this particular wall once again and deselect this. Okay. And just change it to minus 18 inches only. Okay. Highlighted wall overlap. So in some cases, there might be a problem of joint condition. See here it is perfect. I'll go to this junction. Let me just check. Uh, yes, so here you need to join because fine. And I suppose there will be a only problem with this. I don't think there will be a problem with this. See, this is perfect. Likewise, this also will be. See, here there is a problem of join. And also we need to get rid of this. Hmm. On a safer side, what the harm in checking? Fine. Complete. Perfect join condition. Join and get rid of this. Uh-uh. Okay, this is a ceiling plaster layer and there is a little bit of glitch, but that's fine. Just ignore that. Not important right now. Okay, so we are done pasting the walls for this particular floor. I'll just say that join this to this. Yeah. Okay. Now we have to snap the layer of plaster to this particular join this to this. Yeah. We have to snap the layer of plaster to this particular beams on this particular first floor. Not first floor, second floor. Because it's a slab of second floor and this beam are also of the second floor. Okay, second floor beams, SA. So see, so the second floor beam. Okay, so I will just say that select any of this and mm, any of this beam wall and isolate category, but that will isolate all the walls as well. Doesn't matter. I'll just say there hide all this particular thing and hide all this particular thing. Oh, so now this is the little bit of tough part wherein we need to snap the layer of plaster to this particular beams. And a lot of warnings will pop up, but that's fine. We have to do it. So structure and not structure, we will snap the dummy wall which we created, which will just act as a layer of plaster to this beam. And first floor and 8 foot 5.5 inches up to the second floor with the top offset to zero. That would make it unconnected height 1 feet 6 inches. That's fine. And with that, I'll just set quick lines and it will pop up error. Yeah, fine. 2, 3, and a lot of errors. But we have to do it. At some places it won't, but most of the places it will. Uh, You have to snap to the center of that particular beam. Yeah, sorry. Uh, yes, sorry. It's not finding the snap point. Yes. Uh-oh. One, two, and three. Here it won't. That's great. Mm, sorry. You guys might be annoyed by this sound, but can't help it, guys. Sorry. Because the walls are getting overlapped. It's not yet joined. We'll have to join them in section. That would give it the perfect joint condition. So that's why you see that highlighted walls overlap. This is the warning. It's not okay. Finally. So now what we will do is that we will have to join them at a couple of places here in 3D also, and at the same time in, or we can directly join it in section only, first floor at couple of places. So let's first try with this. Okay, this would be easy. Modify, join, press tab, join this to this, join this to this. Let me just hide category this grid lines. Okay, join, press tab until you find the rectangular column, and then join it with, sorry, tab until you find the structural column, and then you join it with architectural column. This would be easy. Section would be much easy, and just flip. Yes, this face is joined. Perfect. Join. I'm used to it, so I'm doing it fast. You guys will not achieve it, but practice makes the man perfect. You have to keep practicing until you achieve this particular thing. Join, press tab, or cancel, press tab, press tab. Yes, this is done. Here, press tab. Which is this portion? This is the portion where the beam is getting, so this will join in horizontal section. Right now, just ignore it. It was the portion where the see, yeah, perfect. Mm, this we will get rid of once we lay this particular drop slab, so that eventually with that we will get rid of the plaster from this face. Okay, done. Let me just do it for this end, and this is done. Oh, great. Shift here. Okay, okay. Wow. And here there is no floor plate. We have already done for this. lower part. Fine. Mhm. No problem. Yes. Fine. Correct. Now let's do it for horizontal ones. So let's start from this point. This wouldn't take much time. Uh, uh, okay. Link level. Here. Oh, this is a mess. Okay. How much is the view range? Where is the view range for this? This section is showing the view range, but this section is not. Yeah, so it's only up till this point and just, yeah, fine. So join and double click. Here still there's a drop slab yet to be referenced. So that's okay. And first floor here, everything is joined. Okay. Here there is still, okay, fine. Okay. So this shows that there are a couple of finishing layers which needs to be joined when the section is cut exactly from the column out. Join. Let me just hide this grid line. HC. Okay. And that's done. First floor. Yes. Okay. Perfect. Let's finally take it here. Oh, this is left. And okay, done. So we are done with this particular section as well. Let's go to 3D and check out. See, everything is perfectly joined. See, if something remains, that we will do here in 3D itself. Section is the perfect view to do this particular job. See, only the layer of plaster wraps. Perfect, absolutely perfect. This is the joint condition which you guys have to achieve. Fine, and just say that HR. Now is the time to take up the finished flooring. This particular beam will not come in this case because there is no cutout over here. So I will just delete this one. Two, we copied it from the ground floor, so that's why. Otherwise, that beams will not come because there is no cutout over here. There's only cutout on the first floor. There's no cutout on second floor, lower terrace. So now what we need to do is that first is just let's just copy the typical details which will follow on this floor for the flooring. That is, let me just hide this as well. This particular floor, HH, 1, 2, 3, and this drop slab. Just copy to clipboard, align to selected levels, and snap it to second floor, upper terrace. Yes. Okay. But we need to edit this boundary over here. First floor private areas, I will just change it to second floor, which will help us in quantification. Second floor private areas, where it is. Second floor private areas, yes. First floor washroom areas, I'll just change it to second floor washroom areas. Where is it? Yeah, okay. First floor public areas 2, second floor public areas 2, and first floor public areas, which go to second floor public areas, where it is second floor public area. Yeah, that's fine. Okay, but now we need to change it a bit because this floor will not have this. For example, this edit boundary, we will get rid of this, delete, yes, don't attach. Then the edit boundary, delete, yes, attach. See how many labor work is eliminated when you work with Revit. You realize that you can copy details from project to project, within the project to multiple levels and everything. So I will just go to this particular in order to define the boundary for this second floor public areas. I need to go to the floor plan of that particular level. So second floor upper terrace, and there is the AutoCAD plan there over here, HL, and we will have a wall over here. So let me just say that edit boundary, delete all of this, delete this, delete this line. Mm, this will come here, join this to this, move it 0.5 inch. Okay, this will join directly with this, and we will not have it. So this would define the boundary of second floor public areas. That's it. Don't attach. Okay. And now we need to host the flooring for this particular terrace level. So again, what I'm going to do is that I'll just go to this particular project. From here, I'll just copy this 1 and 2, copy it, and come to this particular second floor upper terrace, paste it, and finish 1 and 2, and just move it from this point to this point. Somewhere, I guess there is a problem. Let me just turn on the AutoCAD drawing. Yes, it will snap to this point. Press tab until you find a snap point. Yes, fine. Done. Clear. Height category. Okay, R enter. Perfect. Absolutely perfect. The only thing is that the construction of this shows the brick beds. This layer you can design. I mean, the structural engineer will give you. As a designer, you have to decide that what will be the layer of the brick beds for waterproofing on terrace. I'm just taking it some random figure. Okay. Now let's check this particular section. Fine. So, but this you see that the second floor living areas are elevated uh, to wrong. Yes, so there should be a one tile drop here. So the water won't penetrate into the living area. Likewise, I need to check this section also. Yeah, here it is perfect. Second floor upper terrace, second floor public areas. What is this? Second floor private areas. But this is again uh, 6 inch. Yes. Not 6 inch, which will be. Oh, it was perfect actually. This is public areas. Okay. This has been elevated just to second floor public areas. This is the first floor public areas, 2.5. And this is 1/4. So why is second floor public areas 1.25? Why is the public areas provided with a layer of brick beds? It doesn't make any sense. This is second floor. Oh, just to avoid the water penetrate inside into this particular area, this particular thing has been given the height. The brick bed layers has been given the height. Okay, that is again a structural concern. Okay, fine, doesn't matter. Let me just go to this section. Yeah, fine. Okay, 3D. Done. Okay. What we need to do is that we need to select this particular column. There are a lot of columns which needs to be. So for that purpose, I need to go to first floor, lower terrace, 8C and 8C, 8C. This ugly sound I hate. 1 and SAHI. From this, only this many columns will elevate up to slab top. Let's check out in 3D. Oh, wow. See, using the functions of Revit, the drafting becomes so easy. Why is still this join? Okay, let's ignore this particular thing. Which column is this? HR. It is correct, but maybe it is not joined. Yes, so that's why. Now, if you just HI, okay, perfectly, it was not joined. Fine. So see, certain things you figure out while working, certain flaws, but that can be rectified easily with Revit. Doesn't matter. So now we have to paste the walls. So I will first say that wall, main wall 9 inch. I will just say that 0 and unconnected height of 3 foot. And let's first draft HL, the compound parapet wall. Uh, Line is slightly off the axis. Oh, this is also CS. So you need to find the snap point in order to perfectly snap. Yes. And start it from here again. 1, 2, 3, 4, and 5. This will be joined, I guess. We need to disallow the join and break it and perfectly snap it to the place that it's supposed to be. Forget it. Don't ignore this junction. Once we will draw the wall, so you will. No, actually, it was correct. Not this junction, this junction. Okay. This you need to disallow. Sorry. Let us drag it to place it far apart. And now I'll say that wall, but this time I'll just say that up till slap top, minus 18 inches. Fine. And just snap from here to here, here to here, and find the snap points. HL. Why is this line? What is this line? Oh, so this is a height category for now in order to avoid confusion. From here to here, and from here to here, and from here to here. Oh, okay. And these are the internal walls. This wall will be pertaining on that particular floor below also. So we can copy this peripheral walls. I was just confused. So I will just select this one. I'll just hide category 8C, hide category, turn it to hidden line. Select this wall. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And why not use functions of Revit? Copy, align to selected levels, 2, second floor urban upper terrace. And this was left to join. See, join. I let it. Damn it. Mm, why is this creating a problem? The masonry part should join. Yes. Second floor. And here the same problem. Join, join this to this. Okay, perfect. And you see, we have easily snapped this particular. I will just say that. Was it not there on first floor also? Oh, see, it is here not. It's not there over here. Concrete rectangular column. So might not be there at the plinth level also. No, on plinth level, not here, here. Yes, plinth level, it's there. So what is the problem? Directly snap it to slab top. So first floor is there. Yeah. Second floor. Yeah. Perfect. Okay. So you can so easily work with Revit. Go to 3D. Wow. So we are almost done. Just copy this wall, align to selected levels to second floor upper terrace. Perfect. Okay. I don't want to waste time joining this particular geometries. Oh, this one wall is also left. Copy, align to selected levels to first floor. Yeah, I will just work it out. Let me just delete this 1 and 2. Copy, align to selected levels to first floor over terrace. Okay, yeah, work it out in section. Doesn't matter. Okay, so join and first get rid of this can't cut joined elements. Sorry. Yeah. This is so it should get eliminated from not this, but it should get eliminated from this slab. But slab is not. Okay, we'll do that particular thing in section. Don't worry. Now we have to snap the layer of plaster to beams on this particular surface. So concrete beams, slab top beams, HI, or not HI, I will SA, and I'll also have to select any of this particular beam wall and isolate category. From that, I will hide everything of this HH. And now we only have the beams. Again, the warning message, wall, second floor, 1 feet, sorry, 8 foot, 5.5 inches, slab top, and 0. Okay, and just say that pick lines. 1 and 2, uh, and maybe 3. Sorry, pick lines, and yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, and wrong. It should be exactly on the top of that particular face. Mm, 1, 2, and 3. Wall, and let me just, can I see this? No, I need to go to ceiling plan of second floor upper terrace, and there I need to change the view range cut plane to 9 feet. With that, I'll be able to see this main wall, and maybe I'll snap it all the way to this point. Yes, and I'll snap it all the way to this point. Okay, fine. Now we will do the same process, that we will look for the horizontal and vertical section and do the needful wherever required. So see, join, and this wouldn't take much time because it's just a small area. Okay, yes, okay. And second floor, shift it, join, okay. Second floor, and join here as well, but that join, yeah. Come here, perfect. Yes, and second floor. Now the horizontals. So join. Why is this? There is a problem regarding. So let me just move it somewhere outside, and then have a flushed face. Then to it is, uh, forget it. We'll sort that out in plan. What is the problem? Okay, so that was this. Now I need to shift it to this port. Join. Here it is perfect. See, only one wall alignment might have lost. So that's why, because of the laying of the wall, I might have. And here there is no drop slab because there is a terrace above. So this particular wall will go till this part. Perfect. Oh, we forgot to snap the this particular layer of ceiling plaster to this level, but that's okay. You guys can do it. Okay. Hmm, why is this wall? Which portion is the snap point? Oh, here there is no. So actually, this walls here will go till the top. Yes, because there is no drop slab over there. The slab that the drop slab is over this portion. Okay, and join, join this portion. This wall in this case will come till here only and join. Yes, and this wall will snap till this point. This is interesting junction again. So concrete column with this slab, switch order, sorry, switch order, this to this. Yeah, fine, perfect. Join this to this and join this to this. Okay, so the same condition, but this wall, why is this wall creating problem? Oh, because it is a continuous wall. Yeah, so I was supposed to draw that wall differently for this areas. I'll make you understand. Don't worry. See, this particular wall, I have drawn it continuous, but for this area, you don't have a drop slab, and for this area, you do have. So that's why that problem. So in that case, you have to snap this particular wall here, and from this portion, you'll have to draw that wall differently. But right now, I'm not wasting time on that. Okay, I just made you understand the. Okay, fine. Let's just do it. Let me just go to plinth level, not ceiling plan. That won't take much time. HL and select this particular wall and split it from this point. Yes, unjoin. Select this wall and just snap it here. Select this wall and snap it here and make it a different wall. Now go to first floor. Do the same thing here. Split it, unjoin. Yes. For this part, snap it till this point. And for this part, snap it till this point. Okay. And then come to second floor and we have already done that particular thing here. So for this area, you will have all the walls stopping at beam bottom, or that particular drop slab. But for this areas, you will have all those walls going up till the top of this particular slab. Yes, it's the different joint condition. That's it. Nothing. Okay, fine. HR. And with that, now what was left was this particular section, and we already did it, I guess. Second floor. Let me just. Oh, sorry. Shift that particular section over here. Yeah, see, join this to this, this to this, this to this, this to this, this to this. Yeah, fine. Done. Okay, complete. Perfect. 3D. And you see? Everything is perfect. You have to do that particular thing in section only. And just go to, if something remains, you can just do it, do the needful here in 3D. Mm, okay, the unnecessary layers of plaster. Okay, yes, perfect. Okay, and this is, join from here as well. Yeah, absolutely perfect. See, one uniform surface, and we don't have any issues. And I'll just save this particular project before I lose it. Yes. And now the last step is to create the wall, parapet wall on this laptop, following the footprints of this particular HC height category. And what is this reference plane? So delete it. HR, we don't have the AutoCAD drawing. Okay, fine, doesn't matter. Wall and main wall, slab top 0, unconnected, only 15 inches. It will act as a coping. So 1, 2, 2, 3, 4, 5. I think that I'm selecting the wrong face. No, I'm selecting the perfect. So CS, let's create similar, and TR and join this to this. Go to 3D, and it's perfectly done. No issues. Okay. Uh, Join in order to have the uniform surface, but that you will have to do it at a lot of places. Join, sorry, this join. Mm, yes. At some places it is creating problem. Might be the face is not aligned, so that's why, but that's not important. Fine. Okay. Clear, everybody? Fine. So we are, yes, one thing remains that always does. Select this and Control C, come to slab top, Control V, OK, and paste. Move it from this point to this point. Check in section. OK, perfect. Yeah, fine. So with this now, we are done with the modeling part of this particular superstructure. So let's complete the model by posting the openings and other required details for the particular project. For example, here there will be a special wall, a box wall. So if I just go to plinth floor level, and herein, let me just hide this HC height category. Okay, so let me just clear up the plan a bit. I will just click this wall, WA, and I will just go to that particular box wall. So this is a special type of wall, a special wall assembly which has been created using different layers. See, I'll just show you in plan. So this is the finish two, this particular layer. The core structure is the masonry over here. Then there we have a cavity, special type of wall meant for special purpose, which is then followed by the thermal air layer, cavity, the core structure followed by the thermal air layer, then again a half brick thick masonry, with this particular finishing material section. This is the finished two layer. This followed by core structure, then thermal air cavity, finished by half brick thick masonry, and the finishing. Okay, so that makes it thickness 2 feet. This is a special wall meant for special purpose on special direction. But right now, here I have just incorporated that to show you the modeling part. So that will start from ground road level and up till the slab top with the height offset of something like 3 feet 6 inches that we'll decide later. But right now, let me just first place that particular wall with core face exterior. Let's snap it from this point, uh, this point to this point. Yes. And yes, that was but obvious that will pop up this particular error. But we have to join it. We have to make the perfect join condition. It was not supposed to be first floor, it was supposed to be slab top. Okay. And yes, fine. But we need to create a cut within this particular wall at various levels in order to host this particular curtain wall. If I just select this particular curtain wall, first let me just say that R into realistic, and this is the brick jolly, not brick jolly, but just a jolly screen. So if I select this curtain wall staircase, I'll just say that HH. You see that here are the rectangular cuts at various levels. What is the top offset minus base constraint plinth floor, base offset 9 inch, and top constraint first floor with the top offset of minus 6 inches. Okay. So we need to create this particular cuts along this particular wall at various levels. But before that, first I need to join this wall at, you see the join condition HR. This is project one, yeah, fine. So what has happened with the join condition? Yes, so I just need to say that disallow join. Okay, and with that join disallowed, I will just snap it here and then I will just join it. First, I'll join the core structure with that wall and then I will join, okay, the external layers with this wall. Yeah, fine. Same over here, join core structure with the wall and then extend this wall a bit half inches. So RP reference plane and extend this, disallow. Yes, okay. So it wraps the layer, external layer wraps. Okay. We need to do that at all levels. First floor. I guess that it's done. Great. Second floor. Oh, wow. Yes, but the column is continuous. So the column is continuous starting from base constant print level to laptop. So it's done at all the levels. We don't need to do. The only thing that we need to do now is put a cut along this particular thing. So for that purpose, I'll just go to architecture tab and there's this opening panel. You have this wall opening. Cuts a rectangular opening in the straight wall or curved wall. So I will just select this, click, and just drag it. Okay, this is just a random I have kept. And the base offset should be 9 inch. Plinth level up till only first floor with the top offset of minus 18.5 inches or 18 inches, that's fine, equal to the beam depth. And I'll just copy this rectangular cut, copy to clipboard and paste align to selected levels to first floor and to second floor upper terrace. Now just watch. See, the cut has been created. So easily you can work in Revit. I will just copy this and just say that copy to clipboard, paste align to selected levels, the staircase and the first floor and second floor. The staircase will also get copied. Fine. Fine. Now what is left is to place a curtain wall within this particular opening. So plinth level and just come to say that wall and here you have a curtain wall for a particular staircase, curtain wall staircase, and just if I just go to edit type, it is referencing this system panel glazed dark glass. Okay, the material of glass, dark glass has been applied to that. I will just turn this to slab top with the top offset of 3 foot 6 inches. No, this would be up to this laptop, but with minus 18.5 or 18 inches with a height offset of 9 inch. From this face, what is it? Location line? Oh, the location line here from here to this point. Just see. Oh, perfect. It's perfectly placed. Let's check out in section HR washes section, and you see it is perfectly snapped. Okay, clear? I'll just go to 3D of this. Now you need to place mullions along this configuration in a such a way. Watch this. HR, and you see the vertical mullion is fine, but horizontal mullion is following this beam. So we need to do that. How to do that particular thing? So I'll just go to planes level, select this particular section, and just flip the direction slightly. Just take it inside. Okay. And then from our RP reference level, I will just drop this reference level and just say that PK, pick a plane. Press tab and pick this particular plane and go to that particular section. So R enter. You have this curtain wall. I will just select this and HI. No, but if I'll HI, if I'll hide, isolate it, then I'll not be able to have the reference of this particular place where to put the curtain grid. So with this, I'll just say that curtain grid, and first I'll decide this 1.6 and 3, 1.6 and something like almost 3. Okay, so the vertical divisions, oh, so many vertical divisions I don't want, sorry. I just want curtain grid and 1 foot, 4 feet, 1 foot, and approximately 4 feet, 4 feet. Yeah, that's fine. So that decides the horizontal divisions HH. Now the vertical divisions. Now the horizontal divisions. So for that purpose, I will just try to match this 1, 2, 3, 4, and that's it. I will just select this particular curtain wall, HI, and go to mullions. And I will also have the mullions for the staircase. See, 1.5 cross 2.5 rectangular mullion staircase, and just say that all grids and snap it. Okay, perfect. HR, just go to 3D. Wow, clear? So this is how you create this interesting curtain walls and a box wall hosted with this particular curtain walls, following the configuration of this particular beam in creating this facade. Now I'll just go to plinth level. We create need to place the bricks jali screen. So I'll just say that wall drop down, and I will find this curtain wall terracotta jali screen 1 feet. Yeah, 1 feet. This is referencing a family terracotta 1 inch, 1 feet. Fixed distance is 1 cross 1. So now I will just snap it from this face. Mm, Let me just say that wireframe HC height category, and let me just make this drawing a little bit clear. And wall, and just start it from here to here, and it will get inserted inside this wall. Oh, see, can't make. Why? Mm, Wall. Plinth level, I just say that not plinth level. Ground floor, zero up till slab top, and zero that as well. But why it is not creating? Let me just select a round figure, 7 foot. Yeah. Okay. What did it create? Yeah, fine, perfect. So this is a nested and embedded family terracotta tile, 1 feet. If I just said this pertains to parametrics. So this is a generic file which is made by extrusion. This is one single module which is getting repeated. If you want to learn all this, then kindly enroll for this particular course. So with that, you can create such curtain walls, and I will just go to plinth level and try to snap it on this face. It will get joined with the corresponding wall, creating a warning or an error. So automatically, because that is a curtain wall, this is also a wall. So I'll just say that delete, and I'll just say that disallow join, and then I will move this part to this part. Yeah, fine. Just need to do that particular thing, that is disallow join, and this I will just change it to input. Mm, yes. So I will just move it from this point to this point. Perfect. I still need to drag this a bit over here. What is the dimension that it create? Oh, that is a mm, 10 foot. Let's make it 12 feet. Again, that will get flushed, joined within that particular wall. We just need to move it. Yes. Yeah, fine. So here, the round figure 12 feet is coming, so that's fine. I need to just say that CS and create one from this point to roughly this point. Cancel. Not creating. Maybe from here to here. Okay, let's make it 3 foot round figure. Okay, and just join this particular thing to here. You have to make certain computations for this particular thing. That's the only way out. Yeah, fine. Oh, up till slap top. Done. Fine. We can reduce this to 11 foot if we want. 11 foot. Then move it from this point to press tab. Yes. Oh, that's better. Perfect. Fine. So the Jali screen has been created, and this washroom areas has overlooking into this particular duct or this courtyard or whatever. So in that case, you can select this all this wall 1, 2, and 3, and just gain a unconnected height to 15 inches, and then host a piece of glass or anything there. Clear? Fine. Now let's begin the openings, wherein this too is going to be the main highlight of this particular entire exercise, the tutorial and project, where we will lay this particular interesting curtain wall. If I just select this SA and HH, you see this is a dining area. This is a dining area, and this have a full corner glass. Okay, and likewise, this is also the corner glass. And this too, select this SA and HH. Interesting modeling. Okay, see, so the living room and dining room has semi-open spaces. At the same time, it spills out into this particular swimming pool area and garden area, and it has partial visual partial visuals between this particular living area, dining area, and this particular outdoor spillouts. Fine. So this is going to be an interesting modeling part. So just say that HR and just try to follow it. It's going to be a little bit tough, even for me. So this is curtain wall, balcony, corner glass. What is the height of this? 9 inch unconnected, 2 feet 3 inches. Fine. So let me just go to first floor. I should have done this particular thing earlier, but I just forgot. So wall and drop down and uh, curtain wall, balcony, corner glass, 9 inch, or what is the height of the plinth? I don't remember. 15 inch and unconnected, 2 feet 3 inches. One, two, and here we will have the flush. One, two, and three. Just watch. Yeah, perfect. Now let's come to not first floor, plinth level. And here, now, first is that I want to make you understand that what is a curtain wall. A curtain wall is a wall that references a curtain panel within its embedded family. The curtain panel is embedded within its core family, and then it is referencing a piece of glass and mullions. So if I just take you this particular curtain wall that comes with Revit, not this curtain wall storefront. So you see that if I just snap it from plinth level to first floor and zero, I'm just making you understand the basics and fundamentals because the curtain walls which I have designed are quite a bit detailed. It is not There's no time to explain each and every parts and pieces of that. So now you see that this particular curtain wall, when this particular curtain wall is drawn, you see this line of action. It is drawn at some distance. The piece of glass it is referencing, if I just select this and go to edit type, system panel glaze, it is referencing system panel glaze, okay, which is referencing at some distance from the line of action. Okay. At the same time, if I go to edit this this particular thing, see system panel glaze. If I just go to edit type, it has this offset parameter. So that's why it is referencing at some distance. It is referencing the material of glass and thickness of this is 1 inch. So this is the offset parameter which drives its location. But at the same time, it also has this mullions. It also has this rectangular mullions. Let me just take you to this particular architecture and mullions. And under that, let me just show you this particular simple mullion family that comes with Revit. See, this is the family that comes with Revit, 1.5 cross 2.5 rectangular. All this I have duplicated for different types of curtain walls. So what we need to manipulate within this is edit, and this also has its offset parameter, which decides its location from that particular piece of glass and that construction line. Okay, offset parameter and its thickness, and width on side one and width on side two. So all of this you need to be fundamentally pretty much clear. Okay, then only you will be able to understand what I'm going to do next. So I will just go to this particular HR, and let me just go to, sorry, not HR, it's the height category and height category. I want the drawings clear. So if I just go to this particular drawing, this is floor, sorry. Then you have this one, two, and three walls. Okay, I will, you see that this is the wall. I will just come here to modify. And in order to have the corner curtain wall, the process that follows is that you need to go to wall join and disallow this join and disallow this join as well. Let's go to 3D. So see here at this face, this particular join condition has been disallowed. Okay, I will just come here and RP and RP reference planes. Snap this over here. Oh, sorry. Press tab and find the snap point. Press tab and find the snap point. this exterior and this exterior. And this is how you have to disallow the joint and separate the walls in order to host the corner curtain wall. Let's go to 3D. Okay, so there's a joint, but just showing a different face of that particular wall. Okay, it is not referencing this paint. If you want, you can just go to wall paint and plaster. Apply this to this face and this face as well. Okay, done. Okay, with this now, I'll just this particular thing needs to be joined or what? Yeah, this was not joined, I guess. Okay, fine. Let's just ignore that for now. I'll just go to plinth level and then let's say that wall. And from drop down, I will select corner, curtain wall, dining, corner glass, louvers, vertical. Because louvers vertical. And this is just referencing this particular basic wall, glass dining, corner, which is nothing but if I just go to wall and drop down, dining corner, yeah, glass dining corner. It is just a basic wall which has just been given a thickness of 1 inch and a material of dark glass. See, this is just the material of the dark glass that it has been given. It is an existing material of Revit, dark glass, and the wall has been converted into a piece of glass. Okay, the purpose of that is that I will just create this particular thing from this point to this point. Plinth level highlighted wall overlap. Epic automatically embed is checked on or what? Oh, this is the wall, and this is the wall which is referenced within that. But we need to host this dining walls, corner glass, louvers, vertical, and plinth level. And I'll just give it an offset of 3 inch up to second floor, not second floor, first floor, lower terrace, minus 18.5 inches. That makes it unconnected height 8 foot. Okay, and I will just start from here, 1 and 2, and select this and 3. So see, the corner glass has been created. With this, I will just select this particular thing and snap it till this point. Okay, perfect. Select this point and snap it till this point. Perfect, absolutely perfect. And with this, if I just go to 3D, what you'll notice is that we have created a corner glass along that 3 walls, along that junction. I'll just press tab, move it from this point to this point, move it from this point to this point, and move it from this point to this point. Okay, now along this particular curtain wall, I want to place certain vertical mullions. So that's why I have given it a name, curtain wall dining corner glass, because of the corner junction with louvers vertical. Okay, so how will I do that? So select all this particular curtain walls and I select, and then I'll just come here to architecture tab and curtain grid. I will just roughly place one over here, one over here, and this cannot be so long full glass. So 3 foot and couple of them. Let's say that 3 foot from here also. Let's keep it 3 foot 6 inches. Just change this to 3 foot 6 inches. Yes. So still I need to create one curtain grid, and let's just try equidistance. Yeah, fine. Okay. And this, I guess that this particular, I will just change it to 9 inches. Okay, fine. And the same way, select this architecture and curtain grid, 9 inches from here and 6 inches from here. That's perfect. Now I have to host mullions onto this. So which mullions? So for that, I will just come here to mullions, and if I drop down, you will have this mullion already manipulated and designed for this particular dining area. Where is it? Dining area lowers vertical, horizontal, vertical. Where is vertical? Yeah, dining lower 1.9 cross 5.9.5. 1.5 is a thickness, 9.5 is a depth. Dining lower vertical, and if I just go to edit type, and as I said, I have manipulated this particular offset parameter depending upon the thickness of the wall and depending upon the thickness of this glass. And this is its own thickness, 1.5. 3/4, that makes it 1.5. Fine. This is the thickness, this is the width, and this is the offset parameter. Okay, and with that, I will just 1 and 2, and you see it is perfectly snapping along the width of that particular wall. This 1, 2, 3, 4, and 5, 5 and 6. Clear? So we have posted that particular wall, curtain wall with vertical mullions. Now I will just go to plinth level, and herein I'll just say that wall, and this time I will just select this curtain wall dining corner lower horizontal, which again has the system family to empty. This time we are not referencing any glass, but we are just referencing the louvers, which had also been manipulated 0.5 cross 6 inch for dining louvers horizontal. At the spacing should be 4.5 inch equidistant. Okay, and I will just say that okay and select this and just snap it from this point to this point, from here to this point, and from here to CS, from this point to mm, plinth level. Sorry, the CS, that's great similar, and this point to this point. And if you just watch this particular thing in 3D, it's quite interesting. See? Okay, clear? The spacing is 4.5 with this. Clear? So this way we have created this. Now the same thing will come here as well. So plinth level, and I will just come to this particular face and wall and curtain wall living louvers vertical. Where is it? Louvers vertical. Yeah, curtain wall living louvers vertical. All of them have been given the different name because everywhere the height and the width will be different. So the quantification will be different. So that's why the different families with the same dimensions has been created. So curtain wall living corner louvers horizontal, not horizontal. So, yeah. Curtain wall living louvers vertical. Okay, and plinth level 3 feet and 1 feet. Yeah, that's fine. Snap from create from this point to this point. Okay, and somewhere from this point to this point, HL, and let me just snap it here. Okay, in this case here. Okay, this is perfect, and this also. Okay, fine. I'll just select this and move it to the external face. Snap it, press tab and move it from this to the this particular face. Now I will just come here to 3D. Perfect. I'll just select this 1 and 2. See, it is exactly putting a bed. This was just a random rough, but it perfectly popped out at the place it was supposed to be. That's fine. Paste, and I just selected levels and just place it to first floor. Wow. Okay. So the division has been created. Now we just need to, sorry, the curtain wall has been created. Now just we need to create the divisions. because this much full glass cannot rest on its own, like just like that. So select all of this and just say that HI, uh, curtain wall, SAHI, because this is a different family. So curtain grid, maybe say that 2 feet, 2 feet, 2 feet, 2 feet, and here 1 foot 6 inches, 1 foot 6 inches, and 1 foot 6 inches, and just go to mullion for living vertical. The same family. So this is the same family, but just renamed. One, two, three, four, five, six, seven, and eight. And just press HR. Wow. Perfect. Now we need to create the corner. So for that purpose, I will just go to, let me just hide this AutoCAD drawing wireframe, HL, and wall. But this time, curtain wall living corner, lower horizontal. Okay, 3 inch. This constraint, I will just change it to second floor. Start drafting from this point to this point and press tab CS from this point to this point. Uh, let's check out in 3D. Oh, wow. See, perfect, clear, fine. Now is the interesting and maybe say that toughest part, wherein we have to create this curtain wall as a piece of glass with no mullions, just the divisions. Okay, and here this is a curtain wall door. So this would not be difficult, but this is doing too. So for that purpose, what I will do is that the first step that follows is that modify wall join, come to this and disallow. Again, RP, snap it, snap it to this face. Go to first floor. Same, disallow, snap it to this face. Okay. With this done, now I'll come to plinth level. First check in 3D. Yes, everything is perfect. Only thing is that wall paint, plaster applied to this face. This face, anyway, it's going to be hidden, so not important. But now I'm just first going to create a rectangular cut, which we created here for this particular box wall. But this time with a different method, wherein I'm just going to use this curtain wall, but that curtain wall should be empty. Curtain wall living corner empty, which is not referencing any piece of glass or any family. It is empty. Okay, so that I will just create from somewhere this place to this place. Sorry, create it from here to here and then from here to here. Okay, select this and drag it outside. Highlighted elements. Okay, 3D. Okay, but the constraint of that should only be till first floor. So that would not take away the layer of plaster from here. Okay, this I guess should be till this point. Yeah, because here there will be another curtain wall. Now, what next? We have created an empty system. Select this, copy to clipboard, align to selected levels to first level, lower level. Okay. Fine. And now we have to create that particular corner curtain wall. So plinth, wall, living room, corner curtain wall. Yeah, living room, corner, glass, which is referencing this particular piece of glass, basic wall, which has been converted into piece of glass. And then I'll just change this to slab top. Oh, sorry, not slab top, second floor. And start from this point, flip. By pressing space, you can flip. Sorry, it's supposed to be started from here. Flip one and two. Okay, so that particular corner glass has been created, going from plinth level to first floor. And then, just as we made the division, curtain wall division for this box wall, you have to do the horizontal and vertical division for this as well, depending upon the, let me just randomly, but this are just going to have the divisions. There will be no mullion host set to this. So let me just randomly place a couple of divisions, 9 inch, and this, let me place horizontal also. Yes, one and two, and this should match. Okay, roughly, I'm just trying to, sorry, cut in grid, and here on this page, H, HL, yes, and here, uh, let's first place it here, and then, yes, the corresponding segment over here. Okay, R enter. Okay, perfect. If you want, you can place divisions according to uh, your, let me just say that, curtain grid, and one more, I need to place it here to match along this H, HL and along this segment. Okay, R enter. Where did it create? It created in the wrong direction. Why is this not continuing? CS? Yeah. Okay, perfect. Fine. And R enter. The same way, this is concluded. I have made them here. Now I need to check that curtain wall living empty HH, and this is a full curtain wall. Okay, so yes, I just need to go to first floor, this plan, and from here I'll press tab until I find empty HR. Where is the empty family? Curtain wall corner empty. Or let me just wall and let's create that. Why waste time? Curtain wall, living corner, empty 3 foot and second floor, not second floor, first floor. And create from here till this point. Select this. Yes. Select this. Copy to clipboard. Align to selected levels up to first floor. So the cut has been created. Okay. Now, which we need to know, host the piece of glass. So for this, I will just say that this same family, curtain wall, living corner glass, CS, that is create similar. And the constraint should be, yeah, fine. From here till here. Okay, let's go to 3D. Fine. And you can put the divisions. And once place the divisions, I can just say that I'll just show you for this lower part, curtain grid, and I can place somewhere over here depending upon the height. And then select this particular panel, unpin it, and change it to glass, curtain wall glass. Where is it? Mm, it should be somewhere. Why could I not find it? Curtain wall glass. It should be here only. Yeah, sorry. Here it was in drop down. Curtain wall single glass. Yeah. Okay, so this is how you can manipulate. And if you want, you can select this and just give it a height of, let's say that something like 7 foot 6 inches. Okay, fine. So that is how I have manipulated here within this screen. I guess that the curtain wall which I selected placed here was too long, too wide. Sorry, not long. It should be only 4 feet. That's it. And the shame should be reflected on the top as well. So just delete this, select this, copy to clipboard, align to selected level up to first floor. Fine. Perfect. Okay. So we are done with the interesting facade, creating this particular thing. Now what left within this is to post the openings, and that would be very easy. The hardest part is done. Clear? Okay, let's just go to this particular project and check. Yes, this one curtain wall is left, and also this particular semi-covered roof. That's all, and this pergolas. Everything of this is also a curtain wall only, but that is a slope glazing. So let's first finish off with that before proceeding to openings. So I'll just go to this particular plinth level floor plan and uh, say that wall and a cut within this wall. Okay, let's just check how much is the. Oh, it is full. So I will have to come here, snap it till this point, this plaster layer. Yeah, and here too, snap it till you'll have to draw the reference plane in order to perfectly snap. Uh, yes, okay. And then this particular thing, this cut, rectangular cut, base offset, I'll just give it a little bit of offset of 3 inch and from top offset minus 18.5. Okay, and the same, I'll just say that copy to clipboard and paste align to selected levels to first floor also. So that would create a cut. Oh, you cannot copy the cut in this case. So maybe I will just go to first floor as well and go to architecture and cut. Oh, they copied in this case. Why they're not allowing in this? I don't know why. Okay, this press tab, uh, press tab and minus 18.5 and base offset of 3 inch maybe. And this time the base constraint would be, yeah, that's perfect. Just snap it. Yes. And snap it here as well, roughly. Okay, fine. So the cut has been created. Now we need to host the curtain wall over here. That would be wall and curtain wall, which is that courtyard, curtain wall courtyard. Fine. So that is hosted with the glass courtyard. And then once placed up till second floor, yeah, fine. I'll just snap it from here till this point. And when once placed, you have to divide this particular with the help of curtain grid and create host mullions like this. And also this particular door. These are the curtain wall and glass slit. Okay, let's just do it. I will just right now, just to save time, I'll just say that curtain grid and I will just randomly 4 feet maybe and 4 feet here as well. And then the horizontal ones, it is not highlighting the horizontal divisions. Yeah, here it is. One over here. And it is not exactly, it doesn't tallies, but roughly it is placed. Let me just say that I'll just change it to 2 feet maybe. No, but this dimension did change. I'll have to select this grid and it didn't perfectly cut or what? Yeah. So this I suppose should be something like 7 feet 6 inches, 8 feet, 8 feet 3 inches roughly. Yeah, fine. Okay. So that is how I just select this and HI. Fine. And there is a problem, but that's fine. Mullions and curtain wall glass slits, curtain wall and glass slits, all mullions, and just snap it. Okay, done. You can host. Press tab and select this particular and unpin it and just host glass onto this. Curtain wall glass, where is it? This. Okay, so this is how you can play around. So I will just say that HR, and in this case, the curtain wall is going inside. Oh, that's the problem. Just snap it till here. Disallow, and then snap it till the preferred. Uh, why is the glass not changing its location? See, this is the entire curtain wall, and just bring it to here. Let me just say, maybe I need to unpin and then push it. Disallow, and then yeah, but why is this glass not? Hmm. Somehow I have placed this particular glass wrongly. It has maybe modify and just say that disallow, disallow. Okay, perfect. Yeah, fine. So this wall joints are a little bit tough and a little bit weird. Okay, fine. So that is how you have created this particular curtain wall, and now we have to create the sloped glazing. Sloped glazing is nothing but the curtain wall along a roof at various places. Okay, so for that purpose, I will just go to the first floor plan, and here we need to create it. But what is the height for that? What is the so for that particular thing, I need to say that the range level, just change it to plains level. Okay, so we can see this. I'll just go to architecture and roof by footprints, and here I will just say that slope roof for entrance, not this, sorry, plinth floor, semi-covered entrance deck. semi-covered entrance deck, which is with this grid one, 15 inches, 15 inches. It is referencing this particular mullions. Okay. So again, I'll just come here and snap a simple rectangle. Just say that define slope unchecked and just say that finish. The grid, the curtain wall, the slope deglazing has been created, but should be at exact first floor. Okay, and with that created, now I can just come here and change this to 45, 45. Perfect. Okay, so likewise, I'll just come here to first floor again, and then here we need to create roof by footprints, drop down, semi-covered, spill outs, plinth floor, semi-covered spill outs. And for that purpose, I just go to come here and first is this, I need to create this. Let me check where it is. No, it is here only. Fine. So rectangle, drop from here to here and from here to here. Okay. And just take that define slope and check. Get rid of this lines, overlapping lines, and just say that TR and have a closed shape. Okay. And just say that 0 and just say that finish. Zone attach. 3D. Okay. Press tab and select that particular curtain wall. Just drop down. Uh, Press tab until you select that curtain wall and just change this to grid 1 and grid 2 to 45. Okay, done. And then just go to length floor, place the circular columns along this, which will be the architectural circular columns. 12 mm, 12 around, okay, fine. From height up to first floor, that's fine. This is too huge. 6 inch would be better. Oh no, let's go with 12 inch. 1, 2, and maybe 3. 3D. This I suppose that we don't need. One, just one, and two. Just give it a top offset of minus something like 3 inches. Yeah, fine, clear. So that is how we will place the slope glazing for this area also, the entrance pathway. So let me just go to plinth level. We'll place that in first floor only. So here only, so not for plinth floor. And wall and curtain wall for entrance pathway. Curtain wall for entrance pathway. Where is it? Come on. Oh, sorry, not curtain wall. Roof by footprints. Sorry, first floor. And I'll just take this particular thing from here to here and from here to this point. And select this, define unslope. Check. Get rid of this TR, join this to this, join this to this. I have a closed shape. Maybe till here, something like this. Where it is exactly till. Hmm, it is till this point. Yeah, fine. So plinth level till this particular column. Yeah, and just say that base level to be first floor, and that's fine. And just say that basic roof wall. It is supposed to be semi-covered pergolas for entrance, no, not pergolas, sorry, plinth floor, semi-covered entrance deck, plinth floor entrance deck, it should be. Plinth floor, semi-covered entrance deck, entrance pathway. So sloped glazing for entrance pathway. Sorry. Yeah, so fixed distance 2 feet, 2 feet, and this particular mullions referenced. Okay, and just hit the check box. Okay, and let's see. Yes, it's exactly created at the place that it's supposed to be. And select this and just change this particular 45 and 45. Yes, so this will take a bit of time computing it. Yes, finally. And from this particular thing, I will just select this. This is nothing but just a edit in place generic model, and it is a piece of extrusion. See, it is just an simple extrusion which has been created at this level. I don't want to waste time on that. So I will just copy this, Control C, go come to print level, and Control V, can't copy between family and projects. So I need to finish this and then Control C, come to plinth level, Control V, okay, and place it. But it got placed at which level? I need to check where it got placed. Mm, where did it got placed? Oh, it got placed at the wrong place. Shift it to first floor. Simple. Okay, and just come to first floor plan and move it from this point to this point. But it's not matching somehow. So move it from this point to this point. Okay, maybe the curtain wall will only, yeah, the slope, the glazing will only build the edit footprints till this point only. Yes. Okay, and finish. Sorry, done. But still, it is not putting a back perfect place that where it is supposed to be. This is first floor, and this is also first floor, lower terrace. So, what is the problem? Is this a place at some height or what? No, just roughly give it a, or let's just select this and give it a height offset of -2 feet. Yeah, perfect. Okay, fine. And go to plinth level and the circular columns. So again, architecture, column architecture, and that same circular columns, just place it along one and two. Oh, okay. Wireframe, and just select, or as just select this roughly and copy it from this point to this point, this point, here, and here. Right now, I'm just randomly placing it. Let's check in 3D, SA, and just deselect this by cross window. And one, two, three, just give it a -2 feet. Okay, and this needs to be placed on the inside edge. Move it. Yeah. And just CO, copy it from this point to this point, from this point to this point roughly, and from this point to this point. Select it and adjust it a bit. Okay, 3D. Fine, perfect. Okay, so we are now done, and we can now focus and proceed on further and concentrate placing the openings to this particular hosting the openings to this particular project. One column I suppose was here also. Go to top and CEO, and this is not actually important, but Control C and put it somewhere over here to support this CC. Okay, and this should base constraint, we should be ground floor, and just get rid of this offset. Yeah, fine. Okay, so that concludes this particular curtain wall and slope glazing chapter. Now we just need to quickly finish the modeling of this by placing the openings, and that would be very easy because I just have to, the openings are ready. So planes level and CC. Let's bring life to this particular project. Type B. This is the all the parametric openings, all the parametric openings, which has this sash copy all the editable parameters. This will just take a bit of time. Those are the instance parameters. If you want to learn this parametric modeling, then you have to enroll for this particular course, and I do teach them. Okay, clear, fine. So what is, let me just have a glance of it. Oh, we forgot to have a cut here, but that's very easy. See, just select this any of the curtain wall and just say that edit profile, and within that just create punchers, something like this, and something like this, random, and just say that finish. Now you can host mullions to that punchers. I will just go to mullions, architecture and mullions, and living room thicker. Yeah, living room horizontal thicker. 1 and 2, 3, and 4. 1, 2, 3, and 4. Okay, so this is how you create punchers within this particular opening. I forgot to show you that. So let me just say that R enter, and let me just check. Okay, these are the, again, the parametric openings. Cell height is 15 inches. These are the regular doors. This is the window that comes with Revit. This is the parametric angular curtain wall, 1.3 and 6, and all of this is 15 inches. Okay, one more curtain wall over here. Oh my God. But this time I am just going to say that Control C and go to this particular project. There is second floor, and I don't think that I'll be able to host that. Fingers crossed, and move it inside the wall. Oh, fine, perfect. Revit is really amazing software. Fine. So the same way we will create this, but I just forgot. Anyways, so let me just go to plinth level and HL and WN. Where is the parametric window side light and transom? 15 inches of cell height. Okay, and just place one here. Okay, I need to see the AutoCAD drawing. Oh, but AutoCAD drawing doesn't have any openings placed. I am just randomly placed according to. Okay, here it is. So plinth level, select this and DM. Okay, wall, angle curtain wall. Again a parametric stuff. Curtain wall angle, which is referencing this angled curtain panel. Okay, so 6 inch. What was the constraints? Unconnected, 6 foot. Unconnected 6 foot, and it should be the round figure. Okay, flip it 3D. Okay, wow. See, clear. And go to plinth level. And here we have this CS, create similar, place it, and just say that copy to clipboard, align to selected levels to first floor and to second floor, 3D. Okay, perfect. But I guess the cell height for all this three will be 15 inches. And there is one instance parameter show front shade. I'll just keep it off because we are going to have an elevation treatment over here on this face, these two faces. They are here also. Yeah. So let me just go to plinth level and just say that CS create 15 inches, copy to clipboard, align to selected levels, first floor and second, 3D. Okay, perfect. Only thing is that the source and shape parameter should be off. Okay, and let me just check. Yeah, that is perfect. Fine. Here there is a door. So DR, simple, what do we say? 2D, 3D style and rail. Select this, change the 3D swing angle to 45. Just give it a cell height of something random, 3 inch. Okay, clear? Likewise, also we will place doors over here. That would be door, sliding, folding, parametric door, sliding, folding door, type B, one over here, and So this take a bit of time. It's a parametric door, complete parametric door. So yes, and one over here on this wall. Let me just shift it a bit. 3 inch of cell height and 3D awning and casement 45, 45. Yes, let's open it. Okay, and also this will not have a sunshade. So on first floor, I will just copy this particular door, CS, and the same door, I will just place it here. Okay, cell height 3 inch and casement and awning 45, 45. Yeah, fine. That's okay. What else? That particular door is here also, I guess. Okay, yes. And here also. So let's go to planes level. Oh no, sorry, not planes level. First floor. Copy to clipboard, align to selected levels and to planes level. And insert outside hope. Yeah, okay. The wall on that particular floor is not at that. So just say that CS, go to planes level and paste host that particular door on by snapping to a wall. And here too, but the bigger size of that. Okay, yes, 3 inch and casement and awning 45, 45. 3D. Okay, absolutely perfect. 3D, let me just watch this project. Yeah, fine. Here also we have an angled curtain wall. What are the constraints? Let me just check. Plinth floor 4 feet and unconnected 4 feet. Yeah, fine. Okay, just select this angle curtain wall. CS, plinth floor 4 feet and unconnected also 4 feet. 4 feet. Just create one from here till should be a round figure and a multiple of 2. Mm, okay. Oh, it got created. Fine, perfect. Hmm. What's left? Actually, a lot of things left. For this elevation treatment, we will do it at last. First, let me just complete placing the openings. So, door, and here, did we construct the internal wall? Oh, no. If we don't construct a wall, we'll not be able to place the openings. So that's fine. I'm not ignoring this particular part. But here, door, and this, uh, let me just place this from first CS got inserted in the wall. CS and come here to plinth level, place it. Okay, and the same curtain wall which we have, angled curtain wall we have here, we also have it on this face. So just select this, but not be able to visualize that particular thing. I just say that CS, uh, how to place that here. I'll have to change the view range, cut plane to let's say that 6 feet. Okay, CS and just create that from here to here. Perfect. Press tab and invert the direction. Perfect. 3D. Okay, clear. And which windows are there on this particular face? Here it is a bigger size. See, the size of the window here is bigger. It's 1.3 and unconnected. Okay. And we have a corner curtain wall over here. Corner curtain wall. Oh, it's actually a parametric corner window only. Fine. So we don't need to worry. Okay. So here I will just change this particular, go to plinth level and just reduce the size to something like 10 foot. Shift the direction. I mean, drag it in order to place the corner curtain window and WN. That is also a parametric window. And where is it? Corner curtain window. Where is it? Let me just type corner. Yeah, corner window. Type one. Just place it first and change this to type B, smaller size. Then only that particular window will fit and move it. Okay, done. Perfect. Where is the window place? Plinth level 15, I guess. Frame material sash 3D. Okay, perfect. Fine. Then come to here and where is the window? Yes, just say that CS create similar and there are two of them or what? Yes, two of them. So come to plinth level. This window CS that is create similar. Place one here and place one over here. Okay, a door stepping outside, simple door, 36 or 86. Or we can just use the parametric door. Decorative. Okay. The inside door could be the simple one. This 36 cross 84. Mm-hmm. One, two, three. Okay. Same. One and two. Common toilet. We'll have a wash basin here, so let's flush it. The swing on this end. Okay. Then we will have this decorative here for bedroom. The swing is not being seen. Maybe 3 inch. Actually, all this particular doors SA should be up till 3 inch finished flooring. Then only it will be perfect. Yeah, fine. Perfect. So, is anything left now? Actually, a lot of things. First floor, I'll just get rid of this to none. Okay. So the same way, you have to put the doors and windows to this particular floor area. Right now, I'm not wasting time on that. Here too, and here we have already placed, I guess. Okay. So this part, I'm just ignoring it. Uh, you can just actually go to plinth level and using the functions of Revit, you can just select this. Copy to clipboard, align to selected levels to first and second. They are the same doors. See, fine, perfect. Okay, now what left? This got ignored or what? Yeah, this and this also copy to clipboard and align to selected levels first and second. Okay, there is no. Okay, on first there is that, but on second there is no. So that's why. Okay, fine. Plinth level and okay, let me just go to 3D and check. 1 and 2, 15 inches. Copy to clipboard. Align to selected levels to first floor. Okay, fine. Let's ignore that. Here, there is a door, there will be a staircase, but right now I'm just ignoring it. Let me check 3D. What does it says? Oh, there is one window over here, casement double, and this is okay. And also the louvers, and also this, which we need to sort out. Fine. I'll just come here and WN window casement 57 cross with a sill height of 3 feet maybe. Okay. And window, box window. Yes. Okay. Clear. So here we have louvers. So this particular portion is interesting. Wherein if you see that there is a curtain wall. This is a curtain wall. Again, curtain wall washroom slit, which is joining with this particular curtain wall. At the same time, the layer of plaster is not eliminated. So this again is a interesting, which I'll just show you for this ground floor. Okay. Before that, let me just go to plinth level and WN and louvers, window louvers. Where are those? Window louvers. Yeah, here it is. 24 cross 24. Cell height right now. Let's just, in order to see this, let's place it here. Yeah. And then just shift it to 6 feet. And that same copy align to selected to first floor. Match the lintel. Okay. That one, just press space and revert the direction. Now we have to create this particular corner window with this particular louvers. So again, I'll just say that let's say that CS, let's create similar, and I'll just randomly place a louver over here first. Let's go to 3D and I will just shift this. Okay, and move it and shift it to this location. Yeah, fine. Okay, and this should be of the at right now at just 3 foot. Where did it go? Plinth level, cell height to 3 foot. Yeah, that's fine. Okay, view range, I must have changed. Yeah, fine. So 4 feet 6 inches. Okay. Now I will just let me just check which window that I use is it's a which curtain wall it is. Yeah, curtain wall washroom slit, which is referencing this glass. Okay, so just go to 3D wall. Sorry, not 3D. Plinth floor plan and curtain roll washroom slit. Yeah, the same family, which is referencing this glass from washroom slit. Plinth level 3 foot and unconnected height 2 feet. Let me just draw randomly from this point to this point. Just shift. Yes, join here. Okay, and the same window I will create here as well, roughly. Okay, and this should also come out. Yes. For now, I will just select this, press Tab, and move it from this point to this point. And likewise, I will press Tab and move it from this point to this point. Once done, I will select this, snap it, select this, and snap it. Snap it. Yeah. So the corner window has been created with that cut. So if you just go to 3D, see that that portion has been created. What we just need to do is that select this and just change this to 6 foot. Select this and this, both of this curtain wall. Also change this base offset to okay, and that particular window has been created. That same thing, if you want, you can just say that copy to clipboard, align to selected level, but that will not cut, I guess. In order to cut, you need to create that same window at that portion. See curtain wall, copy, align to selected levels first. No, it doesn't cut the wall. So you have to do the same modeling on this particular floor above. Okay. So now what left is this two elevation treatments, which I need to do, and then rest everything is complete for this particular project. So that is very easy. That is nothing but just a component, model in place component. See, this is it. Edit in place, and it is just a simple extrusion. A simple extrusion, which is not taking into consideration this windows, and at the same time, this flower bed has been laid. Okay, so I will just show you for this particular one portion. The same applies over here also. Okay, so you see that this is the extrusion, and this particular thing, let me just say that delete and delete. Okay, so this is at some, okay, the height of 2 feet has been taken into consideration. Yeah, fine. So let's go to this particular project. What is the name of this? I forgot to check that. Walls 1. Okay, that family would be existing there also because I have transferred the project standards. I will come to plinth level, draw a reference plane RP. This is conflicting with the wall. So come to first floor as well, 1 and 2. Okay. So draw a reference plane RP and take the section over here. PK, pick this plane and go to that particular section. Okay. And then I will just say that architecture component model in place. Let me just see that under walls, do we have a generic model walls 1? Let me look for it. Walls 1. No, walls 1. No, it's not there. Fine, forget it. So I will just component model in place. And since it is an elevation treatment, so walls, call it elevation treatment ET. So you are in a drafting mode. So create one extrusion, rectangle, right from here till this point. Snap it somewhere. Sorry. Okay, so just give it a offset of, let's say, that 1 foot on this side and 1 foot on this side. Join this to this, join this to this, and also just take this line to the bottom. Okay, delete this, exclude this particular windows, but with the offset of 2 feet from this, or not 2 feet, sorry, maybe 1 feet is enough. Yeah, and join for the space for the flower bed. Select this, press tab and select chain of lines, copy from one point to another, from one point to another. Okay, but this, I guess, I need to split this, join this to this, join this to this, again split it, join this to this, join this to this. Okay, extrusion start 0 and extrusion end, maybe let's say that 15 inches. And the material, I will just give it an existing material of elevation, elevation treatment, not this. Which was that particular material? Oh my God, a lot of materials over here. So let me just come here, edit in place, select this cladding, cladding wooden. I cannot copy between projects, I guess. So come here, not 3D, come to section. And can I paste? Yeah, fine. So it is accepted. So cladding wooden, yeah, cladding wooden planks. This material has been applied to it. Okay. So it's the valid material what? Cladding. Paste. Oh, wooden planks. Okay. And extrusion start 0 and extrusion end 15 inches. Let's see that where did it extrude? Did it extrude in the perfect direction? Yeah. Perfect. Okay. And then just roughly adjust this height in order to create certain void forms like this, the one that I've done in the project. And just say that CO 1 and 2, just move it, move it, move it. Yes, just say that finish. And now we have to create the flower bed. So create one more extrusion. That would be this. Extrusion start 0 and extrusion end. I'll say that 2 feet. Okay. But that should be the applied the material of black stone. Okay. And once created, now you have to create a puncture within this extrusion in order to create a flower bed. So what we will do, we will go to, this is on second floor. So second floor, second, no, first floor. First floor, this is that particular flower bed. I'll just say that create and void form, then void extrusion with the offset of minus 2 inches maybe on this rectangle and minus 2 inches from this point to where is it? Maybe let's select this face, this point to this point. Okay, and go to 3D, finish, and roughly adjust that. And this should be little okay. This would create the flower bed. Okay, and then just click cut, select this and select that. Done. Okay. Once that for this particular portion, just copy it to rest of the other windows. Fine. So that is how you create the elevation treatment here in Revit. Okay, fine. So what left within this is now how to create the site and add components to this particular model. For example, if you just see here, I'll just say that HR. Sorry. And if I just click this bulb, where is the bulb? Let me just, yeah, and open the 3D again. Okay. Sometimes this bottom taskbar visibility settings disappear. So I'll click this particular bulb, reveals 3D hidden elements. I'll just unhide in view by elements. This also, and this also unhide in view by elements. Okay, and just click this bulb again. So fine. So this site is loaded. So how to create this particular site component? It is nothing but a simple edit group, or let's say that ungroup. In order to explain you, I'll just ungroup it. So that is nothing but a custom model in place elements created. Let's hide in view by elements, this AutoCAD drawing. So that is nothing but just a custom element created with the help of this particular floor and this drafting tools. It is nothing but just a simple boundary and snapped, the lines snapped to this particular AutoCAD drawing and just place that particular floors with different materials. That's it. Nothing rocket science in that. This is also the same floor, pathway exterior, plains floor, and it is just following the boundary of the AutoCAD drawing. That's it. That is how I created the pathway and this water body and arrest everything. All the elements has been created with the help of that. Okay. And regarding this particular site assets, that is the human figures, the trees, cars, etc., where to load it from, I will just show you. And this is also a piece of extrusion edit in place. And just following the footprints of the floor plan, it is nothing but just a simple extrusion which has been given that material. See, extrusion start 1/4 and extrusion end 8 inch. It has been given this material of entrance pathway, the same material. And that is how the steps are created. Okay, now what to be shown is just this components that where to add this particular site components from. So for that purpose, now I don't need this particular project anymore. So I will just close it. No. And herein, I will just show you if I just go to component. This is already components are added here in this particular file. So I'll just open up a fresh new file, new and project, browse, default architectural template, and say that open and OK. So this is a fresh new project. It doesn't have any components added, but all the Revit file by default has certain components in them. For example, place a component. You see that this desk, then this parking space, then we have this couple of trees, one and two and bigger trees. Okay, and these are the components which are loaded. But let's say that you want to add certain other components. I'll just go to 3D, R enter. See, these are the trees Okay, you want to add human figures and cars. So where will you insert that or load that from? Just go to insert and load family. Under your this path and libraries, whether English or English Imperial, both the folders will have that US, and under that you have this folder entrage. Under that you will have this car, this female, male, semi truck, van, etc. All this particular assets which you require for the modeling purpose. CM, that is, you can create a female, you can create male, you can place different. Uh, Let me just change this to male. Yeah, okay, fine. And just like that, CM, you can also load this particular car and place it. See, okay. So let me just close this. No, okay. So to conclude, this was all about the modeling of the 3D interface of Revit, that how with perfect precision and joint condition you can achieve this particular model. But the point still remains the same, that what is the need of doing so much of hard work with the joint conditions in this particular Revit when you can create models easily in stipulated time frame with much less of efforts in Google SketchUp and other 3D softwares. So as I said in my introduction, the only reason is that this particular multidimensional software doesn't only models the 3D interface but also models the 2D interface, which gives us the scheduling, quantification, and each and every detail associated with our project. So if you think that this video was worth, then kindly enroll for this particular course and let's learn together and let's grow together. Bye everyone and all the best for your future endeavors. Bye.